everyone, welcome to the Data Analytics full course by Simplilearn. If you are looking to dive into the world of data and turn information into insights, you are in the right place. In 2024, data analytics is one of the most in-demand skills, with companies across all industries searching for professionals who can analyze and interpret data effectively. Salaries in this field are also on the rise, with data analysts earning impressive packages as they help businesses make data-driven decisions. This course will equip you with all the skills you need to start a successful career in data analytics.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
Also, if you are interested in a professional certification course in data analytics, begin your learning journey with Simplilearn and IIT Kanpur's Data Analytics Certificate course. Explore our learning management system, track your progress, and meet completion requirements. Learn to understand data and enhance your analytics skills through live sessions with industry experts, hands-on labs, and masterclasses by IIT Kanpur faculty. You can check out the link mentioned in the description box below and the pinned comments. Start learning today and unlock endless opportunities in data analytics. So, without further ado, let's get started.
Companies around the world are generating vast volumes of data every hour. This data could be in the form of log files, web server and transactional data, as well as various customer-related data. Also, data is being generated at a rapid rate from social media websites and applications such as Facebook, Instagram, Twitter, and WhatsApp. Companies want to use this data to derive value out of it and make business decisions. That's where data analytics comes into use. Data analytics is the process of exploring and analyzing large datasets to find hidden patterns, unseen trends, discover correlations, and valuable insights to make business predictions. Data analytics improves the speed and efficiency of your business. A few years ago, a business would have gathered information manually, performed statistical and complex analytics, and unearthed information that could be used for future decisions. But today, that business can identify insights on the fly for immediate decisions. Most organizations have big data, and many understand the need to harness that data and extract value out of it. So, they use a lot of modern tools and technologies to perform data analytics. Some of the tools I will discuss in detail later in this tutorial. Now that we have looked at what data analytics really is, let us understand the ways in which you can use data analytics. First is improved decision making. Data analytics eliminates a lot of guesswork and manual tasks, from choosing the right content, planning marketing campaigns, and developing products. Organizations can use the insights they gain from data analytics to make informed decisions, leading to better outcomes and customer satisfaction. It gives you a 360-degree view of your customers, which helps you understand their behavior completely, enabling you to better meet their needs. Second is better customer service. Data analytics provides you with more accurate insights of your customers, allowing you to tailor customer service to their needs, provide more personalization, and build stronger relationships with them. Your data can reveal information about your customers' communication preferences, their interests, their concerns, and more. It helps you give better recommendations for products and services. Next is efficient operations. Data analytics can help you streamline your processes, save money, and boost production. When you have an improved understanding of what your audience wants, you waste less time in creating ads and content that don't match your audience interests. This helps you optimize your campaigns, create better content strategies, and hence improve results. And finally, we have effective marketing. When you understand your audience better, you can market to them more effectively. Data analytics also gives you useful insights into how your campaigns are performing, so that you can fine-tune them for optimal outcomes. You also find out the probable customers who are the most likely to interact with a campaign and convert into leads. Now, let's discuss the various steps involved in the data analytics process. As you can see on the screen, there are 5 process steps. Now let me make you understand each of this one by one. So the first step is to understand the problem. Before starting with the analysis, you need to understand the business problem and define your goals. Asking questions at the outlet is vital because this would address issues such as how can we reduce production costs without sacrificing quality? What are some of the ways to increase sales opportunities with our current resources? Do customers view your brand in a favorable way? Answers to these questions will help you build a clear roadmap with lucrative solutions. Also, try to find out the key performance indicators and consider the matrix to track along the way. The second step in the process is data collection. After you have finalized your goals, it's time to start looking for your data. Data collection is the process of gathering information on targeted variables identified as data requirements. The emphasis is on ensuring accurate and right data is collected. Data collection starts with primary sources, which are also known as internal sources. This is typically structured data gathered from CRM software, ERP systems, marketing automation tools, and others. These sources contain information about customers, finances, gaps in sales, etc. Under external sources, you have both structured and unstructured data. So, if you are looking to perform a sentiment analysis towards your brand, you would gather data from various review websites or social media apps. The next step is to clean the data. The data which is collected from various sources is highly likely to contain incomplete, duplicate, and missing values. So, you need to clean these unwanted redundant data to make it ready for analysis. So to generate accurate results, analytics professionals must identify duplicate and anomalous data and other inconsistencies that could skew the analysis. According to a report, 60% of data scientists say most of the time is spent cleaning the data, while 57% of data scientists say it's their least enjoyable task. Now the fourth step in the process is data exploration and analysis. Once data is cleaned and ready, you can go ahead and explore the data using data visualization and business intelligence tools. You can also use various data mining and predictive modeling techniques to analyze the data and build models. You can use different supervised and unsupervised algorithms such as linear regression, logistic regression, decision tree, KNN, k-means clustering, and lots more to build prediction models for making business decisions. And the final step is to interpret the results. This part is important because it's how a business will gain actual value from the previous 4 steps. Interpreting the results will help you find unseen trends and patterns in the data and gain insights. You can have a validation check if the results are answering your questions. These results can be shown to your clients and stakeholders for better understanding and business collaboration. Now that we have looked at the various steps involved in data analytics, let's now see the different tools that can be used to perform the above steps. So as you can see, we have 7 tools including a few programming languages that will help you perform analytics better. Now let's discuss them one by one. First, we have Python. Python is an object-oriented open-source programming language that supports a range of libraries for data manipulation, data visualization, and data modeling. Python programmers have developed tons of free and open-source libraries that you can use. You can find many of them via the Python package index, which is pypi, the repository of Python software. Python provides the default package installer called pip or pip. Python has libraries such as NumPy for numerical computation of data, pandas to manipulate data on numerical tables and time series. Then you have SciPy for technical and scientific computations. It also provides scikit-learn, which is a machine learning library for creating classification, regression, and clustering algorithms. And finally, it also has PyTorch and TensorFlow for deep learning. Up next, we have R. R is an open source programming language majorly used for numerical and statistical analysis. It provides a range of libraries for data analysis and visualization. Some of these libraries are ggplot, tidyverse, plotly, dplyr, and caret. Then we have Tableau. Tableau is a popular data visualization and analytics tool that helps you create a range of visualizations to interactively present the data, build reports, and dashboards to showcase insights and trends. It can connect with multiple data sources and give hidden business insights and patterns. Then, we have a competitor of Tableau, which is Power BI. Power BI is a business intelligence tool developed by Microsoft that has an easy drag and drop functionality and supports multiple data sources with features that make data visually appealing. Power BI supports features that help you ask questions to your data and get immediate insights. You can also forecast your data for predicting future trends. So the next tool is ClickView. ClickView provides interactive analytics with in-memory storage technology to analyze vast volumes of data and use data discoveries to support decision making. It provides social media discovery and interactive guided analytics. It can manipulate huge data sets instantly with accuracy. Up next, we have Apache Spark. Apache Spark is an open source data analytics engine to process data in real time and carry out complex analytics using SQL queries and machine learning algorithms. It supports Spark Streaming for real-time analytics and Spark SQL for writing SQL queries. It also has Spark MLlib, which is a library that has a repository of machine learning algorithms, and then it has GraphX for graphical computation. And finally, we have SAS. SAS is a statistical analysis software that can help you perform analytics, visualize your data, write SQL queries, perform statistical analysis, and build machine learning models to make future predictions. SAS empowers our customers to move the world forward by transforming data into intelligence. SAS is investing a lot to drive software innovation for analytics. Gartner has positioned SAS as a Magic Quadrant leader for data science and machine learning.
So let's talk about what does a data analyst do. Think of data as the new oil powering decisions in every industry. Data analysts are the ones who extract and refine these valuable resources. They gather, verify, and organize data to make it easy to access and analyze. Using statistical methods, they find trends and patterns, create reports and visualizations with tools like Tableau or Power BI, and provide insights that help businesses make smart decisions. For example, imagine a retail company trying to understand why sales dropped last quarter. A data analyst would gather sales data, customer feedback, and market trends. They might discover that a competitor launched a similar product at a lower price, causing customers to switch. With this insight, the company can adjust its pricing strategy or improve its product to regain market share. So now let's talk about how to become a data analyst. The journey involves learning the right skills, understanding industry tools, and getting practical experiences. Earning a bachelor's degree or master's degree in fields like statistics, computer science, economics, or mathematics give you essential skills in analytical thinking, statistical analysis, and mathematical modeling. Universities often offer courses on data analysis, machine learning, and data management. But here's the good news. Gaining practical experience is essential. Internships allow you to apply your knowledge in real-world settings, offering mentorship and a deeper understanding of business process. University career services, job fairs, and online job portals like Indeed, Glassdoor, and LinkedIn can help you find these opportunities. So let's talk about what skills do you need in order to become a data analyst. So to become a successful data analyst, you need a mix of technical and analytical skills. At first, we have programming. Python. Learn how to use libraries like Pandas for data manipulation, NumPy for numerical data, and practice by working on real-world projects, such as cleaning datasets, performing exploratory data analysis, and building predictive models. Then we have R. This language focuses on statistical analysis and data visualization. Learn packages like ggplot2 for visualization and dplyr for data manipulation and caret for machine learning. Then we have database management. For database management, the first language you need to learn is SQL. Learn how to write queries to extract data, join tables, and perform aggregations. Practice by working with databases like MySQL or PostgreSQL and understand how to optimize queries for performance. Then we have database design. Understand how to design databases efficiently, including normalization and indexing strategies. Practice by designing schemas for sample projects and optimizing them for different query patterns. Then we have data visualization. Tableau and Power BI. Learn how to create interactive dashboards, build compelling data stories, and learn data within these tools. Practice by creating visualizations from different data sets, focusing on presenting clear and actionable insights. Then we have Python libraries like matplotlib for basic plotting and Seaborn for statistical visualization, and Plotly for interactive plots. Practice by visualizing various data sets, highlighting trends, and telling data-driven stories. Let's now talk about analytical skills. At first, you need to have statistical analysis, understand key statistical concepts like hypothesis testing, regression analysis, and probability distributions. Practice by applying these concepts to real data sets and interpreting the results. Problem solving. Develop the ability to tackle business problems using data. Practice by working on case studies and projects that require data-driven decision-making. Then we have communication skills, data storytelling. Learn to present data in a compelling way that highlights key insights. Practice by creating reports and presentations that effectively communicate your findings. Presentation skills. Develop the ability to create clear, informative, and engaging presentations. Practice by presenting your analysis to peers or mentors and incorporating their feedback. Then we have technical writing also. You should know how to learn and write clear and concise reports that explain your methodologies, findings, and recommendations. Practice by documenting your projects and sharing your reports with others for feedback. You might be now wondering, where do data analysts actually work? So data analysts are needed in various industries like healthcare, finance, marketing, and sports. In healthcare, data analysts help hospitals improve patient outcomes by analyzing treatment data. In finance, they help banks detect fraudulent transactions, and in marketing, they optimize campaigns by understanding customer behavior. In sports, they help teams improve performance by analyzing player statistics. So data analysts can be found in tech giants like Google, Amazon, and Microsoft, Facebook, and IBM as well. The job market is vast and growing, with opportunities in almost every sector. So how much do data analysts actually make? Data analysts can expect competitive salaries, often starting around $60,000 and going up to $100,000 or more with experience. For example, an entry-level data analyst at a tech company might start with $65,000, while a senior data analyst with several years of experience could earn over $100,000. The high demand for skilled data analysts means companies are willing to pay well for these valuable skills. Now, how to learn data analysis in 2024? Start with online courses and certification. Online platforms offer specialized learning and are often updated with the latest technologies and methods.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
Also, if you are interested in making a career in data analytics, check out Simplilearn's postgraduate program in data analytics. This comprehensive course is designed to transform you into a data analytics expert. It covers essential skills such as data visualization, statistical analysis, and machine learning, using industry-leading tools and technologies like Excel, R, Python, and Tableau. With expert instructors, real-world projects, and hands-on experience, you will gain the knowledge and confidence needed to excel in today's data-driven world. Join now to advance your career and become data analytics professional. Also, let's talk about whether practicing your skills with real-world projects are essential or not. Well, yes. Building a portfolio to showcase your abilities to potential employers is highly valued. For example, you can start with simple projects like analyzing a public data set and gradually move to more complex ones. Document your process, create visualization, present your findings. A strong portfolio is a great way to demonstrate your skills and attract job offers. Platforms like Kaggle offer data science competitions, while GitHub allows you to contribute to open source projects. Personal projects using public data sets can also enhance your skills and build your portfolio, making you more attractive for potential employers.
Freelancing often provides diverse project experience with direct business implications. Platforms like Upwork, Freelancer, and TopTip helps you connect with clients which needs data analysis, offering flexible experience and industry exposure. Let's talk about whether networking is essential or not. Well, building a professional network is crucial for career growth and gaining industry insights. LinkedIn is a great platform to connect with professionals, join groups, and participate in discussions. Attending conferences and workshops also provides networking opportunities and learning experiences. Networking can help you lead to career opportunities and help you stay updated with industry trends. Engaging with community enhances your problem-solving skills and supports your growth. Platforms like Stack Overflow, Cross-Validated, and local or virtual meetups allow you to discuss data-related topics and build your reputation. Community engagement fosters skill development and help you become a knowledgeable and helpful member of the data community. So, you know that now building a strong resume is your first introduction to potential employers. You must also highlight your educational background, projects, internship, technical skills, and certifications as well. Tailor your resume for each job and quantify your achievements to make a strong impression. Preparing for interviews involves understanding the role, reviewing your projects, practicing common questions, and participating in mock interviews to build confidence. As you gain experience, opportunities to move into senior roles such as data scientist, data engineer, or analytics manager will arise. Continued education, skill diversification, and developing leadership skills are key strategies for advancements. So now let's talk about what is the data analyst job outlook in 2024. Well, the demand for data-driven decision-making is increasing day by day, and with it, the need for skilled data analysts as well. The big data analytics market is predicted to grow by 30%, reaching up to 68 billion US dollars by 2025. The growth means more job opportunities and higher salaries for data analysts. With demand, good pay, and plenty of opportunities, data analytics is a future-proof career choice. Data analysts play a crucial role in helping companies navigate complex data and make informed decisions. This role offers job security, career growth, and the satisfaction of knowing your work making a real impact. Alright, let's get started. Data modeling, my friends, it's all about defining the structure of your database. Imagine you've got this raw data coming from an API or maybe some sales information. It's usually a bit of mess, right? Just a bunch of numbers, letters, and codes representing transactions, customer details, and whatnot. Well, data modeling helps you bring order to that chaos by aligning the data and integrating it into your existing database. Think of it like this. Suppose you are an architect designing a blueprint for your data. You decide how different pieces of information relate to each other, like how payment connects to orders or how customer details link to their purchase history. It visually represents the different data elements and how they relate to each other, following certain predefined rules and guidelines. But why bother with all of this? You might ask. Well, data modeling is the foundation for everything you do with your data. It ensures data integrity and accuracy, making sure your machine learning models aren't just training on garbage data or giving you nonsensical predictions. Moreover, it aids in database design, application development, and data analysis, allowing you to extract valuable insights from your organized information. And let's not forget about data governance. Having a clear understanding of where your data lives, what types of data you're storing, and the security measures is the key to compliance with those pesky regulations and standards. Now let's talk about the different types of data models out there. At first, we've got a good old model, which is the relational model. This uses tables to store data and establish relationships between them. It's relatively simple to set up and has powerful query capabilities, making it a popular choice. Then we've got the object-oriented model, which combines data and operations into a single model. These are great for applications with complex relationship and operations, like maybe modeling the robotics of a car factory, but probably not an AI model. That wouldn't make much sense, right? We've got also network data models, which are an extension of hierarchical models. It allows for multiple parent records for each child, representing more complex relationship. And let's not forget about the entity relationship model, which gives you a clear logical view of your data by mapping out entities, attributes, and relationship. It's like a giant web of connections, making it easy to understand how data flows from one point to another. Now, when it comes to implementing data modeling, you've got a bunch of tools at your disposal, from dedicated solutions like ER Studio and DB Schema to open source options like PG Modeler and MySQL Workbench. You've also got collaborative online tools like Lucid Chart, which is perfect for teams working together on data models. And let's not forget the good old Oracle SQL Data Modeler and IBM InfoSphere Data Architect for those who are in business intelligence and analytics game. But wait, there's more. The data modeling process itself is a journey. First, you start with the conceptual modeling, where you get a high-level understanding of the data you're working with and what your stakeholders need from it. It's like the rough draft of your data blueprint. Then we move on to the logical data modeling, where we get technical details, attributes, primary keys, foreign keys, relationship between tables. Next, we have physical modeling. This is where we design our database schema and optimize it for performance, indexing, and partitioning to make sure your data runs like a well-oiled machine. After that, you finally create the database and start ingesting your business data. But the fun doesn't stop there. You've got to keep maintaining and updating your data model as your needs change, capturing those data changes over time, and making adjustments to keep everything run smoothly. And there you have it. Data modeling is the backbone of your data universe, ensuring that your application, analytics, and decision-making process are built on the solid foundation of well-structured and organized information. After establishing a robust data model, the next step is to delve into the fascinating world of data analysis. This is where the real magic happens. Data analysis empowers you to uncover hidden patterns, trends, and relationships within your meticulously organized data. Through data analysis, you can transform raw information into actionable intelligence that drives informed decision making. It's like uncovering a treasure trove of knowledge buried within your data, waiting to be explored and leveraged for strategic advantage. Now let's switch gears and talk about data analysis. Well, data analysis is all about evaluating the data itself. It's like being a detective, looking for clues and patterns in the data to tell a compelling story. You might run reports, create custom queries, or even merge data from multiple sources to get a complete picture. It's like piecing together a puzzle, but with numbers and information instead of colorful pieces. We will now discuss the several types of data analysis, each serving a different purpose. At first, we have descriptive analysis, which help you to see what has already happened by looking at the past data. Then we have the diagnostic analysis to determine why something happened by examining the data. Predictive analysis uses past data to predict what might happen in the future. And finally, prescriptive analysis combines all others to make recommendations for the future. Where does a data analyst fit into this intricate web of data modeling? Well, a data analyst is the master architect designing the blueprints that bring order to the chaos of raw data. They define how different pieces of information relate to each other following predefined rules and guidelines. It's like creating a massive catalog for your organization data assets, ensuring everything is accounted for and organized. To be a master of data analysis, you just need two crucial skills. First, you need to have a solid understanding of the business, what the data means, and how it impacts the organization operation. But that's not all. You also need some serious technical chops. You need to know your way around databases, business intelligence systems, and the tools needed to extract and analyze the precious data. And let's not forget, the demand for skilled data analysts is soaring. According to the industry reports, the average data analyst salary in the US projected to reach around $75,000, with the opportunities for experienced professionals to earn well over 6 figures. Now you might be thinking, aren't data modeling and analysis two different skill sets? Well, you're not wrong, but here's when it's get interesting. Data analysis and data modeling. Data modeling and data analysis often overlap. To truly understand how data moves from one system to another or how different field maps together, you might need to flex your data analysis and dive into the raw data itself. This synergy has led to the rise of combined business intelligence and business analysis role, a dynamic duo where data modeling and data analysis joined forces to create powerful business insights and intelligence. It's like having a superhero team from where each skill set complements the other. Now you might be thinking, but wait, aren't there still opportunities for more general functional business analysis roles? While dedicated business intelligence is in high demand, there's still a thriving market for those who prefer a more broad-based approach. Let us now discuss the career paths in data-related roles. The key thing to understand is that data modeling and data analysis go hand in hand. Good modeling ensures you have accurate, structured data, skilled analysis that allows you to truly unlock the value in the data through insights. Companies need expertise in both areas for a comprehensive data strategy. If you really enjoy digging into data to find hidden insights, a dedicated business intelligence analyst role could be perfect. But there are also general business analyst role available that still requires good data modeling skills. Whichever path you choose, having skills in both data analysis and modeling is very valuable. With strong abilities in these areas, your data projects are much more likely to succeed.
Hi guys, this is Raul from Simplilearn, and today we're going to look at 3 very important data related roles in the field of data science, and then we're going to pit them against each other. So welcome to data scientist versus data analyst versus data engineer. Now let's have a look at what's in store for you. Firstly, we'll talk about the job descriptions, the skill sets required for each role, the salary, the roles and responsibilities, and the companies hiring for these positions. So now let's have a look at each of these roles in detail. First off, let's have a look at data scientist. Now a data scientist is able to create machine learning based tools or processes within the company. Now they use advanced data techniques such as clustering, division trees, neural networks, and so on, so that they can derive business conclusions. They are the senior most member in the team, which involves a data engineer as well as a data analyst. Now they need to have in-depth knowledge of statistics, data handling, and machine learning. They also take inputs from data engineers as well as analysts so that they can formulate actionable insights for the business. Now a data scientist also needs to have the same skills as a data analyst and an engineer, but needs to have a lot more in-depth knowledge and expertise with these skills. Next up, we have data analyst. Now a data analyst is someone who's able to translate numeric data into a form that everyone in the organization can understand. Now this is an entry-level position in the data analytics team. He or she needs to have technical skills in programming languages such as Python and have knowledge of tools like Excel and understand the basics of data handling, modeling, and reporting. Now in due time, they can move up the ranks by taking up roles of data engineer and data scientist with some experience that they can accumulate over the years. And finally, we have data engineer. Now, a data engineer is someone who's involved with preparing data for analytical or operational purposes. Now, they are the intermediary between the data analyst and the data scientist. He or she needs to have a lot of experience when it comes to developing, constructing, and maintaining architectures. Now, they do generally work on big data and submit their reports to the data scientist so that they can be analyzed. Now let's have a look at the skill sets required for each of these roles. First off, we have data scientist. Now since this role is a little more coding oriented, you need to know a great deal when it comes to programming languages. Programming languages such as Python, R, SQL, SAS, Java, and so on. Now you also need to be well versed with frameworks in relations to big data such as Pig, Spark, and Hadoop. Speaking of Hadoop, if you want to learn more about how it works, I suggest you click on the top right corner and watch our video on what is Hadoop. Coming back, data scientists also need to be well versed with machine learning, deep learning, and other similar technologies. Next up, we have data analyst. Now, this role is much less technical as compared to a data scientist as well as a data engineer, considering how it's entry level. Here, knowing programming languages is a great bonus. So, an idea about programming languages such as Python, R, SQL, JavaScript, SSAS, and so on is a great benefit. At the same time, you do need to be well versed with tools such as SAS Miner, Microsoft Excel, SSAS, SPSS, and so on. And finally, we have data engineer. Now, being a data engineer requires you to be well versed with a bunch of programming languages as well as frameworks. Now, you need to know about programming languages such as Python, R, SQL, SAS, Java, and so on, while having expertise in frameworks such as Hadoop, MapReduce, Hive, Pig, Apache Spark, data streaming, NoSQL, and so on. Now, let's talk about money, or the salary each of these roles get. Firstly, we have the data scientist, who earns a whopping $137,000 per annum. Then we have the data analyst, who earns $67,000 per annum, which is a pretty high salary when you consider that it's only an entry-level job. And a data engineer, which is in the median with $116,000 per annum. Now let's talk about roles and responsibilities. Firstly, we have the data scientist. Now a data scientist gets to work with a lot of unstructured data, so they need to mine and clean the data so that it's usable. They need to be able to design machine learning models to work on the big data data, they need to infer and interpret the analysis on big data, to be able to lead an entire team to achieve the goals of the organization and deliver conclusions that have a direct business impact. Now let's have a look at the roles and responsibilities of a data analyst. They need to use queries to gather information from a database. They need to process the data and provide summary reports. They need to use basic algorithms for their work, such as linear regression, logistic regression, and so on, and have core skills in statistics, data munging, data visualization, and exploratory data analysis. And finally, we have data engineer. Now, they need to mine through the data so that they can gain insights from it. They need to convert erroneous data into a usable form so that they can be further analyzed. They need to write queries on data. They need to maintain the design as well as architecture of the data and create large data warehouses using ETL or extract transform load. Now let's have a look at some of the companies hiring for this role. Firstly, for data scientists, you have Citibank, Facebook, Schneider, Intel, Amazon, and so on. For data analysts, you have Infosys, Oracle, Visa, Capital One, Walmart, and so on. And for data engineer, you have Google, Cisco, Flowcast, Cognizant, Apple, Spotify, and much more.
Now that we have looked at the various steps involved in data analytics, let's now see the different tools that can be used to perform the above steps. So as you can see, we have 7 tools including a few programming languages that will help you perform analytics better. Now let's discuss them one by one. First, we have Python. Python is an object-oriented open-source programming language that supports a range of libraries for data manipulation, data visualization, and data modeling. Python programmers have developed tons of free and open-source libraries that you can use. You can find many of them via the Python package index, which is pypi, the repository of Python software. Python provides the default package installer called pip or pip. Python has libraries such as NumPy for numerical computation of data, pandas to manipulate data on numerical tables and time series. Then you have SciPy for technical and scientific computations. It also provides scikit-learn, which is a machine learning library for creating classification, regression, and clustering algorithms. And finally, it also has PyTorch and TensorFlow for deep learning. Up next, we have R. R is an open source programming language majorly used for numerical and statistical analysis. It provides a range of libraries for data analysis and visualization. Some of these libraries are ggplot, tidyverse, plotly, dplyr, and caret. Then we have Tableau. Tableau is a popular data visualization and analytics tool that helps you create a range of visualizations to interactively present the data, build reports, and dashboards to showcase insights and trends. It can connect with multiple data sources and give hidden business insights and patterns. Then we have a competitor of Tableau, which is Power BI. Power BI is a business intelligence tool developed by Microsoft that has an easy drag and drop functionality and supports multiple data sources with features that make data visually appealing. Power BI supports features that help you ask questions to your data and get immediate insights. You can also forecast your data for predicting future trends. So the next tool is QlikView. QlikView provides interactive analytics with in-memory storage technology to analyze vast volumes of data and use data discoveries to support decision making. It provides social media discovery and interactive guided analytics. It can manipulate huge data sets instantly with accuracy. Up next, we have Apache Spark. Apache Spark is an open source data analytics engine to process data in real time and carry out complex analytics using SQL queries and machine learning algorithms. It supports Spark Streaming for real-time analytics and Spark SQL for writing SQL queries. It also has Spark MLlib, which is a library that has a repository of machine learning algorithms, and then it has GraphX for graphical computation. And finally, we have SAS. SAS is a statistical analysis software that can help you perform analytics, visualize your data, write SQL queries, perform statistical analysis, and build machine learning models to make future predictions. SAS empowers our customers to move the world forward by transforming data into intelligence. SAS is investing a lot to drive Software Innovation for Analytics. Gartner has positioned SAS as a Magic Quadrant leader for data science and machine learning. Moving on to the applications of data analytics. Data analytics is being used in almost every sector of business these days. Let's discuss a few of them. First, we have retail. Customers expect retailers to understand exactly what they need and when they need it. Data analytics helps retailers meet those demands. Retailers not only have an in-depth understanding of their customers, but they can also predict trends, recommend new products, and boost profitability. Retailers create assortments based on customer preferences, invoke the most relevant engagement strategy for each customer, optimize supply chain and retail operations at every step of the customer journey. The second application is on healthcare. Healthcare industries analyze patient data to provide life-saving diagnosis and treatment options. They also deal with healthcare plans and insurance information to drive key insights. Using analytics, they can discover new drugs and come up with new drug development methods. Advanced analytics allows healthcare companies to improve patient outcomes and experience. Cancer cells and diabetic retinopathy can be discovered using medical imaging. At number 3, we have manufacturing. For manufacturers, solving problem is nothing new. They fight with difficult problems and situations on a daily basis. From complex supply chains to motion applications to labor constraints and equipment breakdowns, they deal with such problems on a regular basis. Using data analytics, manufacturing sectors can discover new cost-saving and revenue opportunities. The fourth application is related to the banking sector. Banking and financial institutions collect vast volumes of structured and unstructured data to derive analytical insights and make sound financial decisions. Using analytics, they can find out probable loan defaulters, customer churn-out rate, and detect fraudulent transactions immediately. The final application is based on logistics. Logistics companies use data analytics to develop new business models that can ease their business and improve productivity. They can optimize routes to ensure delivery reaches on time in a cost-efficient manner. They also focus on improving order processing capabilities as well as performance management. With that, now let's look at the companies using data analytics on a daily basis. So we have the e-commerce giant Amazon, then we have Accenture, followed by the American Healthcare Service Organization, Cigna. Then we have the American supplier of health information technology solutions, services, devices and hardware, Cerner, followed by Target and antivirus company McAfee. Next, we have Rapido, which is an Indian bike rental company based in Bangalore. After that, we have Flipkart and the world's largest retail company, Walmart. With that, let's understand a case study from Walmart and how it uses data analytics to grow its business and serve its customers better. Walmart is an American multinational retail company that has over 11,500 stores in 27 countries worldwide, and it has e-commerce websites in 10 different countries. It has more than 5,900 retail units operating outside the United States with 55 banners in 26 countries with more than 7 lakh associates serving more than 100 million customers every week. It has over 2.2 million employees around the world and 1.5 million employees in the United States alone. Walmart's e-commerce branch alone employs more than 3,000 technologists from Silicon Valley to India, England and South America. More than 240 million customers shop at Walmart each week online and at its banner stores. Walmart.com sees up to 100 million unique visitors a month according to ComScore and is growing every year. Walmart collects over 2.5 petabytes of data from 1 million customers every hour. That's really huge. Now to make sense of all this information, Walmart has created Data Cafe, a state-of-the-art analytics hub located within its Bentonville, Arkansas headquarters. Here, over 200 streams of internal and external data, including 40 petabytes of recent transactional data, can be modeled, manipulated, and visualized. Teams from any part of the business are invited to bring their problems to the analytics experts and then see a solution appear before their eyes on the nerve center's touchscreen smartboards. Walmart also constantly analyzes over 100 million keywords to know what people near each store are saying on social media to understand their customer behavior on what they like and dislike. Walmart uses modern tools and technologies to derive business insights and improve customer satisfaction. Some of these tools include Python, SAS, NoSQL databases such as Cassandra and Hadoop. Now, using all these technologies and data analysis techniques, Walmart can better manage its supply chain, optimize product assortment, personalize the shopping experience, give relevant product recommendations, and finally, optimize and analyze transportation lanes and routes for its fleet of trucks. With that, let's jump into our use case demo where we will predict the sales based on advertising expenditure using the linear regression model in R. The advertising expenditure has been made via different mediums such as radio, television, and newspaper. We will use the R programming software to implement the demo. So why R? Well, R is a free and open source software that can be downloaded from the RCRAN website. It is easy to learn and use. R language is built specifically for performing statistical analysis, data manipulation, and data mining using packages such as Plier, dplyr, tidyr, and lubridate. R supports data visualization with the help of packages such as ggplot, Google Viz, R Color Brewer, Leaflet, and ggmap. And finally, the R software can be used in a wide range of analytical modeling including classical statistical tests, linear and nonlinear modeling, data clustering, time series analysis, and more. Now, let's have a look at our data that we will be using for this demo. Here is our advertising CSV dataset, which has 4 columns. You can see there's TV ads expenditure. The next column is for radio ads. Then we have the newspaper ads. And the last column is our target column, that is the sales. So the data set has in total 200 rows. Now, to understand the data, let me give an example. So consider the second row. So suppose you spend around $230 on TV ads, then $37.8 on radio ads, and $69.2 in newspaper ads. You can expect to sell nearly 22 units of a particular product. Similarly, if you are spending $44.5 in TV advertising, $39.3 in radio ads, and $45 in newspaper ads, you can sell around 10 units of certain item. We will analyze this data using linear regression. So linear regression is a supervised learning algorithm, which means the data has labeled columns and is used to predict numeric continuous variables. So our sales column here is the target column and it has continuous numeric variables. Now let me go to the R Studio and start with the demo. So first, I'll create a new file, then I'll select R script. The next step is to install all the necessary packages that we need for this demo. If you already have the packages installed in your R Studio, you need not do it again. You can just call these packages using the library function and pass the package names. So first, I will install the dplyr package, which is used for data manipulation. I'll be using install.packages function and I'll give the package name. So I'll type install.packages. If you hit tab, it will autocomplete. Then under quotations, I'll write dplyr. I'm not going to run this because I already have it installed in my R Studio. The next step, I'll call this package using library function. I'll give the package name deployer. I'll run this. Then I'll install the broom package. It takes the messy output of built-in functions in R such as linear model or LM, then t-test, and turns them into a tidy data frame. So I'll copy the above code. I'll just paste it again. I'll change it to broom. Here also I'll change it to broom. I'll run this. Okay. Then I'll be installing the CA tools package, which will help us build our linear regression model. I'll paste the same code and I'll take CA tools and I'll call that using the library function. I'll run this. Now sometimes people face issues with installing this particular package. If you also face this problem, do visit the RStudio community page. Now let me show it to you. So this is the RStudio community page, and here they have the solution. You can just go through this 2 pages. Alright. After this, I will install the ggplot2 package, which is a very popular package in R for data visualization. I'm not running install.packages because I have already installed all these packages before. If you have not, so you have to run install.packages first and then call the library function. With that, let's now load the dataset. For this, I will use the read.csv function and provide the path location where my data is located, followed by the dataset name and the extension. I'll assign the loaded dataset to a variable. Let me now go ahead and show you where my dataset is located. So here is my advertising CSV dataset and this is the location. I'll copy this location. I'll move back to RStudio and let me comment this line, load the dataset. So I'll take a variable name ads and then using read.csv function, I'll pass the path location where the dataset is present. Now one thing to note is we have to change all the backslash to forward slash, otherwise R won't accept it. And finally, I'll give the dataset name, which is advertising.csv. Let me run it. Okay, we have successfully loaded our dataset. Now let us look at how our dataset looks like using the head function. So I'll give a comment, display the head of the dataset. I'll be using the head function and I'll pass ads. Run it. So you can see the head function has displayed the first 6 rows from the advertising dataset. Let me now check the dimensions of the dataset. So I'll use the dim function. It will give you the total rows and columns present in the dataset. Give a comment, check the dimensions. I'll use the dim function and I'll pass in the ads variable. You can see it has given the number of rows, which is 200, and the total columns, which is 4. Now, if you want to get a summary of the dataset, you can use the summary function. So I'll directly type in summary and I'll give adds. Let me expand this. So actually summary function gives you information about a few statistics for each of the columns. So you can see the minimum value for each column, the maximum value for each column, the mean, the median, first quartile and the third quartile values. The first quartile or lower quartile is the value that cuts off the first 25% of the data when it is sorted in ascending order. The second quartile is the median, which has the value that cuts off the first 50%. And the third quartile or the upper quartile is the value that cuts off the first 75% of data. Moving ahead, let's do some data visualization now to visualize our data. Since our data has only numeric values, using scatter plots would be the best option. So we will visualize our sales against each of the independent variables. For that, I will use the plot function and give sales in my x-axis and the independent variable names in the y-axis. Let me now do that. So I'll give a comment, data visualization. First, I'll use the plot function, and then in x-axis using the dollar symbol, I'll give sales. Then in the y-axis, I'll give my independent variable. You can see R is automatically giving you the suggestions. I'll select TV. Then I'll take type is equal to under quotes, I'll give P, which stands for points, and I'll take the color as red. So you can see under plots we have our scatter plot. If I zoom in, you can see the red dots are pretty much aligned in one direction, which means if you are increasing the expenditure on TV ads, the units sold are also increasing equally. So the more you spend on TV ads, the more sales you can expect. I'll close it. Now let's look at how sales vary based on radio advertising expenditure. I'll copy this. Paste it, and under y-axis I'll change it to radio, and I'll take the color now as, let's say, blue color. I'll run it. Now if I were to zoom in, now if you look at the blue dots, it is not that linear compared to our previous graph. You can see there are a few data points like this that show the sales were not good even after spending decent money on radio ads. But still you can expect a decent amount of sales if you are willing to spend on radio advertising. Close it. Let's now look at how sales will vary based on the newspaper advertising expenditure. I'll change the radio to newspaper column, and this time I'll take color as green. I'll run it. Let me zoom in. You can see the plots are very haphazardly present. The data is completely non-linear, and there seems to be a low correlation between the sales and newspaper advertising expenditure. Now if you want to look at these plots at a time, you can use the pairs function. So I'll type pairs and then pass in my variable name, which is ads. I'll run it. Let me zoom in. So this is our plot, and you can see this has all the visualizations. So you can see the TV sales. Now you can see the sales that were made with radio expenditure and with the newspaper expenditure as well. I'll close it. Moving ahead, let's check the correlation between the variables and see what insight we can get. We will use the core function or COR function and build a correlation matrix. First, let me go ahead and install the core plot package. So I'll give a comment, correlation analysis. For this, I will have to install the core plot package. I have already got it installed. Then I'll call this function using library. I'll run it. You can see core plot, the version has been uploaded. Now I'll tell you how you can grab only the numeric columns. Now our data only has numeric columns, but still let me tell you how you can do it. Since correlations are based on numeric columns only, this can be done using the sapply function. So for that, we have already installed the dplyr library. I'll give a variable name as num.calls, which is numeric columns. Then I'll pass in the sapply function. I'll give the ads variable and I'll check if the variable is numeric or not. So I'll use is.numeric. Let me run it. And now let's display what's there in num.calls. You can see it says TV, it's true, which means TV has numeric values, even radio has numeric values. Similarly for newspaper and sales also. Then I'll use the correlation function, which is COR, to display the correlations between the variables. So I'll give my variable name as cor.data, and then I'll take the core function, pass in the ads variable, and I'll only filter out the numeric columns. So comma numeric columns means we need all the rows and the selected columns. Let me run it. And now to display, let me call cor.data again. So this is our correlation output. As you can see, the correlation values are all above 0, which means there is a positive correlation between the variables, and a change in one of the independent variables will have a positive impact on the sales numbers. TV ads have the maximum correlation with sales and the value is around 0.78. Then there is radio advertising, which has correlation of about 0.57 with sales, and newspaper ads have the lowest correlation compared to the other two, which is at 0.22. Now you can also build a correlation matrix using the correlation plot method. This will give you a visual representation of the correlation between the variables. So let's see how we can do that. I'll type core plot and I'll give core.data and I'll pass a method as color. If I zoom in, you can see this is our correlation matrix. On the right, you can see the scale. So -1 is for negative correlation. Then there's light red, 0, which is almost white color. Then there's light blue, and finally dark blue for the maximum positive correlation. The diagonals are dark blue, which represents the same variables as in rows and in columns. So it's dark blue. TV ads and radio ads have the next highest correlation, while newspaper ads have the lowest correlation with sales. With that, let's jump into the most important part of this analysis, which is building our regression model. First, we will look at a simple linear regression model where we will take one input variable, that is TV ads. I'll be using the LM function or the linear model function to build the model. So I'll give a comment, simple linear regression. I'll take a variable name as model underscore simple, and then using LM function I'll give my target variable, which is sales, and using tilde I'll give my independent variable, which is TV, and data as ads. I'll run it. Now that we have built our linear regression model, let's check the summary. Take summary function and I'll pass in model underscore simple. Let me run it. Now if I expand this, you can see our intercept estimate is around 7.03. So when the TV advertising budget is 0, we can expect sales to be around 7030 or 7030. Also remember, we are operating in units of 1000, and for every $1000 increase in the TV advertising budget, we can expect the average increase in sales to be around 47 units. Now the same summary can be checked using the tidy function present in the Broom package. So if I call tidy and I'll give the model name, which is model underscore simple, I'll run it. So there you go. This gives us a tidy representation of the summary figures. Now let's build a regression model with more than one input variable. So we'll build a multiple linear regression model. I'll take my variable name as model underscore multiple this time, and I'll use the same LM function. I'll pass in the sales, and using tilde I'll take all the column names. Stevie, then I'll use an addition operator, then I'll take in newspaper, followed by the radio column, and then I'll take my data as ads. Let's run it. I'll follow the same drill. Let me now call the summary function over this newly created model. So I'll write summary and I'll select my model name as model underscore multiple. Let me run it. So the interpretation of our coefficients is the same as in simple linear regression model. First, we see that our coefficients for TV and radio advertising budget are statistically significant, since our p-value is less than 0.05, while the coefficient of newspaper is not, which is around 0.86. Thus, changes in the newspaper budget does not appear to have any relationship with changes in sales. However, for TV ads, our coefficient suggests that for every $1000 increase in TV advertising budget, holding any other predictors constant, we can expect an increase in sales of 45 units on average. Similarly, the radio coefficient suggests that for every $1,000 increase in radio advertising, holding all the other predictors constant, we can expect an increase of 188 sales units on an average. Now you can also call the tidy function over this multiple linear regression model. So let me do that. I'll call tidy and I'll pass in model underscore multiple. You can see it has given the output. Now you can also find the coefficients of the model using another method. It's called the coefficient matrix. Here is how you can do that. So take a variable name and I'll use the summary function. I'll pass in model underscore multiple and using the dollar symbol I'll take the parameter as coefficient. Let me call C coefficient now. So these are the coefficients of different variables. Let me now show you another example of how you can train a linear regression model using the CA tools library. First, I'll take a seed value, a random seed value of say 101. Next, I will split the data into training and testing sets. I'll take 70% for training the data and 30% for testing the data. So I'll use a variable sample, then I'll call sample.split, take ads, and then I'll use another parameter called split ratio, and I'll take the split ratio as 0.7, which is 70%. I'll run it, and then I'll use another variable called train and take the subset of the sample, pass in my ads variable, and I'll select sample is equal to true. Similarly, I'll take another variable called test. I'll use my subset function and given the same parameters, but this time I'll take sample is equal to false, which means the test sample dataset won't have any values that are present in train dataset. I'll run it. Now we will use the same lm function to create our model. So I'll take model as my variable and assign it to lm function. So I'll assign the linear model to the model variable. I'll take sales as my target column, use the tilde followed by a dot, which means I'm taking all the variables in terms of the independent variables, and then I'll select my train dataset. With that, let's check the summary as well. So this is the summary of our newly created model. Now you can also check the residual collected from the trained model using the residuals function. Let me go ahead and assign a variable called res for residual, and I'll use the residuals function. Pass in my model. Then I'll convert the residuals into a data frame. So I'll use the as.dataframe function and pass in res. Now you can check the residuals. So these are the residual values. Now it's time to make our predictions using the test dataset. I'll use the predict function for this. Let me take another variable called sales.predictions and I'll use the predict function, pass in my model followed by the test dataset. Now I'll run it. Then let me call sales.prediction to display the values. As you can see, these are my predicted sales values. Now let me combine these predicted sales values to our original sales for the test data. For that, I'll use the cbind function and pass the column names. I'll take another variable called results and use the cbind function. I'll take sales.predictions and I'll consider the sales column from the test data. Let me check the values now. So you have the predicted sales values and the original values of sales, but you can see the columns don't have any name assigned to them. So let me go ahead and assign the column names using the call names function and convert it into a data frame to make it look better. So I'll use the call names function and pass in my results variable. Then I'll take a vector and give the column names as pred for predicted values and let's say real for the original values. We run it. Now I'll convert this into a data frame. So I'll use as.data.frame and give my results variable. Now if I display results, you can see, go on top, you can see the columns have been assigned successfully. So on the left you have the predicted values and on the right you have the real values. So we have successfully built our linear regression model and predicted the sales values using linear regression in R. You can also go ahead and find the accuracy of this model to know how good your model is. We won't be covering that as part of this tutorial. I'll leave it for you and encourage you to do some research on how you can find the accuracy of a linear regression model. You will come across terms such as mean squared error, root mean squared error, and R squared value. If you are able to find the accuracy, please post the results in the comment section, or if you face any issues with it, please post your queries. We'll be happy to help you.
And if you're an aspiring data analyst, try giving a shot to Simplilearn's postgraduate program in data analytics from Purdue University in collaboration with IBM. The link in the description box and the pinned comment should take you to the program being offered.
Online Analytical Processing (OLAP) and Online Transaction Processing, in short OLTP, are two popular database systems that have evolved separately to serve distinct purposes. While both systems offer data storage and retrieval capabilities, they differ significantly in terms of their architecture, data flow, and performance characteristics. OLAP is designed specifically for data analysis and reporting, while OLTP is designed for online transaction processing, such as online banking, inventory management, and order processing. OLAP is optimized for analyzing large volumes of data and reporting metrics, while OLTP is optimized for quickly processing individual transactions. There are many other differences between these two crucial data processing systems. So in this video, we'll be discussing the major differences between these two and how you can implement these in large transaction processing systems. So without any further ado, let's get started. Also, if you're an aspiring data analyst looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in data analysis from Purdue University in collaboration with IBM should be your right choice. For more details, use the link in the description box below. And with that in mind, over to our training experts.
Digital approaches stand out in data processing and data analysis, online analytical processing, that is OLAP, and online transactional processing, OLTP. Although they share the common goal of handling data, these methodologies differ significantly in their purpose, data structure, performance characteristics, and design principles. OLAP is a powerful tool for organizations seeking to extract valuable insights from vast volumes of historical data. Its multidimensional data model, organized in cubes comprising dimensions and measures, allows for sophisticated analysis and in-depth exploration. With a focus on aggregating and summarizing information, OLAP empowers users to identify trends, patterns, and correlations across multiple dimensions. Despite longer response times, which are acceptable due to their analytical nature, OLAP excels in providing flexible ad hoc query capabilities for complex data explorations. Conversely, OLTP is designed to handle real-time transactional processing, ensuring the integrity and consistency of daily operational activities. By adopting a normalized data model, OLTP optimizes the storage and retrieval of individual records in high-speed environments. Its primary objective revolves around efficient data modification, such as inserting, updating, and deleting records. To support concurrent transactional operations with a focus on rapid response times and maintaining data accuracy at record level, OLTP caters to the needs of time-sensitive business operations. Understanding the distinctions between OLAP and OLTP is crucial for organizations to choose the appropriate data processing approach based on their specific requirements. Today, we will be understanding the difference between OLAP and OLTP by going through the following details mentioned in the agenda. We will get started with the first one, which is its purpose, then data structures, data volume, response time, query complexity, data modification, data granularity, concurrency, data backup and recovery, and finally the system design. So, with the briefing of OLAP and OLTP discussed and the agenda for the session discussed, let's proceed to the point of today's session, that is the major or top 10 differences between OLAP and OLTP. Firstly, we will go through the purpose. Open reporting, enabling users to gain insights from large volumes of historical data. It focuses on providing aggregated and summarized views of the data. OLTP. OLTP is designed for real-time transactional processing, handling day-to-day operations such as inserting, updating, and deleting individual records. Its primary objective is to ensure data integrity and support high-speed transactional operations. Next is data structure. OLAP uses a multidimensional data model called a cube. It organizes data into dimensions such as time, geography, and product, and measures such as sales and profit to facilitate multidimensional analysis and drill down capabilities. Then we have OLTP. OLTP uses a normalized data model with tables and relationships aiming for efficient transactional processing. It minimizes the data redundancy and ensures data consistency through the use of normalization techniques. Next ahead we have the data volume. OLAP deals with large volumes of historical data, typically containing years of data. It focuses on analyzing and summarizing this vast amount of information. Next is OLTP. OLTP deals with relatively smaller volumes of data, usually representing real-time transactions happening within a shorter time frame. Moving ahead, we have response time. OLAP allows for longer response times since it deals with complex queries and large data sets. Users expect analytical reports to be generated within minutes or even hours. Coming into OLTP, OLTP requires vast response times to support real-time transaction processing. Users expect quick responses, usually in milliseconds or seconds, a lot faster than OLAP. Moving ahead, we have query complexity. OLAP queries are usually complex, involving aggregations, grouping, filtering, and calculations across multiple dimensions. Users need flexible ad hoc querying capabilities to perform data analysis. Moving ahead, we have OLTP. OLTP queries are relatively simple, primarily focused on retrieving or modifying individual records based on specific transactional needs. Queries are typically short and transaction-oriented. Moving ahead, we have the sixth one, that is data modification. OLAP is read-only or minimally updated. Data is loaded into OLAP cubes periodically, example daily or weekly, to update the analytical database with the new information. Coming into OLTP, OLTP involves frequent data modification including insertions, updates, and deletions. It ensures that the transactional database remains up to date and reflects the current state of business. Next in the docket, we have data granularity. OLAP deals with aggregated and summarized data, providing with a high-level view of information across various dimensions. It focuses on trends, patterns, and overall performance analysis. Next, we have OLTP. OLTP operates at a detailed level, capturing individual transactional data with a focus on maintaining accuracy and integrity at a record level. Next, we have the eighth point, which is about concurrency. OLAP involves a low level of concurrent users, since users typically perform separate analysis and reporting tasks that emphasizes on analytical activities rather than concurrent transactional processing. Next, OLTP. OLTP requires a high level of concurrency to handle multiple users simultaneously accessing and modifying the same data. It focuses on maintaining data consistency and isolation amongst concurrent transactions. 9 point, data backup and recovery. OLAP is usually derived from OLTP system, and backup and recovery are less critical. It can be generated from the transactional database if necessary. In case of OLTP, OLTP data is critical and backup and recovery processes are essential. Regular backups are taken to ensure data integrity and provide the ability to store the system in case of failures. And lastly, we have system design. OLAP systems are typically designed with a focus on read-intensive operations. They employ specialized data storage and indexing techniques optimized for analytical queries and aggregations. OLAP databases are often denormalized to improve query performance. And in case of OLTP, OLTP systems are designed to handle a high volume of concurrent read and write operations. They prioritize data consistency and transactional integrity, often using normalized database structures to minimize redundancy and ensure data accuracy.
In today's fast-paced digital landscape, businesses face a daunting challenge: extracting valuable insights from massive amounts of data. Enter the ETL pipeline, the backbone of data processing and analytics. In this tutorial, we will embark on an exhilarating journey unveiling the secrets of building a powerful ETL pipeline. Whether you are a seasoned data engineer or just starting your data-driven adventure, this video is your gateway to unlocking the full potential of your data. Together, we will demystify the ETL process step by step. We'll dive into the extract phase, where we retrieve data from multiple sources ranging from databases to APIs. And then we'll seamlessly transition into the transformation phase, where we clean, validate, and reshape the data into a consistent format. But wait, there's more. We will explore cutting-edge techniques for handling large datasets, leveraging cloud-based technologies, and ensuring quality. We aim to equip you with tools and knowledge to create robust and scalable ETL pipelines to handle any data challenge. So buckle up and get ready to revolutionize your data workflow. Join us in this exhilarating journey to master the art of ETL pipelines. Having said that, if you're an aspiring data analyst looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in data analytics from Purdue University in collaboration with IBM should be a right choice. For more details, use the link in the description box below. With that in mind, over to our training experts.
Hey everyone, so without further ado, let's get started with ETL pipeline. So ETL basically stands for extract, transform, and load. So ETL pipelines fall under the umbrella of data pipelines. A data pipeline is simply a medium of data extraction, filtration, transformation, exporting, and loading activities through which the data is delivered from producer to consumer. To make it a little simpler, the data is produced in two types. Let's say you run a vehicle showroom and you are being a data producer. So the data that you produce is very less, and that could be basically fit into an Excel sheet. This type of data might need update once in 24 hours or based on your audit cycle. Here we call it batch data, and this data is processed using the OLTP model and batch processing tools. But now, let's say you're running an entire vehicle manufacturing plant. Now, the data you're dealing with is voluminous and includes various types of data. It can be structured data, unstructured data, semi-structured data, ranging from space inventory to all the way up to robotic assembly sensors data. Based on requirements, this type of data needs updates maybe every hour, every minute, or even every second. Such type of data is called real-time data and needs real-time data streaming frameworks, and the data is processed using OLAP models. Now, ETL is involved in both these approaches. Now, let's dive in and understand what exactly is an ETL pipeline. ETL stands basically for extract, transform, and load, and representing these three core steps in data integration and transformation process. Let's dive into each phase and explore their significance. Firstly, extract. The first step in ETL pipeline is extracting data from various sources. These sources can range from relational databases, data warehouses, APIs, or even streaming platforms. The goal is to gather raw data and bring it into centralized location for further processing. Tools like Apache Kafka, Apache NiFi, or even custom scripts can be used to perform the extraction efficiently. Next is transform. Once the data is extracted, it often requires significant cleaning, validation, and restructuring. This is transformation phase. The transformation phase ensures that the data is consistent, standardized, and ready for analysis. Transformations can include tasks such as data cleansing, filtering, aggregating, joining, or applying complex business rules. Tools like Apache Spark, Talent, or Python libraries like Pandas are commonly used for these transformations. Lastly, we have the load phase. The final step is loading the transformed data into target systems such as data warehouse, data lake, or database optimized for analysis. This allows business users and analysts to access and query the data easily. Loading can involve batch processing or real-time streaming depending upon the requirements of the business. Technologies like Apache Hadoop, Amazon Redshift, or Google BigQuery are often employed for efficient data loading. Now that we understood the core phases, let's explore some key concepts and best practices for building robust ETL pipelines. Firstly, data quality. Ensuring data quality is crucial for reliable analysis. Implementing data validation checks, handling missing values, and resolving data inconsistencies are vital to maintaining data integrity throughout the pipeline. Next is scalability. As data volumes grow exponentially, scalability becomes essential. Distributed computing frameworks like Apache Spark enable processing large datasets in parallel, allowing the pipelines to handle increasing data loads efficiently. Thirdly, we have error handling and monitoring. Robust error handling mechanisms such as retry, logging, and alerting should be implemented to handle failures gracefully. Additionally, monitoring tools can provide real-time insights into pipeline performance, allowing quick identification and resolution of issues. Next, we have incremental loading. For continuously evolving datasets, incremental loading strategies can significantly improve pipeline efficiency. Rather than processing the entire dataset each time, only the new or modified data is extracted and transformed, reducing processing time and resource consumption. And lastly, we have data governance and security. Incorporating data governance practices and adhering to security protocols is crucial for protecting sensitive data and ensuring compliance with regulations like GDPR or HIPAA. Now that we have covered what exactly is ETL and ETL stages and also the best practices for ETL pipelines, let's proceeding with understanding the popular ETL tools. So the first one amongst the popular ETL tools is the Apache Airflow. Apache Airflow is an open source platform that allows you to schedule, monitor, and manage complex workflows. Apache Airflow provides a rich set of operators and connectors, enabling seamless integration with various data sources and destinations. Next is Talent, a comprehensive ETL tool that offers a visual interface for designing data integration workflows. Talent provides a vast array of pre-built connectors, transformations, and data quality features, making it ideal choice for enterprises. And lastly, we have Informatica. Informatica is a widely used enterprise-grade ETL tool that supports complex data integration scenarios. PowerCenter offers a robust set of features like metadata management, data profiling, and data lineage, empowering organizations.
So what is data analysis? Data analysis is not just a single step but a set of processes. It is the process of collecting data, then cleaning it. When I say cleaning, it simply means removing the irrelevant data, and then this data is transformed into meaningful information. We can simply relate this process to how you make a jigsaw puzzle. Just like how you gather all the pieces together and fit them accordingly to bring out a beautiful picture. Data analysis also works on almost the same grounds. To achieve the goals of data analysis, we use a number of data analysis tools. Companies rely on these tools to gather and transform their data into meaningful insights. So which tool should you choose to analyze your data? Which tool should you learn if you want to make a career in this field? We will answer that in this session. After extensive research, we have come up with these top 10 data analysis tools. Here, we will look at the features of each of these tools and the companies using them. So let's start off. At number 10, we have Microsoft Excel. All of us would have used Microsoft Excel at some point, right? It is easy to use and one of the best tools for data analysis. Developed by Microsoft, Excel is basically a spreadsheet program. Using Excel, you can create grids of numbers, text, and formulae. It is one of the widely used tools, be it in a small or large setup. The interface of Microsoft Excel looks like this. Let's now move on to the features of Excel. Firstly, Excel works with almost every other piece of software in Office. We can easily add Excel spreadsheets to Word documents and PowerPoint presentations to create more visually appealing reports or presentations. The Windows version of Excel supports programming through Microsoft's Visual Basic for Applications (VBA). Programming with VBA allows spreadsheet manipulation that is difficult with standard spreadsheet techniques. In addition to this, the user can automate tasks such as formatting or data organization in VBA. One of the biggest benefits of Excel is its ability to organize large amounts of data into orderly, logical spreadsheets and charts. By doing so, it's a lot easier to analyze data, especially while creating graphs and other visual data representations. The visualization can be generated from a specified group of cells. Those were few of the features of Microsoft Excel. Let's now have a look at the companies using it. Most of the organizations today use Excel. Few of them that use it for analysis are the UK-based company Ernst & Young. Then we have Urban Pro, Wipro, and Amazon. Moving on to our next data analysis tool, at number 9, we have RapidMiner. A data science software platform, RapidMiner provides an integrated environment for data preparation, analysis, machine learning, and deep learning. It is used in almost every business and commercial sector. RapidMiner also supports all the steps of the machine learning process. Seen on your screens is the interface of RapidMiner. Moving on to the features of RapidMiner. Firstly, it offers the ability to drag and drop. It is very convenient to just drag drop some columns as you are exploring a data set and working on some analysis. RapidMiner allows the usage of any data, and it also gives an opportunity to create models which are used as a basis for decision making and formulation of strategies. It has data exploration features such as graphs, descriptive statistics, and visualization, which allows users to get valuable insights. It also has more than 1,500 operators for every data transformation and analysis task. Let's now have a look at the companies using RapidMiner. We have the Caribbean airline Leeward Islands Air Transport. Next, we have the United Health Group, the American online payment company PayPal, and the Austrian telecom company Mobilcom. So that was all about RapidMiner. Now let's see which tool we have at number 8. We have Talent at number 8. Talent is an open source software platform which offers data integration and management. It specializes in big data integration. Talent is available both in open source and premium versions. It is one of the best tools for cloud computing and big data integration. The interface of Talent is as seen on your screens. Moving on to the features of Talent. Firstly, automation is one of the great boons Talent offers. It even maintains the tasks for the users. This helps with quick deployment and development. It also offers open source tools. Talent lets you download these tools for free. The development costs reduce significantly as the processes gradually speed up. Talent provides a unified platform. It allows you to integrate with many databases, SaaS, and other technologies. With the help of the data integration platform, you can build flat files, relational databases, and cloud apps 10 times faster. Those were the features of Talent. The companies using Talent are Air France, L'Oreal, Capgemini, and the American multinational pizza restaurant chain Domino's. Next on the list at 7 we have KNIME. Constance Information Miner or KNIME is a free and open source data analytics, reporting and integration platform. It can integrate various components for machine learning and data mining through its modular data pipelining concept. KNIME has been used in pharmaceutical research and other areas like CRM customer data analysis, business intelligence, text mining, and financial data analysis. Here is how the interface of KNIME application looks like. Now coming to the KNIME features. KNIME provides an interactive graphical user interface to create visual workflows using the drag and drop feature. Use of JDBC allows assembly of nodes blending different data sources, including pre-processing such as ETL, that is extraction, transformation, loading, for modeling, data analysis, and visualization with minimal programming. It supports multi-threaded in-memory data processing. KNIME allows users to visually create data flows, selectively execute some or all analysis steps, and later inspect the results, models, and interactive views. KNIME Server automates workflow execution and supports team-based collaboration. KNIME integrates various other open source projects such as machine learning algorithms from Becker, H2O, Keras, Spark, and our project. KNIME allows analysis of 300 million custom addresses, 20 million cell images, and 10 million molecular structures. Some of the companies hiring for KNIME are United Health Group, ASML, Fractal Analytics, Atos, and Lego Group. Let's now move on to the next tool. We have SAS at number 6. SAS facilitates analysis, reporting, and predictive modeling with the help of powerful visualizations and dashboards. In SAS, data is extracted and categorized, which helps in identifying and analyzing data patterns. As you can see on your screens, this is how the interface looks like. Moving on to the features of SAS. Using SAS, better analysis of data is achieved by using automatic code generation and SAS SQL. SAS allows you to access through Microsoft Office by letting you create reports using it and by distributing them through it. SAS helps with an easy understanding of complex data and allows you to create interactive dashboards and reports. Let's now have a look at the companies using SAS. We have companies like Genpact, IQVIA, Accenture, and IBM to name a few. That was all about SAS. So for all those who joined in late, let me just quickly repeat our list. At number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talent. At number 7, we have KNIME. And at number 6, we have SAS. So far, do you all agree with this list? Let us know in the comment section below. Let's now move on to the next 5 tools in our list. So at number 5, we have both R and Python. Yes, we have two of them in the 5th position. R is a programming language which is used for analysis as well. It has traditionally been used in academics and research. Python is a high-level programming language which has a Python data analysis library. It is used for everything starting from importing data from Excel spreadsheets to processing them for analysis. This is the interface of R. Next up is the interface of the Python Jupyter Notebook. Let's now move on to the features of both R and Python. When it comes to the availability of R and Python, it is very easy. Both R and Python are completely free, hence it can be used without any license. R used to compute everything in memory and hence the computations were limited, but now it has changed. Both R and Python have options for parallel computations and good data handling capabilities. As mentioned earlier, as both R and Python are open in nature, all the latest features are available without any delay. Moving on to the companies using R, we have Uber, Google, Facebook, to name a few. Python is used by many companies. Again, to name a few, we have Amazon, Google, and the American photo and video sharing social networking service, Instagram. That was all about R and Python. At number 4, we have Apache Spark. Apache Spark is an open source engine developed specifically for handling large-scale data processing and analytics. Spark offers the ability to access data in a variety of sources including Hadoop Distributed File System HDFS, OpenStack Swift, Amazon S3 and Cassandra. It allows you to store and process data in real time across various clusters of computers using simple programming constructs. Apache Spark is designed to accelerate analytics on Hadoop while providing a complete suite of complementary tools that include a fully featured machine learning library, a graph processing engine, and stream processing. So this is how the interface of Apache Spark looks like. Now let's look at the important features of Apache Spark. Spark stores data in the RAM, hence it can access the data quickly and accelerate the speed of analytics. Spark helps to run an application in a Hadoop cluster up to 100 times faster in memory and 10 times faster when running on disk. It supports multiple languages and allows the developers to write applications in Java, Scala, R, or Python. Spark comes up with 80 high-level operators for interactive querying. Spark code for batch processing, join stream against historical data, or run ad hoc queries on stream state. Analytics can be performed better as Spark has a rich set of SQL queries, machine learning algorithms, complex analytics, etc. Apache Spark provides fault tolerance through Spark RDD. Spark resilient distributed data sets are designed to handle the failure of any worker node in the cluster. Thus, it ensures that the loss of data reduces to zero. Conviva, Netflix, IQVIA, Lockheed Martin, and eBay are some of the companies that use Apache Spark on a daily basis. At number 3, we have another important growing data analysis tool, that is ClickView. ClickView software is a product of Qlik for business intelligence and data visualization. ClickView is a business discovery platform that provides self-service BI for all business users and organizations. With ClickView, you can analyze data and use your data discoveries to support decision-making. ClickView is a leading business intelligence and analytics platform in Gartner Magic Quadrant. On the screen, you can see how the interface of ClickView looks like. Now talking about its features. ClickView provides interactive guided analytics with in-memory storage technology. During the process of data discovery and interpretation of collected data, the ClickView software helps the user by suggesting possible interpretations. ClickView uses a new patent in-memory architecture for data storage. All the data from the different sources is loaded in the RAM of the system and it is ready to be retrieved from there. It has the capability of efficient social and mobile data discovery. Social data discovery offers to share individual data insights within groups or out of it. A user can add annotations as an addition to someone else's insights on a particular data report. ClickView supports mobile data discovery within an HTML5-enabled touch feature which lets the user search the data and conduct data discovery interactively and explore other server-based applications. ClickView performs OLAP and ETL features to perform analytical operations, extract data from multiple sources, transform it for usage, and load it to a data warehouse. The companies that can help you start your career in ClickView are Mercedes-Benz, Capgemini, Citibank, Cognizant, and Accenture, to name a few. At number 2, we have Power BI. Power BI is a business analytics solution that lets you visualize your data and share insights across your organization or embed them in your app or website. It can connect to hundreds of data sources and bring your data to life with live dashboards and reports. Power BI is the collective name for a combination of cloud-based apps and services that help organizations collate, manage, and analyze data from a variety of sources through a user-friendly interface. Power BI is built on the foundation of Microsoft Excel and has several components such as Windows desktop application called Power BI Desktop and online software as a service called Power BI Service, mobile Power BI apps available on Windows phones and tablets, as well as for iOS and Android devices. Here is how the Power BI interface looks like. As you can see, there is a visually interactive sales report with different charts and graphs. Moving on to the features of Power BI. It has an easy drag and drop functionality with features that make data visually appealing. You can create reports without having the knowledge of any programming language. Power BI helps users see not only what's happened in the past and what's happening in the present, but also what might happen in the future. It offers a wide range of detailed and attractive visualizations to create reports and dashboards. You can select several charts and graphs from the visualization pane. Power BI has machine learning capabilities with which it can spot patterns in data and use those patterns to make informed predictions and run what-if scenarios. Power BI supports multiple data sources such as Excel, Text CSV, Oracle, SQL Server PDF, and XML files. The platform integrates with other popular business management tools like SharePoint, Office 365, and Dynamics 365, as well as other non-Microsoft products like Spark, Hadoop, Google Analytics, SAP, Salesforce, and MailChimp. Some of the companies using Power BI are Adobe, AXA, Carlsberg, Capgemini, and Nestle. Moving on to the next tool. So any guesses as to what we have at number 1? You can comment in the chat section below. Finally, on the top of the pyramid, we have Tableau. Gartner's Magic Quadrant of 2020 classified Tableau as a leader in business intelligence and data analysis. Tableau Interactive Data Visualization Software Company was founded in Jan 2003 in Mountain View, California. Tableau is a data visualization software that is used for data science and business intelligence. It can create a wide range of different visualization to interactively present the data and showcase insights. The important products of Tableau are Tableau Desktop, Tableau Public, Tableau Server, Tableau Online, and Tableau Reader. This is how the interface of Tableau Desktop looks like. Now, coming to the features of Tableau. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. Tableau delivers interactive dashboards that support insights on the fly. It can translate queries to visualizations and import all ranges and sizes of data. Writing simple SQL queries can help join multiple datasets and then build reports out of it. You can create transparent filters, parameters, and highlighters. Tableau allows you to ask questions, spot trends, and identify opportunities. With the help of Tableau Online, you can connect with cloud databases, Amazon Redshift, and Google BigQuery. The companies using Tableau are Deloitte, Adobe, Cisco, LinkedIn, and the American e-commerce giant Amazon, to name a few. And there you go, those are the top 10 data analysis tools. Let's now have a question and answer session. Please feel free to post your queries in the comments section and we'll respond in the chat. Before the question and answer session, let's recap quickly. In the meanwhile, y'all can post your questions in the comment section below. So at number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talent. At number 7, we have Nime. At number 6, we have SAS. R and Python at number 5. Apache Spark at number 4. ClickView at number 3. Power BI at number 2. And finally, we have Tableau topping the list at number 1.
Welcome to this tutorial on Microsoft Excel. So we will learn about functions and formulas. We will learn about conditional formatting, data validation, pivot chart, and pivot table. Now let's look at a scenario here. So one day in a startup, one professional speaks that their business is growing and they would need an efficient way to work with the data. They would have to find a way to work faster with storing and analyzing data. Now, to that, another colleague responds, well, we can make use of Microsoft Excel to do this job. The question is, will Excel be able to cater to their business needs? Now, the colleague responds, well, we can make use of Excel in several ways, and it also is a cost-efficient option. Now, in that case, the colleague who posed the question says, let's go ahead with Excel and let's train our employees in Excel. And the suggestion is welcomed, which would make the job easier for them. And they would basically decide on using Excel. So they decide on taking a training right away and basically starting to learn Excel. Now, before we move to Excel, one of the questions is, why should we use Excel? So let's look at some of the points here. So Excel proves to be a great platform to perform various mathematical calculation on large data sets, which is one of the biggest requirements of various organizations these days. Various features in Excel like searching, sorting, filtering makes it easier for you to play with the data. And Excel also allows you to beautify your data and present it in the form of charts, tables, and data bars. Now, when it comes to reporting, accounting, and analysis can be performed with the help of Excel. It can help you with your task lists, your calendars, and goal planning worksheets. Excel also provides good security for your data. Excel files have the feature of password protection. This way, your information can be safe. Now, when we talk about what is Excel and how it can be used, so Excel, or you might have heard as spreadsheet, can be basically used for a lot of different tasks than just storing the information in so-called tabular format. Now, Microsoft Excel is an application that is used for recording, analyzing, and visualizing data. It is in the form of a spreadsheet. Let's have a look at few of the functions and formulas used in Excel. And before we do that, we can also quickly take a small tour to understand how to work with Excel. Now, to do that, what we can do is we can type in our search, say for example Excel, and just select your Excel app which is installed. And here you see you have a lot of options which says take a tour, drop down list, get started with formulas, make your pivot table, going forward with pie charts, and much more. So we can click on this one which says take a tour. and that basically pops up a window which says welcome to Excel. And if you have always wanted to be better at Excel, you have this which can help you. So let's click on create, and that takes us to the store window. Now that says instructions for screen readers, which basically talks about 10 different steps in which we can learn Excel and using the spreadsheet app. So there are more than 11 sheets which we see here at the bottom end, and each one gives us a simple example which we can work on. So for example, if I click on add, now that takes me to this page which says how do we add numbers. Now you might be provided data which we can upload by loading a file from our machine, or getting data from a web source, or even connecting to a database. So there are various options which we will see in some time. So here we have an option which is called data. You can click on this one, and this basically has options where you can use existing connections. If you have created some, you can always click on from other sources, and you can get your data from SQL Server, from analysis services, from OData data feed. You can get in from XML, from data connection wizard, or also from Microsoft Query. You can be running in different queries here, which shows up in the option which says new query. There are connections which you can use, and that basically will display all the connections for this particular workbook, which we do not have as of now, but we can create them. But let's look at simple examples. Now you can follow these instructions here, which says basically adding up the numbers, and that could be easily done by just placing your cursor here. And what you could do is either you can type in the formula, that is from which row to which row you would want to add the data. So for example, I could just do a sum here, and that shows up all the different functions which are available. Then we can open up a parenthesis, and we can say I would be interested in totaling the amount from column D, and I would select, for example, D4. So I could be doing this, and then I could say D4 onwards till D7. So that's the data which I'm interested in. You can close your parenthesis and hit enter, and that gives you the total. There is also a shortcut for this, which you can always do, is we can first delete this, and you can just place your cursor here and just use your alt and equals. That automatically selects the numericals, which we can anytime expand or basically collapse. So I will basically select this, which says this function needs two numbers, which is number 1 and number 2, and then you can hit on enter, and that gives you the total. So similarly, we can be getting in the data here by selecting all the fields. So here it also says that you can use a shortcut. Now what we can also do is we can add numbers over 50 by selecting the yellow cell here, and then giving a condition such as, so I can basically use something like sum if, and then open a parenthesis. I can select I would be interested in this row, and then I can even drag and drop till here. So that tells me D11 to D15. You can then put in a comma here, and you can give your condition. Say for example, we would say I would be interested in numbers only above 50, and we can select this, close your quotes, and then just close your parenthesis, and that's your formula. So you can do this, and that basically gives me the total is 100. Now similarly, we could do that for the amount here. I could select this. Now there is also an option, I can click on home, and I can go for something like auto sum. So that's one more way of doing it, which anyways says sum is alt plus equals. So it automatically adds up your values, and I can try doing a auto sum that automatically selects my rows, and then I can get my total. Now as per this activity here, it says try adding another sum if formula here, but add amounts that are less than 100, and the result should be 160. So what we can do is we can basically select all the numbers which are lesser than 100. So the way we did earlier here, there can be always a shortcut. So you can always, for example, if you would want to avoid typing in the formula, you can always copy it from here and then just hit on enter. So you are back into this cell, and then I can basically go here and paste the number, and then as per the requirement, we are required to select anything which is lesser than 100. So what I could do is I could select here, I could say, let's say G, and then I can change this value to G15, and that's one more way. Now we see our selected rows have been changed, so I can hit on enter and I can check what is the result. So we would be interested in looking for numbers which are lesser than 100, so I will have to also change this one to a lesser sign, and that basically gives me the total, which is 160. So that's how you can simply add numbers. You can use auto sum, you can type in the formula, you can select the fields, or you can just place your cursor where you would be looking for a sum, and then you can just do a alt equals, and that basically populates the sum. Now let's look at some easy options of filling your cells or automatically populating the values in your cells within your Excel sheet. Now here we have an option which says 100. Now we can click on this, and that basically says it is making a sum of column C4 to D4. So if I click on this one, I can check that this is row number 4, which shows up here, and I also know this is column C. I also have D, so this equals is basically giving me a sum of C4 to D4. Now what we can do is we can always place our cursor here at the right corner, and then we can just drag and drop, and this basically gives me a total of all the numbers for all different rows. So this is one shortcut which we can do to get the total. Excel will automatically give the totals, which we call as filling down. Now what we can do is, in the same way, if we would want to get the totals here, we can first check what is this 200, and this tells me it is C11 to C14 total. So it is totaling the rows from C11, so column C and 11th row, till 14th row, and that's the sum. Now what I can also do is I can similarly, like above, we can do a filling right, which basically means bringing your cursor here and then just dragging and dropping it all the way where you would need the totals, and this basically gives me the total. There is one more quick way to check if this is right. So the easiest option would be to select this cell. Now what I can also do is I can just select all of these fields by just highlighting and selecting all the fields. Once it is selected, press on Control R, and that gives you the total. Now if we would be doing this top down, then I could select all these rows for this particular column, and then I could do a Control D. So that's your filling down, and this one was filling right. So this is an easier option of doing a fill when you would want to have the formula applied to every row as it occurs in the first row or the last row. We could test this by, for example, selecting these fields. I could delete them, and I have here which says 130. I could just place my cursor here and I could drag it all the way up, and that should also do the same magic which we were seeing from top down. So this is a simple way wherein you can fill up your cells, and you can also automatically propagate or move your computation to all the cells. Let's look at the split option, which basically helps us in splitting the data when we have some kind of pattern or when we have some kind of delimiters in our data. in say one particular column and we would want to derive the values out of it, so we can always use the splitting option. Now the easiest option would be, so for example, we have our email column which has the email IDs and which we can clearly see has a first name dot last name. Now I see that there is a last name Smith filled up here, first name is empty. So what I can also do is I can just type in say Nancy here. Now that's the first name. I can again start typing the second name, and as soon as you do that, you would see a faded list of numbers, and that's your clue to hit enter. And once you do that, you would see all the first names have been filled in here. If you would want to maintain the case sensitiveness, you can just go ahead and delete these, and let's type in as it occurs. So let's say Nancy as the first name, go down to the next cell and just type in Andy, and there is your grade list. So just hit on enter, and that basically fills up your first name. What we can also do is we can just select this particular field, and either we can type in Control E, which basically fills up all the options. Now I can just do a undo by typing in or clicking Control Z, and that's basically gone. What I can also do is I can select a particular field, and then I can go into home option, and under home you have an option here which says fill. So you can select this, and then you can do a flash fill, which is what we are doing here. So click on flash fill, and that automatically fills up the values. So in this way you can work within your spreadsheet, and you can be filling up the values where a delimiter by default is understood, and we can split the data. Now however, sometimes you might have some data which has a different kind of delimiter, and there is again a smarter way of splitting your data. So you can always scroll down here, and that says splitting a column based on delimiters. So we have some values in the data column, and these values in each row are separated by comma. So select this. Your data is already selected. Text to columns, delimited, comma is selected, and now click on next. So it basically says what is the destination. Let's select this one, and I can choose what would you want to have. So that shows me this would be my data preview. Now I can basically select this one. I can say finish and say okay. And now if you see, our data has been placed in the columns appropriately. So this is how you can split your data based on a delimiter and then organize your data in a better way. Now there are some advanced options which we can learn later, but this basically tells about using a formula. So this is something, if we have some name in one cell, and if you would want to split it into first name, your helper column, your middle name, last name, so that can also be done using formulas. And this basically tells how would you extract characters from your left cell and how would you place them in your right cell. So you can try this activity, which is a little more of advanced option. The benefit is that you can always use this, wherein if you do some kind of transformation using your formulas, if your original data gets updated, then the split data will also get updated. And that's the benefit of using formulas, where you can place values from one cell into multiple cells based on execution of your details in the formulas. How about using the transpose option? Now, you might have heard of situations where you would want to switch or turn your rows into columns and your columns into rows, and that's where transposing comes into picture. It might be useful when you have your data in your X and Y axis, or as I would say in rows and columns, and you would want to switch your rows to become the columns and columns to become your rows. So what we can do is, the simplest way is you can select all your values. So here we basically have 6 columns and I would say 2 rows. Now I can select all of these and then I can select an empty field. For example, the one which is highlighted here. Well, you can always do a Control Alt V. That's a shortcut. What you can also do is once you have selected all your fields, you can just copy them. So just do a Control C and then click on an empty cell, and then what you can do is you can do a special paste or paste special. So under your home you have the paste option and here you can go for paste special, and once you do that you need to select the transpose option over here and click on OK, and now you will see that the columns and the rows have been transposed. So your row name was item and that has become the column heading. You had row name as amount and that has become the column heading, and all your values have been transposed in this particular format. Now there is another way of doing that, and again that's using your formulas. So what you can do is you can transpose with a formula also, and that basically works when you have similar kind of data. So this has 6 columns and basically 2 rows. So you can basically do this. So you can select this, and earlier we were doing a copy, but now what we would want to do is we would want to just look at the row numbers, which tells me it is C33, C34, and it starts with C and ends in with your H column. So what we can do is we know that we have 6 columns and 2 rows. So transposing that would actually give me 2 columns and 6 rows. So what we can do is we can select 2 columns and 6 rows in our Excel sheet. I can then basically start typing in the message, or I can just go to the address bar and here I can say transpose. Let's go for C33, H34. It basically selects my data, and now I can just do a Control Shift and enter, and now if you see all the values have been populated. Now you can just place your cursor in one of the cells, but if you see the address bar, the formula remains the same. This is because this is an array formula. So we can read more about an array formula here. It's basically something which performs calculations on more than one cell in an array. And in the example here, the array is the original data, that is C33 to H34. So your transpose is just changing the horizontal orientation to the vertical orientation. So this is a very simple way in which you can basically use the Excel's capability to transpose your data and convert your rows into columns and columns into rows. Apart from working on additions, subtractions, filling up your data, sorting the data, or basically splitting your data, transposing your data, one of the other requirements is sorting and filtering your data. Now that can be very handy when you're working on huge data and you would want to sort it in a particular order, say ascending or descending, or might be based on a particular field, or if that field was, or if the cell was highlighted with a particular color, sorting the data. So let's look at how Excel can be used for sorting and filtering. Examples are pretty simple here. So let's check that. So if we go into sort and filter and say this is the data I have, say for example I would want to sort the values in the department column alphabetically. So what I can do is I can select department column, and I'm already in the home tab. I can straight away go here which says sort and filter. I can then say sort A to Z, and that's basically alphabetically sorting your department column. And once I do this, you would see the data has been sorted, but it's not just this data. We can just do a Control Z and check what are the values we have. So here we have meat, which is beef, and 90,000, 110,000, the values. Then you have bakery, which should ideally be the first row, if we sort it in an alphabetical order, which goes with bakery as desserts, you have the values. So we can check this again. So select department and then just do a sort and filter, and let's say sort A to Z. And if you see, the data has changed, but it's not just in changing your first column, but then it has taken care of all the data. However, the data has been sorted based on the department column. So you have bakery, which aligns with desserts, which has the values, and now we have all the data which has been filtered. Now what we can also do is we can sort December's amounts from largest to smallest. So what we can do is we can basically click any cell in the December column, let's say 20,000, and then what I can do is I can go into sort filter, and then I can say sort largest to smallest. So if you see, bakery breads is the row which has the smallest data, or might be you have deli sandwiches, so that one looks also smaller. So let's do a larger to smallest, and if I do this, you would see the values have been shifted now. So it is no more based on the department column, because now the data is being sorted based on the values in the December column. And you see bakery, which was alphabetically the first one, has become second last. So either you can sort the data based on a department column, which goes based on the values. These are all string values or words, so it sorts alphabetically. If you have numbers, might be you can give some values and you can sort the data. You could anytime do a custom sort, and you could basically select if you would want to select the data. So I could do a custom sort, and then I could choose which is the column which we would want to use for sorting, what is the sorting needs to be done, is it cell values, is it cell color, font color, conditional formatting, and then you can also choose the order. So that's one more way to do that. Now, if you scroll down, that also shows how you can sort by date or a color. So for example, if you would want to sort based on the expense date, so there are different options. So what I can do is I can select this date field. I can just do a right click. I can go into sort, and then I can choose. I would want to sort oldest to newest. So since I selected the date field, it basically has sorted all the data, and it has taken the expense date into consideration. Now there are these filters which you see on the row headings. We could have also used those. So I could have selected this, and that basically says or mentions which are the dates I would be interested in looking at. I also have sort by color here. I can do a sort oldest to newest or newest to oldest. So I could also use these filters which have been applied here. Now we have the data which is in color. So if I would want to basically select the color columns or color cells, I could select this. I can basically do a right click here, and when I go into sort, I could choose put selected color or cell color on the top, and that basically will make sure that my data is sorted, and it has also sorted that in a descending order. So in this way you can sort or basically filter your data. What we can also do is we can add filters. So sometimes we can go for formulas which we would want to use. What we can also do is we can basically select the filter which has been applied here. Now how does the filter come in there? So if I would select a particular row, I could select a particular row, and then I could decide if I would want to just add a filter to this one. And that's how the filter has come in. So we have the filter. What we can do is we can basically click on this drop down, and then you have something like number filters. So we can always go here. We can basically choose one of these. So we can basically choose above average. So I could select this, and then basically it shows me the values. We could also delete the filter by clicking on this one, and we could say, well, I'm not interested in this filter anymore. So I could clear the filter, and that shows me all the values. Or I could say that let's click on some other field, for example food. I can go in here, I can go into number filters, and then I could say, well, I'm interested in values which are below average, above average, might be greater than, and then I can choose what is the value. So for example, if we say I'm interested in food which is greater than $25, I could give a value here, I could say okay, and now I have applied the filter. Similarly, you can select this and then you can just clear your filter and your data is back. So remember, no data is lost. It is just hidden, or basically based on the filter not shown. So that's good enough for us. And in this way, you can sort and filter the data. So for more details, obviously in all these sheets, you have the links which point to more information on the web, and you can always refer to these. So this is simple way in which you can sort and filter any amount of data which has been stored within your Excel within a particular sheet. Now that we have learned about add, fill, split, transpose, sorting, and filtering, it will also be good to learn how to work with tables, or basically converting your data into a tabular format and then doing some easy computations. So click on this tables option here. Now here we see there is some data which is in 5 columns and n number of rows. So I can basically select this data, and then what I can do is I can insert, choose the table option, and then it says my table has headers, and we'll be okay with that. I'll say okay, and now if you see, this is the table created. It basically has different filters which we have learned earlier how to use, and this is basically my table, which is a collection of cells which has some special features. So we can easily add rows to this table, we can add columns to this table, and we can even do some calculations. So for example, here I can click on this one, I can basically enter some field, and then I can hit on enter, and we see that this row has been inserted, wherein we can easily fill in values. For example, I would say chocolates. I could give some value here, say 25,000, might be 35,000, and then basically I can give in some values here. Now what you can also do is you can continue adding rows in this way, and say for example you would want more columns, so you can select this option here in the top bottom right corner. You can just drag it towards the right, and that basically has automatically created columns for my next months wherein I can feed in the data. So this is a simpler way wherein you can keep adding more rows and columns to your data if that has been converted in a tabular format. Now let me just do a Control Z, that basically deletes the columns. Again Control Z deletes the last row which we added, and I can stop here, or I can even remove my values by doing multiple Control Z and removing my rows. So this is how I converted my data into a table, and then I can easily work on this. What I can also do is I can do some calculations. So what we can do, we have a table here, we have a total field, and what we can do is we can just select one cell here. Now as we have learned earlier, we can do a alt and then equals, and that basically says what is this doing. So it says it is calculating the sum of the last 3 months, and if that's what you would want to do, just hit on enter, and it has automatically calculated the totals for all your rows for these 3 columns. So the sum formula is getting filled up. Now I can select any particular cell and I can look in my address bar. So it has already given me the formula where it has started calculating the sum from the October column till the December column, and has given me the calculated values of the columns. What we can also do is we can get total rows in the table. Now that's a simpler option. So what we can do is we can select any cell in this particular table, And then we see that there is a table tools design option showing up here. Now I can select this, and then it says, well, let's get a total row. So let's select this, and it automatically populates the total here. And if you would want the average, then we could select this, and from the drop down I can select what I'm interested in. So for example, I would want the average values and not the total. I could just select this, and that gives me the average of these values. So we can always do simpler computations here by converting our data into table format. Let's learn about one more efficient way of working with the data, and that's using your drop downs. So let's see how drop downs work here. Now, say for example, you have this data which has the values in the food column and department is empty. And say for example, you would want to enter the values in department. However, you would want to select that department should either have produce or meat and bakery, and these are the only three options which should be available for any user to fill in the values. How do we do that? So we can basically create a table by pressing Ctrl D. So what I can do is, under my department here, I can select one of the cells, and then I can do a Ctrl T. That basically converts this into a table. I can say OK, and my table is created. Now what I can do is, once this part is done, we can select all the blank fields here where we would want this drop down to be applicable. Now under your data tab, you can go in and select data validation, and this has an option called data validation. Click on this, which basically says allow any value. So here I will select, I would want to give a list of values, and then I can type in my values here, which I can say produce, say for example meat, and then say bakery. Now these are the values, so we can click on OK. And once we have done that, we basically have a drop down here next to apples, which will only show us the values which we can feed in under the department column. So I can go into every cell, and then I can basically choose what is the department which handles this, and then basically I can select one of these from the drop down. So this is an easier option of creating your drop down and then feeding in the values from the set of values which you have defined here on the right. So this is a simple example of using your drop downs, working with your tables, working with your sort and filter, transpose, split, filling up your data, adding in some data here. And similarly, you can use Excel for more than one use case using its inbuilt features to easily work with your data. Let's see how we can import data or bring in data into our Excel from your local machine or from an external web source. So what we can do is we can open up a blank Excel sheet and say, for example, you have been provided a text file or a CSV file and you would want to import that data into your Excel sheet. That can be easily done. So right now I've opened an Excel sheet. Now I can click on data, and here I have an option which says existing connections from other data sources. So, or you can click on connections if you have already created some. So we can click on from other sources. So this is one option where you can connect to your different data sources and you can get the data from one of these. What we can also do is I can click on connections. Now it says there is none. I can click on add. It says, well, show the connections where connection files on network, connection files on this computer. So I can say, let's get some files from this computer. Now, if that does not show up something, so say browse for more, and that basically shows you different options. So let's basically select a folder where I have some data sets. I'll click in here, and this is basically a folder where I have some data sets. Now let me select this particular file, and I know it is a CSV file. So let's click on open. Now if you would want to verify this, you could have gone and looked into the properties of the file, and it says it is a .csv file, which is what we are interested in. So I'll take this file, I'll say open. Now this basically shows me the text import wizard option, which says is the file delimited. I'll say yes, click on next. So I will select comma as my delimiter. I can say text qualifier is none. Now this is my data. So my data preview is already showing me the data is what is the data in the CSV file. You can click on next, and then you have an option which says data format is general. You can go for date format, you can go for advanced options. So I'll just say finish, and basically now this has been created here. So we basically have this, and now I can click on close. Now once you have done that, you can click on existing connections. It shows me the data which we have here, the connection which we have created, say open, and then it says, do you want to import this data or bring this data into existing worksheet? You can also say add this to a data model if you are doing some data modeling. So click on OK, and now this data is automatically inserted in my Excel file. I can basically save it into this particular sheet. Now what we can also do is we can also start a new sheet, and that does not have a data, and we can get some other data from web. So what I can do is I can go into my GitHub, and let's say I would be interested in this CSV file. So I can select this, and this is my GitHub path, a path on web. So I can click on raw, and that basically gives me the raw path where this particular file is. Now you can select this, copy this particular path, and here you can come back to your Excel sheet. We would be interested in getting the data from web, might be from a text file where we will have to specify the delimiters, or let's go to web, and here I can give in the web path from where I would be interested in getting the file. Let's give the GitHub path, which is publicly available, and then click on import. Now once you click on import, it tells me there are two fields, data and value. These are within double quotes, separated by comma. So first let's click on import. Now once we do this, it will basically get the data from web and put in here. It says existing worksheet, so we had already created a new worksheet. So let's click on OK, and now you have the data coming in, but then this basically shows me in one particular field. So what we can also do is we can just do a Control A, that selects all my columns here, and that's my data. So we can then basically filter this out. So we can say text to columns. It's a delimited file. Click on next. We can select comma and let the text qualifier be quotes. It shows me data preview. Click on next. So you have the general format. It shows the destination, that's the column. Click on finish, and now your data has been split, and you have the data which you have imported from web. So this is the data which is coming in from web. This is the data which came in from my local machine. And similarly, we can even create connection with an existing database. So I can basically click on connections if I would want to do that. So I have an option called connection here, and it says where the selected connections are used. I can basically click on add. I can basically choose if I would want to get the files from network or from computer like we did earlier. I can click on browse for more, which should show me different other options to create connections. Say you would want to create a new SQL server connection. You can connect to a new data source coming in from different place. You could basically choose what kind of connection would you want. So these are all the different options which we can go for, and we can basically connect to a database. For example, if I have some database and say, for example, access database. I can see if there are some files with that particular database and I can import it. So similarly, we can also click in here which says new query, and that also gives you an option of getting the data from your files, from all these folders, from databases. So you can basically click here and then you can import data from a MySQL database, provided that is set up on your local machine or on a particular server. You can go from cloud, you can get it from online services, you can get it from other sources, which says from web, from your Hadoop file system, from Active Directory, from a blank query, and you can even combine queries wherein you can run a Power Query editor. You can get the data from different sources and then you can bring it into your Excel. So in this way, you can get your data from different sources into your Excel, into your spreadsheet, and then you can continue working on those data sets. We have already learned some basic operations which you can do in Excel, and let's implement our knowledge by working on this particular data which is coming in from housing data set. Now here, if we see some fields, we have agent, date listed, area, list price, and this is basically the data which has been sorted in newest to oldest order of date listed. So how do we arrive at this? So what I can do is I can just click on data listed, and then I can either go in here, I can select sort, I can get into custom sort, and then I can choose the column based on which I would want to sort the data. So I would look for the newest data to the oldest data. That means that would be in a descending order of dates, or you could say the oldest date or the earliest month will be towards the lower side of your sheet. So here we can select date listed. Now I can say let it sort based on cell values and the order what we have here. So we have newest to oldest. So let's select this. I can say okay, and now if you see, the date has been sorted. So we have your 10/18/2007 on the top, so that seems to be the latest date, and as we go down we will see an earlier month or an earlier month than that in this date listed. So we have sorted our data into newest to oldest order, and that's based on your date column. So the result shows up here. Now what we can also do is we can have different questions which we would want to answer. So for example, I would want to sort the data in ascending order of area and descending order of agent name. How do we do that? So let's look into this. So this is here. I already have the result here. And how did I get this? So I'm looking for ascending order of area and descending order of agent name. So we can start with any particular column, that does not matter. So for example, if I look into this Excel sheet, I have my agent name, select this, which we want in a descending order. So we could either do a sort and then go for descending sort Z to A. We could also use the filter option here on the top right, and we could do it, or I could just say sort Z to A, and then it has arranged the data based on the agent column being in descending order. Now I can go into area and then I can again do a sort, and I wanted my area column to be used for sorting the data in ascending to descending, and that basically not only changes the order of this particular column but for my complete data. So let's do that. And now if you see, we have the data which has been sorted. So we can see how many values we have here and the area values which we see, and this is how you get your result. So I'll just do a Control Z and again, and I'm back to my original data, and this is the sorted result which we are seeing at. Similarly, we can answer other questions. For example, sort the data according to the following order of area. That is, we are saying county, central, and then your county. So we can basically choose in which particular way we would want to do it. So it is county, central, and then again county. So if I look into my sheet 3, so here I basically have my data which is having some South County, then you have your Central, and then you have your North County. So we would want to sort the data to solve our problem, which is according to the following order. So first we go for area, then we go for South County, Central, and North County. So what we can do is we can basically have area field selected, and I would want to sort this particular data. So I have South County, Central, and North County. So I can basically go for custom sort, and then I can choose which is the value or column which I'm interested in. Let's go for area. We will go for something like cell values. Well, you can also try to explore conditional formatting icon if this is what you would want to use, or we can basically go for just cell values. And here we can say if I would be interested in first getting my values for South County. So for example, I can say custom list, and then I can basically give in the new list here. So I can say s dot county, and then I would want central, and then I would want North County. So let's select this as it exists. We can basically say add, and that's basically the order which we want. Say okay, and then say okay here. And now what we would want is we would want our data, so we can compare that with the values which we see here. It starts with Kelly. You have in the 12th row something like Lang, and that's what we are doing. So we can basically arrange the data in a particular order by choosing a custom list and then sorting your data. So that's one more simpler task what we have done, where we have sorted the data in the order where under our area column, we first wanted South County, then we wanted central data, and then we wanted North County. So this is how you can do it. Now, let's look into one more problem. So it says find all the houses in the central area, and we would want to basically apply a regular filter. Let's see how do we do that. So we can click on this, and here we have the data. So the problem statement is we would want to find all the houses in central area. Now how do we do that? We can do a sorting, but we would want to use the filter which you see here is implemented. So how do you do it? So you can select this area, and say for example I would want to apply filter. I can just go in here and I can say let's get a filter on my first row, and now I have filters applied. So we are interested in looking into the central area houses. Let's go in here. It says all these fields are selected. That means it shows everything wherein your area has all these values. Let's unselect this, and then I will only be interested in the central. So let's say okay, and then say okay. So now you see the area filter has been applied, and we are looking at the central column. So what we have done is we have applied a simple filter, and we are looking at our data. At any point of time, if you do not want the filter, then what I can do is I can select this, and I can say, well, I'm interested in all the data. So I could do this, or you can clear the filters from area and you get your data back. So that's in one way you can filter out your data. So let's look at an example of sort and filter, where we might have to filter the data based on two columns or multiple columns with different kind of values, where it could be and an or condition. Now say for example this is the data I have, and this is the question which we need to answer, such as find the list of all houses in the central region with pool and South County without pool. Now if it was a simple filter based on one cell, I could have just selected my header row. I could have then applied the filter, and once I have the filter, I can look in area where I have 3 regions. So I'm only interested in Central and South County, so I can get rid of North County, and that's fine. But then we have 2 different conditions here. So we need the data in Central region to have the value for pool being true, and for South County the value has to be without pool. Now how do we do that? So what we can do is we can first create a copy of these headers here. So let me do that. Now the area has to be South County, so basically I can either just select this and I can choose this value, and then I can select this and then I can choose Central. So that's the criteria which I have, and the pool value has to be, so Central region should be with pool, so then this one basically has to be true, and this one has to be basically false. So South County is without pool, so let's select one of the values here, and this is my criteria. Now to get my result, we can always place your cursor here and you can check this is M column and 8th row. Okay, so we would want the result here. So let's go ahead and now click on data, and then in filter you have an option called advanced, and here what I can do is I can say I would want to filter the list in the place, but that's not what I would want to do. So I'll say copy to another location, and here if you see the list range will tell me that this is the data, so A1 to J126, so A to J column selected and all the rows. Criteria range is basically based on what I've given here, so that is M from 1 to V, which is 3. So I'm selecting these columns and then I'm saying all the way whatever criteria I've given, and copy to, I'm saying M8 to V8. So that basically will give me my filtered result. So you could basically just say okay, and now I have my data which has been filtered, and I have my area which is South County, that is without pool, Central with pool, again South County without pool, and then if you look at your Central value, that's pool. So this is an advanced filter which we have applied, where simply we have filtered the data based on 2 columns and then we have our result. So in this way you can have your customized filter applied on 2 different columns and get your data, which can be either replacing the existing content, or in the same sheet in different set of columns and rows you can have your result. Let's look at one more example of filtering where you are trying to filter the data based on an AND condition being met in 2 different columns, and then you would want to filter out the data for only specific columns. So the situation is the agents with a house in North County, that should be county, area having 2 and a single type family. So we are talking about 2 bedrooms, and we would basically have a single type family, and here the criteria is that we would want to only populate these columns, which is agent, area, bedroom and type. Now what you can do is, as I explained earlier, that you can get your result in the same sheet in a different location. So here I have created these headers which says agent, area, bedrooms and type. Now this is basically a copy of all the columns what we have here: agent, data listed, area, list price, bedrooms, bath, square feet and so on. So you can basically create a copy of the headers here, and this is where we will give our advanced criteria to filter the data. So the conditions which need to be met is we need to look at North County. So for example, here in area, I can basically go ahead and select one of the values, North County. Now the criteria is having 2 bedrooms only. So let's say bedrooms, and let's say the value should be 2. And then basically I am saying a single type family. So when you would want the single type family, so here under type I can give the criteria single type. So this is my AND condition. So we are saying North County area having 2 bedrooms and the type is single family. Now this is the criteria, which basically means if I select this one tells me that this is M1 row onwards till V2. So this is what we have, and we would want to filter based on this. So let's go ahead and then go for data filter advanced. And here in advanced, it says filter the list in place. Now that's not what we would want to do. So I'll say copy to another location. This basically selects the list range. So which is telling me A1 to J126. So that's the columns and rows selected. Criteria range is based on M1, V2, which we have given here. And copy to, I would say, for example, from M7 to P7. Now this is the area where this is the place where I want the result. Let's say OK. And now I get my data, which is based on the question which has been asked, that you would want the agents with a house in North County area having 2 bedrooms and single type family. So in this way, you can basically do advanced filtering, get your data and get it stored in the sheet anywhere at a different location. Well, I could have also done filtering in place, and that would have replaced the data which we have, but that's not what we want. We would want the filtered result in a different place. So this is how you can do some advanced filtering. We can also use Excel to filter out the data in one particular column, which might be conditional or say using some numerical filters. Now here, say for example, the problem statement is that you would want to display all the houses whose list price is between 45,000 to 600,000. Or say for example, we would want to filter out the data to something else. Say for example, let's say I would want to filter out the data between 300,000 and 400,000. So we can basically update this. Say for example, I'm saying I'm interested in 300,000 to 400,000, and that's the criteria to filter out the data. Now there are two different ways, or there are two easier ways to do it. One is I would want to look at the list price. So I can select this, I can go ahead and do a filter here, and in the list price, now this is where we would want to do the filtering. So it's pretty easy. You can click on this one and then you can go into number filters and you can choose between. Now that's one easier way of doing it. So I could basically select this. I could say I'm looking for value which is greater than or equal to 300,000 and then is less than or equal to 400,000. So if I just do this, I have applied my filter and I have my data which is filtered based on my criteria, right? So that's one easier way of doing it. Or let me do a Control Z. Now let the filter be there, which you can anyways use. But what we can also do is, as we have seen earlier methods, so get a set or get your column headers here, and then you are giving two columns here. Now the only difference between this set of columns, which I have 1 2 3 4, and then you have 7 and 10 columns, and if you see here we have 4 5 6 7 8 9 10 11, right? So whenever you want a AND condition, you will basically add the columns where I can give add condition if it is the same column. If it was a different column, then it would be same number of columns, but AND conditions will lie in the same line and OR condition would lie in a different line. Now here I can give this value, so I am looking for listed price being between 300,000. So I am saying it should be greater than or equal to 300,000, and then I can say less than or equal to 400,000. Now that's my criteria, and then I need my result here, which is in M7. So what I can do is, once I've given my criteria which I'll be using to filter, I can get into data, I can get into advanced, and then I can say copy to another location. So it is selecting my A1 to J126. Criteria range is based on M1 to W2, and then I would want my result from this particular column. So let's say OK, and now you have your data filtered out in a different location in the sheet, which has been filtered based on your AND condition. So you can filter out the data in this way, or you could just apply a filter on a column and give the conditions. Now let's solve one more interesting problem. And here we would want to use Excel, where we would have an and an or condition. So say for example, this is the data given to you, and the question is that you would want to find all the houses in North County. Again, that's a spelling mistake, but then they are North County area with a list price greater than 300,000 and having 3 or 4 bedrooms. So the bedroom has conditional, so it has or 3 and 4, and then basically you have list price which is greater than 300,000. Now I could have obviously selected the columns and then basically gone for a filter. So I can just do a filtering here, and then I'm looking for list price being greater than 300,000, so which we can always give a number filter, and I can say greater than, and then I can say greater than or equal. So I can say greater than, and then I can give 3,000, 30, 300,000, and that's basically the filter which we would want. And here I would want to select the bedrooms, which should be just either 3 or 4. So if for example here I go in here and I unselect this and then I say 3 and 4, right? So I am getting my data which is greater than 300,000, and it should have the bedroom values which will be either 3 or 4 selected. Now that's one way of doing it. Let's do a Control Z and get it back to as we were, or you can even just say clear filter, so you get your data back as it was. So what we can do is we can here give the criteria. So for example, I have my list price. Now this is what I would want as a condition. So let's say greater than 300,000, and bedrooms should be 3, and then I can say greater than 300,000, and then I can say 4. So this one basically gives me a situation where your list price has to be greater than 300,000 and bedroom should be either 3 or 4. So we have given our filtering criteria. Now to get the result, what we can do is we can go into data, we can go into advanced, and we can say copy to another location. So our list range is selected, which is columns A to J, row number 1 to 126. Your criteria range is given in M1 to V3, where we have specified, and we are saying the result would be in M7 to V7. So if I do this, now I have got the same data which we were seeing earlier, and here the bedroom values are 3 or 4, and basically the list price is greater than 300,000. So this is a simpler way in which you can create your filters. And all this advanced filtering, what we are seeing, it will be saved with your sheet. You can always go back and change this value, or you could do filtering where one person has to look into the filter to see what values have been selected. Now that we have looked into some operations which we can perform in Excel using filter or sorting the data, creating your tables, let's also quickly look at functions and formulas which can be used for doing some easy calculations or computations. Now, Excel can be used in different kind of data analysis. So for example, you have different inbuilt functions which can be used, and we can always check for a particular function. So for example, if I wanted to look at a particular function, I could just type in here something, for example is, and then it shows me all the possible functions. And you can always have a look at the detail of the function. For example, you have is even, which will return true if the number is even. If we would say is logical, so I could search for is logical, and that tells me whether a value is logical value, true or false, and returns your value true and false. Now we can obviously say subtotal, so you can search for any of these useful functions, and that tells me what this function can be used for. So returns a subtotal in a list or a database. You have many other such functions such as integer, sum, average. You may be interested in working on truncating some data, getting the absolute value, getting the square root, basically getting a count or getting a max value. You can look for any particular functions within your Excel sheet. Now you also have other functions such as now or time. For example, let's look at now function. So I can search for now, and here it is. So this is returns the current date and time formatted as a date and time. So this is the function which we would want to use. And if I just give the function, it tells me what is the current time. Let's first look at the description of time here. So say for example, I would want time. It says converts hours, minutes and seconds given as numbers to an Excel serial number formatted with a time format. So for example, if I would say 2 hours and then 30 minutes and 30 seconds, and if I do this, it has basically converted this into your time format. So you can always use different inbuilt functions for your work. Now we will also look at some advanced functions like SUMIF or SUMIFs. You have COUNTIF and COUNTIFs, and you can be working on various functionalities of Excel to easily help you in doing some calculations, computations, working with your data, working with your different cell values. So let's look at some example of using functions like sum or SUMIF. So for that, let's go to this sheet, and here we have some data. Now I have already applied a filter which can allow me to filter out the data. So it says find the total units that were sold in the East region. Now we know that in region we have East, and I have multiple regions. I could basically be saying unselect all and select only East and say OK, and that basically gives me the units which were sold. And if I place my cursor here, and then if I did a auto sum, so it would basically give me the function which is being used, so something like subtotal, and it is basically working on your rows which is E2 to E44. And here we can just do this, so that gives me the total. But this is fine, you could do that, but it would be good if we know how do we use a function like SUMIF to do that. So here I'm seeing this is the subtotal where I'm looking at the values, and basically what I have done is I have filtered out the region, and then basically I'm getting a count. But this does not give me clearly how a sum was calculated from all the values which were listed. What we can also do is let's do a Control Z and let's get it back. So now we have our data and we would want to get the total units that were sold in the East region. So what I can do is I can start typing in my formula, and for that I'll use an inbuilt function. So for example, I would be interested in going for SUMIF. Now it says SUMIF adds the cells specified by a given condition or criteria. When you talk about SUMIFs, this is when you could give set of conditions or multiple criteria. So let's look at SUMIF. Let's do this. Now obviously this gives me an error because the formula is not right. So we have to basically come in here and let's start with SUMIF. Now when I say SUMIF, it shows me there is a function with SUMIF which we would want to use. And here, once I open up the bracket, it tells me, okay, what is the range of data which you are interested in. So I'm interested in all the units that were sold in the East region. So we are interested in the region which is here. So I can basically be selecting this, and this tells me you are interested in the data here. So let's not take the header value. So let's say B2, and then we can go all the way to the end. So we can basically select this way. That's the data we have. Select this and hit enter. So now here it has selected B2 to B4, but we need to basically now give the criteria. So the criteria is either a value or you can point it to a cell which has that particular value. So as per our problem statement, we are looking for the units which are sold in East region. So I can select the value East here, and then my SUMIF needs the range on which you want to calculate a sum. So let's select this, and now we are interested in finding out the sum of units. So that's basically this column, E column. So I can basically type in instead of selecting. So I can say E, and I'm interested in E2 to E44. So that basically selects the area or all the values. And now let's do this. So that basically gives me the sum is 691. Right now, this is the criteria where I have pointed it to a cell and whatever value that cell has. Well, I could have done something like this. So I could have selected East, giving the value, and then doing it. It still does the same thing. And in this way, you have more clarity that you are using SUMIF. You are filtering the data. So you have given the rows, you are given the criteria, and then you have given the range on which you would want to sum up the values. Now, similarly, if the question was what was the total revenue generated from binder, now we would want to find out what is the total revenue generated from binders. That means my filtering criteria will be binder, and then I want to find out the total revenue generated. So we have the revenue generated field also here, and we don't have any region to be filtered. We are just looking for binder. So let's again start doing the same thing. So we can go for SUMIF. We can open the bracket. Now it needs the range. So we are interested in revenue generated. Now that's the summation we want, and we would want to get the range of data. So here we can basically select D2 to D44. So that's the data selected. Now I would want to give the filtering criteria. So let's say binder, and then we need to give the range on which the sum needs to be calculated. So that's my revenue column. So that's G. So I can say G2 to G44, and that basically selects the column, and then you get your sum. So it tells me what is the total revenue generated from binder. Now, I could be doing this for other things also. So say for example, if you would want to filter out something else, you could basically just drag and drop here, and then I could come here and change this to, say, instead of binder, I would be interested in, say, pencil, if that's the criteria you are interested in. Remember to change this so that you take all the values, and here we will change it to select the relevant rows, and then this is the data I'm getting. So I know that this is the revenue generated from pencil. This is the revenue generated from binder. Now this is a simple use case where we are using sum if. What if we would want to use some ifs? So some ifs, let's have a look at how we get to some ifs. So some ifs is where you would want to work on doing some calculation, but then you would want multiple criterias to be met. So let's see how we get this. So here what I can do is, let's work on this problem statement which says what is the total revenue generated from central region where the item is a pencil. So that's something which I would want to check. Now, when we are answering this question, we can also look at the order in which things have been asked in the question. So it says, what is the total revenue generated from central region? So we need the total revenue generated. We know there is a revenue column. We are interested in getting the total revenue generated. We are saying the filtering criteria is central region, and we say in that we would be interested only in the item if it is pencil. How do I do it? So I can use some ifs where you can pass in multiple criteria. So let's start with some ifs. And when I start with some ifs, let's open up the bracket. So it says sum range, it says criteria range, then it gives one criteria, and you can give in any number of criterias. So for example, we are interested in total revenue generated. Now that's my G column. So let's follow in the same order. So let's say G2. So that's my first value. And then I know there are 44 rows here. So I can say G44. And you can obviously check if that has selected all the rows. Now that's my total revenue generated. So I would want the total revenue generated. So I'm saying setting this sum range. Then I need to give the criteria range. So it says from central region. So central region comes into column 2, that's B. So let's say B2 to B44. So that's my criteria range. Then you have to give your criteria, but we need to filter out the region being central. So let's select this. Now either I could point to a value in the cell, or I can just give the exact value here. We can also give a wildcard or matching pattern, so that also works. Now this one is fine. We are now also interested in finding the total revenue generated when the region is central and the item is pencil. How do we do that? So for item, we know the column is D2. So let's select D2 to D44. So that basically selects all the rows in the D column, and we need to give the filtering criteria. So let's do a comma and then just given our value. So let's say pencil, and then let's close your bracket, and that basically gives you the result. So we need to just follow the order of our question, which says what is the total revenue generated. So we are looking at the revenue column, we are selecting all the rows. Then it says from the central region. So we need to select the region column and give the filtering criteria as central, or point to a cell which contains that value. And then it says we would be interested only in item being pencil. So then you select the column which has all the items and provide your filtering criteria, that is pencil. So that's your easy calculation of using sum if, which we compare with sum if here. So sum if here was just having your criteria. So basically you are selecting your rows, giving your filtering criteria, and then your sum range. In sum ifs, we are giving multiple condition. Now same thing can be done here. It says how many units were sold by sales representative Jones or Jones, where the cost of each item was greater than 4. So how many units were sold by sales representative? So when we talk about how many units, that's your E column. So let's start with that. So let's say sum ifs, I would be interested in E column. Then let's give the range. So it says sum range. So those are the number of units on which we would want to find the sum. Then it says you need to give the criteria range. So we say sales representative, where the name is Jones. So sales representative is in sales rep column C. So let's say C2 to C44. Now then we need to give our filtering criteria. So let's say Jones is the sales representative where we are interested, about whom we are interested in. And then the question says where the cost of each item. So cost of each item is what we are interested in. You have unit cost. So that's what we are interested in. So that would be F, and then say F2 to F44. And then you need to give your cost. So it says where each item is greater than 4. So let's select this and let's do this. So this tells me 301. Now, similarly, let's answer our third question, which says how many units did Jones sell excluding pencil item? So we would want to find out what was the total number of units that were sold, and that units or that should not include the pencil item. How do we start doing this? So let's start with sum ifs. Now we know that you start with sum ifs, you need to give the sum range. So we are interested in the number of units. So let's basically go in and select our number of units which were sold. So that's your column E. So I can say E2 to E44. That's where I would want to perform the sum. Now I'm saying how many units that were sold, where we are talking about sales rep being Jones. So let's select the columns C and then give the range. After that, we need to give our filtering criteria, which is Jones, and then we are interested in the items, but excluding pencil. So items is in column D. So let's say D to D44, and then we have to give our criteria. So we can say, well, that should exclude pencil. So I can basically say pencil, and let's close this and let's check. So that's my formula, which says that these are the number of units which the sales representative, whose name is Jones, had sold, and that does not include pencil as an item. Let's also look at an example of using COUNTIF or COUNTIFs. Now, both of these can be very useful when you would want to calculate certain values. So for example, if I would want to work on COUNTIF, let's try solving this problem. Now remember, you can answer these questions using filters and that can be an easier way. But then sometimes you may want to get the formulas so that you can make your spreadsheet and your calculation more dynamic in nature, and that will basically depend on the values in the columns or rows. So for example, if I have find the total number of times Gil has made a sale. Now if I look at my data here, it tells me that for every sales representative there is some value in the sale, and it says sales has greater than 3. So for example, Jones, you have sales greater than 3, or you have Jardine, which is sales greater than 3, and so on. So what we are interested in is doing a quick count and finding out the total number of times Gil has made a sale. How do we do that? So we can use this COUNTIF function, and if I go into COUNTIF, it says counts the number of cells within a range that meet the given condition. Now what's our condition? Our condition is Gil, and we would want to find out how many times the name say Gil appears or Gil has made a sale. Now I could just say COUNTIF and then open up a bracket. I need to give a range. So let's say we are interested in looking at the range. So let's say we will choose sales rep. So I can say C, and then I can say C2 to C44. Now that's my range. Let's not give that in quotes. So you have to give a range. So let's do a COUNTIF that selects the data, and then we need to give the condition. So for example, let's here give the name, which is Gil, and then close this. So that basically tells me it is 5 times Gil appears here. We can check this. So I can go in here, I can add a filter, and then might be I would be interested in looking at only Gil, and that basically gives me 5, right? So we can always do that, and we can be using formulas like this. Now what about this question? So which basically says which sales representative made a sale more than 3 times. Now it might be looking little confusing when I say, for example, let me clear out this filter. Now we have sales greater than 3, and we would want to find out which sales representative made a sale more than 3 times. Now I could basically check for every sales representative here if they have made a sale more than 3 times, and what I can do is I can just say equals, I can start with COUNTIF, then I need my filtering criteria. So that's your range. So first thing is we will choose, for example, let's choose C2 to C44, and then we need to give an criteria. What is the criteria? We need basically a sales representative. So I can choose the value here in C2, and then I can close this, and then I can say the sale has to be greater than 3, and let's check. So it tells me the Boolean value that yes, this guy has made sales more than 3 times. And what we can do is we can just drag and drop, which basically gives me the value for other sales rep. You can always check the value is automatically changing to this value in cell. And for example, let's go in here. So this is obviously 2, so it says me false, right? And you can basically get the values for all your values. So that basically tells me which sales representative has made a sale more than 3 times. Now, like some ifs, we also have count ifs where you can give multiple criterias. So for example, the question is how many orders were placed from the East region after this particular date. So we have a date criteria, we also have the region criteria, and we need to basically get the count of number of orders which were placed. Now I can in this case use count ifs, And this basically says that you can start with a criteria. So it says how many orders were placed from East region after particular date. So date is in my first column. So for example, I could say A, start with 2, and say for example, let's go A44. That should have selected all the rows. And then I need to, once I've given the criteria range, I need to give the criteria. So we are saying the date has to be greater than 10th Feb. So let's give it 2/10/2019. And then you need to say how many orders were placed. So you need to give the criteria, second criteria range. So we are looking at the number of orders which were placed from the East region. So when I would want to look at the region, that's your column B. So I can basically say B2 to B44. And here I would basically give my criteria. So the criteria is East. Let's give that. And once you have done this, you would want to find out the total number of orders. So let's select this. And if I do this, it tells me 13. Now, is that right? So we are looking for your date, your region being East, and then getting the total number of orders. So here I can just do a count if I'm saying A2 to A44, wherein I have given the date criteria that it should be greater than 10th Feb, because I do not want to count 10th Feb. It says after 10th February. And then you are saying the region has to be East. So we would want to find out the total number of orders. So my region is East, and that gives me the result. Now similarly, you can also find out how many times Gill sold pencils. So here we will have to give the range. So let's start with count ifs. Now here I would want that item is pencils, so we can as well select column D to D44. Then you have to give your criteria, so that's your pencil. And then we are looking for sales rep, which is Gill. So that is my column C. So let's say C2 to C44, and the value should be just Gill. So it tells me it's twice where Gill has sold pencils. So we can obviously check this by going in here, choosing my filter, and then let's search for rep being just Gill. Okay, and now we are interested only in the item being pencil. So I can say, well, let's get to pencil only, and that tells me twice. So you can obviously re-verify using filters, but using functions or using formulas, it is always good to calculate, and that can be making your computation and calculation more dynamic. Let's look at one more interesting feature of Excel, and that's your conditional formatting. Now, as you see on the screen, conditional formatting has different rules which can be applied on your data, and that allows you to basically differentiate or easily identify data values which are based on certain criteria or rules. So when you talk about conditional formatting, you have different options, such as you can highlight cell rules, you can get top and bottom values, you can apply different rules, apply different color scales, and you can easily manage these rules. So conditional formatting is very useful for people who would want to work on huge amount of data and easily perform some data analysis. It's easy to use as it is shown here, and with your conditional formatting you can format cells based on a preset condition. You can perform conditional formatting to identify cells. You can highlight a few significant cells, and you can easily perform conditional formatting as shown on the left side. Now, how do we work with conditional formatting? Let's have a quick look. So say for example, we have our Excel sheet, and if you see here, I am highlighting the salesperson who have generated revenue greater than 10,000. So we can be looking at the values where the revenue generated by a particular salesperson is greater than 10,000. It has a particular color. And how do we get here? So for example, let's select this data. And what I could do is I could go into conditional formatting. Now I could basically highlight cell rules, and we could just say greater than. That's an easier way. I could also go ahead and create a new rule, but then I can use one of this option. I can say greater than, and let's give some value. Might be we would be interested in looking at any value greater than 12,000. So let's choose 12,000. And here it says what color would you want to select. So for example, I would say something like yellow filled with dark yellow text, and let's say okay. So right now what I'm doing is I have all the values where the revenue generated was greater than 10,000, but then I have also selected all the sales people who have made or who have generated revenue greater than 12,000. So I can just do a Control Z to see the previous result. Now here I had the values which were greater than 10,000, and the one which we did just now basically highlighted the values which are greater than 12,000. So this is one simple example. Now we can look at some other examples. Say for example, you want to format cells using 3-color scale. So if you look at the values here, I have a 3-color scale mainly in green, yellow, and red. And how do you do this? So for example, I can go in here and I can go to conditional formatting. So I would want to go for color scales, and here you can create different rules. So we can set up a 2-color scale. So we can say format only values that are above and below average. I can format only cells that contain something. I can get the top and bottom value. So these are different ways in which I can have a 3-color based scale. Now what I will do is I will select this, and let me show you the rule which I have. So for example, I can go into manage rules, and if you see here, there are certain rules which have been specified. Now what does that mean? So you would want to specify a 3-grade scale. So for example, if I would want to look at my first rule, it tells me that I'm choosing 3-color scale. I can choose lowest value, percentile, and highest value, and that basically will select the cells based on their values. So what we could have done is I can basically use one of these values. I can delete these rules which I have created. So for example, I have all these rules, but you should always carefully remember that the rules will be applied in the order shown. So for example, if I just delete these rules and then say apply and say okay, my data is back. Now it does not have any highlighting. Now I can go in here, I can say conditional formatting. I could go for color scales, or I could basically go into new rule. So I would want the cells to be using 3-color scale. So let's choose 3-color scale. Now when you say 3-color scale, it says what will be the color of lowest value, and we could choose, might be any one of this. Let's choose red. I can say midpoint is percentile 50, and then the highest value is green, and if that looks good, let's say okay. And now if you see, the lowest values have been highlighted as red, you have mid values, and then you have the positive value. So this is the 3-color scale, and that easily helps me in identifying the data based on the cell values. Now in conditional formatting, what you can also do is you can basically color the cells based on their values. So what we are seeing here is if the revenue generated is greater than average, then that shows in green. And if the revenue generated is lesser than average, that shows in orange. Now, how do we do that? So we can basically again manage some rules. So I can basically create a new rule. Now here I can select one of the options which says format only values that are above or below average, and that's the option I would want to select. Now I can select this, and it says format values that are above average. So in our case, we had it in green. So for example, I'll say above average, and then here I can go for a particular color. So you can go for a particular size. So let's go and look into the formatting. So for example, let's choose yellow. Say okay. Now I'm saying wherever the cell values are above average, it would be yellow instead of green. And let's go in here. Let's go and look into manage rules. So this is basically the rule which we are applying. Now we can also add a new rule, and I need to select the values. So for example, I will say here, so we had gone for above, now we'll go for below, we'll go for format, we will choose red, we'll say okay, we'll say now these are basically the rules which we have created, and here it says applies to your data. So right now it has not been applied. So for example, if I select this, and then I could basically choose my area, just hit on enter, and similarly you can go in here and then select your area, hit on enter, and say apply, say okay. And now if you see, I have really chosen bright colors, but then I have said wherever my revenue generated is above average, it should be in yellow, and below average should be in red. So we wanted above average to be in green and below average to be in orange. So that's what we have here, right? So you can always color code your cell values based on some rules which you are setting up. Now similarly, you can also find the top 10 and bottom 10 values, and that's pretty easy. So you can just select this, and then you can go into conditional formatting. You can go for top and bottom values, top 10 items, bottom 10 items, or you can go in for more rules. So you can say format only top or bottom ranked values. So you have top 10. Now you can choose the color, and for example, I'll go for blue, and I'll say okay. So now if you see, my top 10 values are blue. Now similarly, I can add one more rule. So I can say new rule, and I can say let's go for top or bottom. Let's go for bottom. Let's go for format. Let's say orange. Say okay, say okay, and that's it. So now you have your values which are top or bottom 10 values. So you are using conditional formatting where you are basically highlighting your cell values based on different colors, and here easy conditional formatting based on different rules helps us to do that. Now similarly, you can also have the values which is basically showing you how the values are increasing. So what we can do is we can select our columns. Either you could apply this to all the columns. Now here I have applied this only to Jan and April. Now I could apply this for June. So let's say June. So you can go for gradient fill, you can go for solid fill, you can obviously just select the color, and that takes care of the things. You can say, for example, select this, and now this is selected. What I would want to might be format this. So I can go in here, I can go into manage rules. Now that will tell me what rule has been applied in the order. So I can just do a edit rule, and that basically says this is a solid fill, which is color, you have no border, this is basically color is black. Now I can go for something like gradient fill, and I can say okay. And now if I say apply and okay, so this basically is like your first column. So you can use conditional formatting for various use cases, and you can highlight the values. So anyone who would look at the value would automatically notice which are the higher values, which are lower values. Might be here the revenue is getting generated or was getting generated but did not grow beyond a particular value, and so on. Now similarly, you can also go in for different options. Say for example, here we would want to see if the revenue was dropping, or if the revenue decreased, or say for example if the revenue was going up for this particular salesperson. So here we are looking at Carol. So in Jan the revenue generation by sales was very high, then in Feb it was falling down, in March it was kind of stable, then in April it went way below. So we can obviously work on this, wherein we can grade our cell values. So what we can do is we can go in for highlighting the cell values. Now you can go for color scales, you can go for icon sets, and this is where you can choose your different shapes. So you could choose one of these shapes. So for example, I would be interested in looking at the indicators like directional. I could go using this 3 arrows. I can go in for this color, I can choose directional, and then my values are automatically using directional. Now what we can also do is we can then go into manage rules, and that basically tells me what rules have been applied. So for example, the latest one is the icon set, which I have chosen. It shows the selected columns. I can obviously do a edit rule, and then I can choose. So I'm saying the format style is icon sets. I'm not using a data bar, I'm not using color scale. Now here I have chosen the style of icons, and then here you can basically give some values. So you have icon which is green when the value is greater than or equal to 67%. When I say hyphen or minus, it is less than 67. It's way below 33%, then you give this value. So you can obviously edit and easily highlight your cell values based on this icon set. So I can apply this, and that's how I use conditional formatting. So conditional formatting can be very useful if you would want to use icon set, if you want to use your data bars, if you would want to highlight particular values, if you would want to color code based on some calculation, if you would want to use a 3-color or a 2-color scale, or if you would want to just find out values based on some simple calculation. So conditional formatting is used extensively by data analysts, or people who are working business intelligence teams, or people who would want to use Excel to easily identify the data, easily identify the cells which contain particular value, or finding out less significant or more significant cells to then pull out values and carry out your computations, calculations, or analysis.
And if you're an aspiring data analyst, try giving a shot to Simplilearn's postgraduate program in data analytics from Purdue University in collaboration with IBM. The link in the description box and the pinned comment should take you to the program being offered.
And so why exactly do we need to do time series analysis? Typically, we would like to predict something in the future. And it could be stock prices, it could be the sales, or anything that needs to be predicted into the future. That is when we use time series analysis. So it is, as the name suggests, it is forecasting. And typically when we say predict, it need not be into the future. In machine learning and data analysis, when we talk about predicting, we are not necessarily talking about the future. But in time series analysis, we typically predict the future. So we have some past data and we want to predict the future. That is when we perform time series analysis. So what are some of the examples? It could be daily stock price, the shares as we talk about, or it could be the interest rates, weekly interest rates, or sales figures of a company. So these are some of the examples where we use time series data. We have historical data, which is dependent on time. And then based on that, we create a model to predict the future. So what exactly is time series? So time series data has time as one of the components, as the name suggests. So in this example, let's say this is the stock price data and one of the components. So there are two columns here. Column B is price and column A is basically the time information. In this case, the time is a day. So that primarily the closing price of a particular stock has been recorded on a daily basis. So this is the time series data and the time interval is obviously a day. Time series or time intervals can be daily, weekly, hourly, or even sometimes there is something like a sensor data. It could be every few milliseconds or microseconds as well. So the size of the time intervals can vary, but they are fixed. So if I'm saying that it is daily data, then the interval is fixed as daily. If I'm saying this data is an hourly data, then it is the data is captured every hour and so on. So the time intervals are fixed. The interval itself you can decide based on what kind of data we are capturing. So this is a graphical representation. The previous one here we saw the tabular representation, and this is how to plot the data. So on the y-axis is, let's say, the price or the stock price, and the x-axis is the time. So against time, if you plot it, this is how a time series graph would look. So as the name suggests, what is time series data? Time series data is basically a sequence of data that is recorded over a specific intervals of time and based on the past values. So if we want to do an analysis of time series past data, we try to forecast a future. And again, as the name suggests, it is time series data, which means that it is time dependent. So time is one of the components of this data. Time series data consists of primarily four components. One is the trend, then we have the seasonality, then cyclicity, and then last but not least, irregularity or the random component. Sometimes it is also referred to as a random component. So let's see what each of these components are. So what is trend? Trend is overall change or the pattern of the data, which means that the data may be, let me just pull up a pen and show you. So let's say you have a data set somewhat like this, a time series data set somewhat like this. All right. So what is the overall trend? There is an overall trend which is upward trend, as we call it here, right? So it is not like it is continuously increasing. There are times when it is dipping, then there are times when it is increasing, then it is decreasing and so on. But overall, over a period of time, from the time we start recording to the time we end, there is a trend, right? There is an upward trend in this case. So the trend need not always be upwards. There could be a downward trend as well. So for example, here, there is a downward trend, right? So this is basically what is a trend. Overall, whether the data is increasing or decreasing. All right, then we have the next component, which is seasonality. What is seasonality? Seasonality, as the name suggests once again, changes over a period of time and periodic changes, right? So there is a certain pattern. Let's take the sales of warm clothes, for example. So if we plot it along the months, so let's say January, February, March, April, May, June, July, and then let's say it goes up to December. Okay, so this is our December, a D. I will just mark it as D. And then you again have Jan, Feb, March, and then you get another December. Okay, and just for simplicity, let's mark these as Decembers as the end of the year, and then one more December. Okay, so what will happen if you're talking about warm clothes, what happens? The sales of warm clothes will increase probably around December when it is cold, and then they will come down. And then again around December, again they will increase, and then the sales will come down. And then there will be again an increase, and then they will come down. And then again an increase, and then they will come down. Let's say this is the sales pattern. So you see here there is a trend as well. There is an upward trend, right? The sales are increasing over, let's say these are multiple years. This is for year 1, this is for year 2, this is for year 3, and so on. So for multiple years, overall the trend, there is an upward trend. The sales are increasing, but it is not a continuous increase, right? So there is a certain pattern. So what is happening? What is the pattern? Every December, the sales are increasing or they are peaking for that particular year, right? Then there is a new year. Again, when December approaches, the sales are increasing. Again, when December approaches, the sales are increasing, and so on and so forth. So this is known as seasonality. So there is a certain fluctuation which is periodic in nature. So this is known as seasonality. Then cyclicity. What is cyclicity? Now, cyclicity is somewhat similar to seasonality, but here the duration between two cycles is much longer. So seasonality typically is referred to as an annual kind of a sequence. Like for example, we saw here. So it is pretty much like every year in the month of December, the sales are increasing. However, cyclicity, what happens is, first of all, the duration is pretty much not fixed, and the duration or the gap length of time between two cycles can be much longer. So recession is an example. So we had, let's say, recession in 2001 or 2002 perhaps, and then we had one in 2008, and then we had probably in 2012, and so on and so forth. So it is not like every year this happens probably. So there is usually when we say recession, there is a slump, and then it recovers, and then there is a slump, and then it recovers, and probably there is another bigger slump, and so on, right? So you see here, this is similar to seasonality, but first of all, this length is much more than a year, right? That is number one. And it is not fixed as well. It is not like every 4 years or every 6 years. That duration is not fixed. So the duration can vary. At the same time, the gap between two cycles is much longer compared to seasonality. Alright, so then what is irregularity? Irregularity is like the random component of the time series data. So there is like, you have part which is the trend, which tells whether the overall it is increasing or decreasing. Then you have cyclicity and seasonality, which is like kind of a specific pattern, right? Then there is a cyclicity, which is again a pattern, but at much longer intervals. Plus there is a random component, so which cannot be accounted for very easily, right? So there will be a random component which can be really random, as the name suggests, right? So that is the irregularity component. So these are the various components of time series data. Yes, there are conditions where we cannot use time series analysis, right? So can we do time series analysis with any kind of data? No, not really. So what are the situations where we cannot do time series analysis? So there will be some data which is collected over a period of time, but it's really not changing. So it will not make sense to perform any time series analysis over it, right? For example, like this one. So if we take X as the time and Y as the value of whatever the output we are talking about, and if the Y value is constant, there is really no analysis that you can do. leave alone time series analysis, right? So that is one. Another possibility is, yes, there is a change, but it is changing as per a very fixed function like a sine wave or a cos wave. Again, time series analysis will not make sense in this kind of a situation because there is a definite pattern here, there is a definite function that the data is following. So it will not make sense to do a time series analysis. Now, before performing any time series analysis, the data has to be stationary. And typically, time series data is not stationary. So in which case, you need to make the data stationary before we apply any models like ARIMA model or any of these, right? So what exactly is stationary data? And what is meant by stationary data? Let us take a look. First of all, what is non-stationary data, time series data? If you recall from one of my earlier slides, we said that time series data has the following 4 components: the trend, seasonality, cyclicity, and random component or irregularity, right? So if these components are present in time series data, it is non-stationary, which means that typically these components will be present. Therefore, most of the time, a time series data that is collected raw data is non-stationary data. So it has to be changed to stationary data before we apply any of these algorithms. All right, so a non-stationary time series data would look like this, which means, like, for example, here there is an upward trend, the seasonality component is there, and also the random component and so on. So if the data is not stationary, then the time series forecasting will be affected. So you cannot really perform a time series forecasting on a non-stationary data. So how do we differentiate between a stationary and a non-stationary time series data? Typically or technically, one is, of course, you can do it visually. In non-stationary data, the data will be more flattish. The seasonality will, of course, be there, but the trend will not be there. So the data may, if we plot that, it may appear somewhat like this, right? It's a horizontal line. Along the horizontal line, you will see. Compared to the original data, there was an upward trend, so it was changing somewhat like this, right? So this is non-stationary data, and this is how a stationary data would look visually. What does this mean? Technically, this means that the stationarity of the data depends on a few things: the mean, the variance, and the covariance. So these are the 3 components on which the stationarity of the data depends. So let's take a look at what each of these are. For stationary data, the mean should not be a function of time, which means that the mean should pretty much remain constant over a period of time, right? So there shouldn't be any change. So this is how the stationary data would look. And this is how a non-stationary data would look. I've shown in the previous slide as well. So here, the mean is increasing. That means there is an upward trend. Okay, so that is one part of it. And then the variance of the series should not be also a function of time. So the variance also should be pretty much common, or should be constant rather. So this is if we visually take a look, this is how time series stationary data would look, where the variance is not changing. Here the variance is changing, therefore this is non-stationary, and we cannot apply time series forecasting on this kind of data. Similarly, the covariance, which is basically of the ith term and the I plus mth term, should not be a function of time as well. So covariance is nothing but not only the variance at the ith term, but the relation between the variance at the ith term and the I plus mth or the I plus nth term. So once again, visually this is how it would look if the covariance is also changing with respect to time. So these are all three components should be pretty much constant. That is when you have stationary data, and in order to perform time series analysis, the data should be stationary. Okay, so let's take a look at the concept of moving average, or the method of moving average, and let's see how it works. We'll do simple calculations. So let's say this is our sample data. We have the data for 3 months, January, February, March. The sales in thousands of dollars is given here, and now we want to find the moving average. So how do we find the moving average? We call it as moving average 3. So moving average 3 is nothing but you take 3 of the values or the readings, add them up and divide by 3. Basically the way we take a mean or average of the 3 values. So that is as simple as that. So that's the average first of all. So what is moving average? Moving average is if you now have a series of data, you keep taking the 3 values, the next 3 values, and then you take the average of that, and then the next 3 values, and so on and so forth. So that is how you take the moving average. So let's take a little more detailed example of car sales. So this is how we have the car sales data for the entire year, let's say. So rather for 4 years. So year 1 we have for each quarter 1, 2, 3, 4, and then year 2, quarter 1, 2, 3, 4, and so on and so forth. So this is how we have sales data of a particular car, let's say, or a showroom. And we want to forecast for year 5. So we have the data for 4 years. We now want to forecast for the 5th year. Let's see how it works. First of all, if we plot the data as it is taken, the raw data, this is how it would look. And what do you think? Is it stationary? No, right? Because there is a trend, upward trend. So this is not a stationary data. So we need to, later we will see how to make it stationary. But to start with, just an example. We will not worry about it for now. We will just go ahead and manually do the forecasting using what is known as moving average method. Okay, so we are not applying any algorithm or anything like that. In the next video, we will see how to apply an algorithm, how to make it stationary, and so on. All right, so here we see that all the 3 or 4 components that we talked about are there. There is a trend, there is a seasonality, and then of course there is some random component as well. Cyclicity may not be, it is possible that cyclicity is not applicable in all the situations. For sales especially, there may not be, or unless you're taking a sales for maybe 20-30 years, cyclicity may not come into play. So we will just consider primarily the trend, seasonality, and irregularity, right? So random, it is also known as random irregularity, right? So we were calling the random or irregularity component. So these are the 3 main components typically in this case we will talk about. So this is the trend component, and we will see how to do these calculations. So let's take a look, redraw the table including the time code. We will add another column which is the time code, and this is the column. And we'll just number it like 1, 2, 3, 4 up to 16. The rest of the data remains the same. Okay, so we will do the calculations now. Now let us do the moving average calculations or MA4 as we call it for each year. So we take all the 4 quarters and we take an average of that. So if we add up these 4 values and divide by 4, you get the moving average of 3.4. So we start by putting the value here. So that will be for the 3rd quarter, let's say 1, 2, 3, the 3rd quarter. Then we will go on to the next one. So we take the next 4 values as you see here and take the average of that, which is the moving average for the next quarter, and so on and so forth. Now, if we just do the moving average, it is not centered. So what we do is we basically add one more column and we calculate the centered moving average as shown here. So here what we do is we take the average of 2 values and then just adding these values here. So for example, the first value for the 3rd quarter is actually the average of the 3rd and the 4th quarter. So we have 3.5. Now it gets centered. So similarly, the next value would be 3.6 plus 3.9 divided by 2, so which is 3.7, and so on and so forth. Okay, so that is the centered moving average. This is done primarily to smoothen the data so that there are not too many rough edges. So that is what we do here. So if we visualize this data now, this is how it looks. Right, so if we take the centered moving average, as you can see, there is a gradual increase. If this was not the case, if we had not centered it, the changes would have been much sharper. So that is basically the smoothing that we are talking about. Now let's go and do the forecast for the 5th year. So in order to do the forecast, what we will do is we will take the centered moving average as our baseline and then start doing a few more calculations that are required in order to come up with the prediction. So what we are going to do is we are going to use this multiplicity or multiplicative model in this case, and this is how it looks. So we take the product of seasonality and the trend and the irregularity components, and we just multiply that. And in order to get that, this product of these two, we have basically the actual value divided by CMA. YT value divided by CMA will give you the predicted value, or YT is equal to the product of all three components. Therefore, ST into YT is equal to YT by CMA. So this is equal to YT, right? So therefore, if we want ST into YT, the product of seasonality and irregularity, it is equal to YT by CMA. So that is how we will work it out. I also have an Excel sheet of the actual data. So let me just pull that up. Alright, so this is how the data looks in Excel. As you can see here, year 1, quarter 1, 2, 3, 4, year 2, quarter 1, 2, 3, 4, and so on. And this is the sales data. And then this is the moving average. As I mentioned, this is how we calculate. And this is the centered moving average. So this is the primary component that we will start working with. And then we will calculate, since we want the product of ST into YT, that is equal to YT by CMA. So if you see, these values are nothing but the YT value divided by CMA. So in this case, it is 4 by 3.5, which is 1.14. Similarly, 4.5 by 3.7, 1.22, and so on and so forth. So we have the product ST into YT, and then the next step is to calculate the average of respective quarters. So that is what we are doing here, average of respective quarters. And then we need to calculate the deseasonalized values. So in order to get deseasonalized value, we need to divide YT by ST that was calculated. So for example, here it is 2.8 by 0.9. So we got the deseasonalized value here, and then we get the trend, and then we get the predicted values. So in order to get the predicted value, which is basically we predict the values for known values as well. Like for example, year 1, quarter 1, we know the value, but now that we have our model, we predict ourselves and see how close it is. So we predicted as 2.89, whereas the actual value is 2.8. Then we have 2.59, the actual value is 2.1, and so on, just to see how our model works, and then continue that into the 5th year, because for 5th year we don't have a reference value. Okay, and if we plot this, we will come to know how well our calculations are, how well our manual model. In this case, we did not really use a model, but we did on our own manually. So it will tell us the trend. So for example, the predicted value is this gray color here, and you can see that it is actually pretty much following the actual value, which is the blue color. Right? And the gray color is the predicted value. So wherever we know the values up to year 4, we can see that our predicted values are following or pretty much very close to the actual values. And then from here onwards, when the year 5 starts, the blue color line is not there because we don't have the actual values, only the predicted value. So we can see that since it was following the trend pretty much for the last 4 years, we can safely assume that it has understood the pattern and it is predicting correctly for the next 1 year, the next 4 quarters, right? So that is what we are doing here. So these 4 quarters, we did not have actual data, but we have the predicted values. So let's go back and see how this is working in this using the slides. So this is, we already saw this part, and I think it was easier to see in the Excel sheet. So we calculated the ST, IT, the product of ST and IT using the formula like here, Y by YT by CMA, we got that, and then we got ST, which is basically YT. So this is average of the first quarters for all the 4 years. And similarly, this is the average of the second quarter for all the 4 years, and so on. So these values are repeating. They are calculated only once. They get repeated, as you can see here. And then we get the deseasonalized data, and that is basically YT by ST. So we calculated ST here, and we have YT. So YT by ST will give you the deseasonalized data. And we have got rid of the seasonal and the irregular components so far. Now what we are left with is the trend. And before we start the time series forecasting or time series analysis, as I mentioned earlier, we need to completely get rid of the non-stationary components. So we are still left with the trend component. So now let us also remove the trend component. In order to do that, we have to we have to calculate the intercept and slope of the data, because that is required to calculate the trend. And how are we going to do that? We will actually use what is known as a regression tool or analytics tool that is available in Excel. So you remember we have our data in Excel. So let me take you to the Excel, and here we need to calculate the intercept and the slope. In order to do that, we have to use the regression mechanism, and in order to use the regression mechanism, we have to use the analytics tool that comes with Excel. So how do you activate this tool? So this is how you would need to activate the tool. From Excel, you need to go to options, and in options there will be add-ins, and in add-ins you will have analysis toolpack, and you select this and you just say go. It will open up a box like this. You say analysis toolpack and you say okay. And now when you come back into the regular view of Excel, in the data tab, you will see data analysis activated. So you need to go to file, options, and add-ins, and then analysis toolpack. Typically, since I've already added it, it is coming at the top, but it would come under inactive application add-ins. So when you're doing it for the first time. So don't use VBA, you just say analysis toolpack. There are two options, one with VBA like this one and one without VBA. So just use the one without VBA. And then instead of just saying okay, just take care that you click on this go and not just okay. So you say go, then it will give you these options. Only then you select just the analysis toolpack and then you say okay. Alright, so and then when you come back to the main view, you click on data. Okay, so this is your normal home view perhaps. So you need to come to data, and here is where you will see data analysis available to you. And then if you click on that, there are a bunch of possibilities of what kind of data analysis you want to do. If there are options are given. Right now we just want to do regression because we want to find the slope and the intercept. So select regression and you say okay. And you will get these options for input Y range and input X range. Input Y range is the value YT. So you just select this and you can select up to here and press enter. And input X range, you can, for now, you start with the baseline, or you can also start with the deseasoned values. So you can just click on these and say okay. I have already calculated it. So these are the intercept and the coefficients that we are getting for these values. And we will actually use that to calculate our trend here, right? So which is in the J column. So our trend is equal to intercept plus slope into the time code. So the intercept is out here, as we can see in our slide as well. So if you see here, this is our intercept, and the lower value is the slope. So we have calculated here and it's shown in the slides as well. So intercept, so the formula is shown here. So our trend is equal to intercept plus slope into time code. Time code is nothing but this one, T, column A, 1, 2, 3, 4. Okay. So that's how you calculate the trend, and that's how you use the data analysis tool from Excel. Using these two, we calculate the predicted values. And using this formula, which is basically trend is equal to intercept plus slope into time code. And then we can go and plot it, see how it is looking, and therefore, so we see here that the predicted values are pretty close to the actual values, and therefore we can safely assume that our calculations, which are like our manual model, is working, and hence we go ahead and predict for the 5th year. So till 4 years we know the actual value as well, so we can compare how our model is performing. And for the 5th year, we don't have reference values, so we can use our equations to calculate the values or predict the values for the 5th year, and we can go ahead and safely calculate those values. And when we plot for the 5th year as well, the predicted values, we see that they are pretty much, they captured the pattern, and we can safely assume that the predictions are fairly accurate, as we can also see from the graph in the Excel sheet that we have already seen. Okay, so let's go and plot it. So this is how the plot looks. This is the CMA, or the centered moving average, the green color, and then the blue color is the actual data, red color is the predicted value, predicted by our handcrafted model. Okay, so remember, we did not use any regular forecasting model or any tool. We have done this manually, and the actual tool will be used in the next video. This is just to give you an idea about how behind the scenes or under the hood, how forecasting works, or time series analysis, how it is performed. Okay, so it looks like it has captured the trend properly. So up to here is the known reference, we have reference, and from here onwards is purely predicted. And as I mentioned earlier, we can safely assume that the values are accurate and predicted properly for the 5th year. So let's go ahead and implement a time series forecast in R. First of all, we will be using the ARIMA model to do the forecast of this time series data. So let us try to understand what is ARIMA model. So ARIMA is actually an acronym. It stands for Autoregressive Integrated Moving Average. So that is what is ARIMA model. And it is specified by 3 parameters, which is P, D, and Q. P stands for autoregressive. So let me just mark this. So there are 3 components here: autoregressive, integrated, moving average. Okay. So these 3 parameters correspond to those 3 components. So the P stands for autoregressive, D for integrated, and Q for moving average. So let us see what exactly this is. So these 3 factors are: P is the number of autoregressive terms, or AR, we will see that in a little bit, and D is how many levels of differences that we need to do, or differentiation we need to do, and Q is the number of lagged forecast errors. So we'll see what exactly each of these are. So AR is the number of autoregressive terms, and which is basically denoted by the P, and then we have D, which is for the number of times it has to be differentiated, and then we have Q, which is for the moving average. So what exactly AR terms? So in terms of the regression model, autoregressive components refer to the prior values of the current value. Well, what we mean by that is, here when we talk about time series data, focus on the fact that there is regression. So what exactly happens in regression? We try to do something like, if it is simple linear regression, we do some equation like y is equal to mx plus c, where there are 2 variables. One is the dependent variable, and then there is an independent variable. Let me just complete this equation as well, mx plus c. Right? So this is a normal regression curve, or a simple regression curve. Now here we are talking about autoregression or autoregressive. So autoregressive, as the name suggests, is regression of itself. So which means that here you have only one variable, which is your maybe the cost of the flights or whatever it is, right? And the other variable is basically time dependent, and therefore the value at any given time, and that we will denote as yt, for example. So there is no x here, there is only one variable, and which is y, and we say yt, which is basically the predicted value at a time interval t, for example, is dependent on the previous value. So for example, there may be a1 and then yt minus 1, and then there will be like plus a2 and plus a2 and yt minus 2 and alright, and then plus a3 into yt minus 3. Correct? So basically here what we are saying is there's only one variable here, but there is a regression component. So we are doing a regression on itself. So that's how the term auto regression comes into play. So only thing is that it is dependent on the previous time values. So there is a lag, let's say. This is the first lag, second lag, third lag, and so on. So the current value, which is yt, is dependent on the previous time lag values. So that is what is auto regression component. So this is what is shown here. For example, in this case, instead of y, we are calling it as x. So that's the same. And this is represented by some equation of that sort, depending on how many lags we take. So that is the AR component. And the term P is basically determines how many lags we are considering. So that's the term P for. Now, what is D? D is the degree of differencing. So here differencing is like for the non-seasonal differences, right? So for example, if you take the values like this, which are given for 5, 4, 6, and so on and so forth, if you take the differencing of one after another, like for example, 5 minus 4 or 4 minus 5, the next value with the previous value. So 4 minus 5. So this is known as the first order differencing. So the result is minus 1. Similarly, 6 minus 4 is 2. 7 minus 6 is 1. So this is first order differencing. And here we call it as D is equal to 1. Okay. And same way we can have second order, third order, and so on. Then the last one is Q. Q is we call it moving average, but in reality it is actually the error of the model. So we also sometimes represent as ET. Alright, so now ARIMA model works on the assumption that the data is stationary, which means that the trend and seasonality of the data has been removed. That is correct. Okay. So this we have discussed in the first part, what exactly is stationary data and how do we remove the non-stationary part of it. Now, in order to test whether the data is stationary or not, there are two important components that are considered. One is the autocorrelation function and the other is the partial autocorrelation function. So this is referred to as ACF and PACF. Right. So what is autocorrelation and what is the definition? Autocorrelation is basically the similarity between values of a same variable across observations, as the name suggests. Now, how do we actually find the autocorrelation function, the value, right? So this is basically done by plotting, and autocorrelation function also tells you how correlated points are with each other based on how many time steps they are separated by and so on. That is basically the time lag that we were talking about. And it is also used to determine how past and future data points are related. And the value of the autocorrelation function can vary from -1 to 1. So if we plot, this is how it would look. Autocorrelation function would look somewhat like this. And there is actually a readily available function in R. So we will see that and you can use that to plot your autocorrelation function. Okay. So that is ACF, and we will see that in our RStudio in a little bit. And similarly, you have partial autocorrelation function. So partial autocorrelation function is the degree of association between two variables while adjusting the effect of one or more additional variables. So this again can be measured and it can also be plotted, and its value once again can go from -1 to 1, and it gives the partial correlation of time series with its own lagged value. So lag again we have discussed in the previous couple of slides. This is how a PACF plot would look in RStudio. We will see that as well and once we get into the RStudio. And with that, let's get into RStudio and take a look at our use case. Before we go into the code, let's just quickly understand what exactly is the objective of this use case. So we are going to predict some values or forecast some values, and we have the data of the airline ticket sales of the previous years, and now we will try to find or predict or forecast the values for the future years. All right. So we will basically identify the time series components like trend, seasonality, and random behavior. We will actually visualize this in RStudio, and then we will actually forecast the values based on the past values or history data, historical data. So these are the steps that we follow. We will see in RStudio in a little bit. Just quickly, let's go through what are the steps. We load the data, and it is the time series data, and we try to find out what class it belongs to. The data is actually air passengers data that is already comes preloaded with RStudio, so we will be using that. and we can take a look at the data, and then what is the starting point, what is the end point. So these are all functions that are readily available we'll be using. And then what is the frequency? So it's basically frequency is 12, which is like yearly data, right? So every month the data has been collected. So for each year it is 12. And then we can check for any missing values if there are any. And then we can take a look at summary of the data. This is what we do in exploratory data analysis. And then we can plot the data, visualize the data, how it is looking, and we will see how the data has some trend, seasonality, and so on and so forth. All right, then we can take a look at the cycle of the data using the cycle function, and we can see that it is every month. That's the cycle. End of every 12 months, a new cycle begins. So each month of the year is the data is available. Then we can do box plots to see for each month how the data is varying over the various 10 or 12 years that we will be looking at this data. And from exploratory data analysis, we can identify that there is a trend, there is a seasonality component, and how the seasonality component varies also we can see from the box plots. And we can decompose the data. We can use the decompose function rather to see the various components like the seasonality, trend, and the irregularity part. Okay, so we will see all of this in RStudio. This is how they will look. This is the once you decompose, and this is how you can visualize the data. This is the actual data, and this is the trend. As you can see, it's going upwards. This is the seasonal component, and this is your random or irregularity, right? So we call it irregularity, or we can also call it random, as you can see here. Yes, so the data must have a constant variance and mean, which means that it is stationary before we start any analysis, time series analysis. And so basically, if it is stationary, only then it is easy to model the data, perform time series analysis. So we can then go ahead and fit the model. As we discussed earlier, we'll be using ARIMA model. There are some techniques to find out what should be the parameters. So we will see that when we go into RStudio. So the auto ARIMA function basically tells us what should be the parameters, right? So these parameters are the P, D, and Q that we talked about. That's what is being shown here. So if we use auto ARIMA, it will basically take all possible values of this P, D, Q, these parameters, and it will find out what is the best value, and then it will recommend. So that is the advantage of using auto ARIMA. All right. So like in this case, it will tell us if we use this parameter trace, we set the parameter trace is equal to true, then it will basically tell us what is the value of this AIC, which has to be minimum. So the lower the value, the better. So for each of these combinations of P, D, and Q, it will give us the values here, and then it will recommend to us which is the best model. Okay. Because whichever has the lowest value of this AIC, it will recommend that as our best PDQ values. So once we have that, we can see that we can potentially get a model or the equation. Model is nothing but the equation, and based on the parameters that we get. And we can do some diagnostics. We can do some plotting to see whether there is a plot for the residuals, so which shows the stationarity. And then we can also take a look at the ACF and PACF. We can plot the ACF and PACF, and then we can do some forecasting for the future years. So in this case, we have up to 1960, and then we can see how we can forecast for the next 10 years, which is 1970, up to 1970. And once we have done this, can we validate this model? Yes, definitely we can validate this model. And to validate the findings, we use junk box test. And this is how you just call box.test, and then you pass these parameters, and you will get the values that will be returned, which will tell us whether how accurate this model is, how accurate the predictions are. So the values of P are quite insignificant in this case. We will see that, and that also indicates that our model is free of autocorrelation, and that will basically be it. So let's go back and into our RStudio and go through these steps in real time. So we have to import this library. Forecast package is not installed. You have to go here and install the forecast package. Okay, so that's the easy way to install rather than, so click on this install. I will not do it now because I've already installed. So the first time, that's only one time. Then after that, you just have to load it into memory and then keep going. So we will load this data called air passengers. So by calling this data method, and if you see the data air passengers is loaded here, and if we check for the class, it is a time series data, TS data. So we can check for the dates. We can also view the data in a little bit, and the start date is 1949 and January, and our end date is 1960 December, and the frequency is 12, which is like collected monthly. So that is the frequency, which is 12 here, and then we check if there are any missing values. There are no missing values, and then we take a look at the summary of the data. This is all exploratory data analysis, and then if you just display the data, this is how it looks. And then we need to decompose this data, so we will kind of store this in an object TS data and then use that to decompose and store the new values. Let me just clear this for now. And if we decompose, basically as we have seen in the slides, decomposing is breaking it into the trend, seasonality, and the irregular or random components. Then you can go ahead and plot it. So when you plot it, you can see here, let me zoom this. This is our original plot, or observed value as it is known as. Then we have decomposed the three parts, which is basically the trend. As you can see, there is an upward trend. Then the seasonal component. So this is some regularly occurring pattern. And then there is a random value, which is basically you cannot really give any equation or function or anything like that. So that's what this plotting has done. And then you can actually plot them individually as well. So these are the individual plots for the trend, for the seasonal component, and the random component. All right. So now let's take a look at the original data and see how the trend is in a way. So if we do this linear regression line, it will show that it is going upwards. And we can also take a look at the cycle that are there, which is nothing but we have a frequency of 12, right? So the cycles will display that it is January, February to December, and then back to January, February, and so on and so forth. And if we do box plots for the monthly data, you will see that for each of the months, right? And over the 10 years that the data that we have, we will see that there is a certain pattern, right? This is also in a way to find the seasonality component. So while January, February sales are relatively low, around July, August, the sales pick up. So especially in July, I think the sales are the highest. And this seems to be happening pretty much every year, right? So this is every year in July, there seems to be a peak in the sales, and then it goes down and slightly higher in December and so on. So that is again part of our exploratory data analysis. And once again, let's just plot the data. Now, as I said, in order to fit into an ARIMA model, we need the values of P, D, and Q. Now, one way of doing it is, there are multiple ways actually of doing it. The earlier method of doing it was you draw the autocorrelation function plot and then partial autocorrelation function plot and then observe that and where does this change and then identify what should be the values of P and Q and so on. Now, R really has a very beautiful method which we can use to avoid all that manual process that we used to do earlier. So what R will do is, there is a method called auto ARIMA, and if we just call this auto ARIMA method, and it will basically go and test the ARIMA model for all possible values of these parameters P, D, Q, and then it will suggest to you what should be the best model, and it will return that best model with the right values of P, D, and Q. So we as data scientists don't have to do any manual, trial and error kind of stuff. Okay, so we got the model now, and this is the model. It has PDQ values are 211 PDQ, and this is the seasonal part of it, so we can ignore it for now. And so if we want to actually understand how this has returned these values 211 as the best one, there is another functionality or feature where we can use this trace function or trace parameter. So if you pass to auto ARIMA the trace parameter, what it will do is it will show you how it is doing this calculation. What is the value of the AIC? Basically, AIC is what defines the accuracy of the model. The lower, the better. Okay. So for each combination of PDQ, it will show us the value of AIC. So let's run it instead of me talking so much. Let's run this. If we run AutoArima with trace, you see here there is a red mark here. That means it is performing, it's executing this, and here we see the display, right? So it starts with certain values of PDQ, and then it finds that value is too high. So it starts with again with some 0, 1, 1, 0, and so on and so forth. And ultimately it tells us, okay, this is our best model. You see here, so it says this is our best model 211. Let's go back and see, did we get the same one? Yes, we got the same one when we ran without trace as well, right? Now, why is 211? Let us see, where is 211? Here is our 211, and if you compare the values, you see that 1017 is pretty much the lowest value, and therefore it is saying this is our best model. All other values are higher. So that's how you kind of get your model. And now that you have your model, what you have to do, you need to predict the values, right? So before that, let us just do some test of these values. So for that, you install T-Series. Again, if you are doing it for the first time, you would rather use this package and install and say T-Series and install it. And then you just use this library function to load it into your memory. Alright, so now that we got our model using AutoArima, let us go ahead and forecast and also test the model and also plot the ACF and PSCF. Remember, we talked about this, but we did not really use it. We don't have to use that, but at least we will visualize it. And for some of the stuff, we may need this T-Series library. So if you are doing this for the first time, you may have to install it. And my recommendation is don't use it in the code. You go here and install T-Series. And I will not do it now because I have already installed it, but this is a preferred method. And once you install it, you just load it using this libraries function. And then you can plot your residuals, and this is how the residuals look. And you can plot your ACF and PSCF. Okay, so this is how your PSCF looks, and this is how your ACF looks. For now, there is really nothing else we need to do with ACF and PSCF. This is just to visualize how it looks. But as I mentioned earlier, we were actually using these visualizations or these graphs to identify the values of P, D, and Q. And how that was done, it's out of scope of this video, so we will leave it at that. And then we will forecast for the next 10 years. How do we forecast that? So we call forecast, and we pass the model, and we pass what is the level of accuracy that you need, which is 95%, and for how many periods, right? So basically we want for 10 years, which is like 10 into 12 time periods. So that's what we are doing here. And now we can plot the forecast value. So you see this is the original value up to I think 62 or whatever, and then it goes up to 72. This blue color is the predicted value. Let's go and zoom it up so that we can see it better. So from here onwards, we're forecasting, and you can see that it looks like our model has kind of learned the pattern, and this pattern looks very similar to what we see in the actual data. Now, how do we test our model? So we can do what is known as a box test, and we pass our model here, residuals basically, with different lags. And from those values here, the p values here, we find that they are reasonably low, the p values, which means our model is fairly accurate.
Applications of data analytics. Now, the sky's the limit on this. In today's world, almost every business, act of life, your music on your Spotify are driven by data analytics. But some of the big players, when you go in there job hunting, are going to be your fraud analysis. If you want to go make a lot of money and you're good at it and you like dealing with numbers, go join the banks and track down the criminals who are stealing money. It's a lot of, it's a big thing to protect credit cards, protect sales purchases, bad checks, any of those things. When you can track them down is huge. Healthcare exploding. There's everything from trying to find cures for the COVID virus or any of the viruses out there, using your cell phone to diagnose different ailments. That way you don't have to go in and see the doctor. You can actually just go in there and take a picture of the funky growth on your arm. Hopefully it's not too big. And then they send it in there, and the data analytics goes in there and looks at it and says, oh, this is what this is. This is a professional you need to go see or don't need to see. And that's just one aspect of healthcare. The databases being generated by healthcare and getting the right doctors and helping the doctors analyze whether something is benign or malignant, if it's cancerous. All those things are now part of the ongoing healthcare growth in data analytics. Inventory management. Think one of those huge warehouses where they're shipping out all the goods. How do you inventory that in such a way so that you maximize the stuff that's being purchased the most near the entrance and all the other stuff towards the back, or even pre-ship it? So it's huge to be able to manage your inventory, and pretty soon they'll just have a drone come in there and start picking up some of those boxes and move them around also. Delivery logistics. Again, this goes from getting from point A to point B. You can combine it with our inventory, so you pre-ship stuff if you know a certain area is more likely to purchase it. How do you get the delivery to the most destinations the quickest in the short amount of time? And then they even pre-stack the trucks going out, and that's all done with data analytics. How do we stack all that stuff so it comes out in the right order? Targeted marketing. Huge industry. Any kind of marketing, whether you're generating the right content for the marketing, who are you targeting with that marketing, researching the people, what they want, so you know what products to market out there. All those things are huge. And these are just a few examples. You can probably go way beyond this, from tracking forest fires to astrology and studying the stars. All of this is part of data analytics now and plays a huge role in all these different areas. City planning is another one. You can see a nice organized city like this one where you can get in and out of the neighborhoods if you're a fire truck. Police officers need to be able to get in and out. You want your tourists to be able to come in, yet you still want the place to look nice, and you have the right commercial development, the right industrial development, like enough residents for people to stay. All those things are part of your city planning. Again, huge in data analytics. So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many sales per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up in the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive. Then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. If we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse cells, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three, because a lot of people stumble on this when they come in and are doing analytics. Whether you're the manager, shareholder or the data scientist coming in, you really need to understand the descriptive analytics, where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future. Gear up for how many employees we need, how much money we're going to make. And prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture. We're going to guess at what the area is looking for and how that marketing is going to change. Data analytics process steps. So let's take a look at some of the basic processing and what that looks like when you're working with this data. So there's 5 basic steps. The 5 steps of processing, and this changes, and then there's a lot of things that go on when they talk about agile programming. The whole concept of agile is you take some kind of framework like this and then you build on it depending on what your business needs. So the first step is data collection. And usually with a large company, you might have somebody who is responsible for the database management. You might have another one where they're pulling APIs and they're pulling data off of maybe the Census Bureau, maybe something very, very specific, domain specific. So if you're analyzing cancerous growths and how to understand them, then the data collection is going to be those measurements they take from the MRI. Or it might be even the MRI images. They've used those also. So there's a lot of things with data collection and how to control that and make sure it has what you need and is clean and you don't have misinformation coming in. Once you have the data collected, there's a data preparation. So stage 2 is we take that data and we format it into something we can use. Probably one of the biggest formats that you see is when you're processing text. How do you process text? Well, you use what they call a one-hot encoder, and each word is represented by a yes-no kind of setup. So it'd be like a long array of bits. That's one way to prepare it. And so, bit number 1 is the. Bit number 2 is has, or whatever it is. Other preparations might be if you're using neural networks, you might be taking integers or float numbers and converting them to a value between 0 and 1. That way you don't have one of them creating a bias in there. So there's a lot of different things that go into data preparation. That is 80% of data science. So when we talk about the data analytics, which is a little bit more on the math side, and they usually talk about a data scientist kind of being the overall preparer of this stuff, you're going to spend 80% of your data preparation. Data exploration, that's the fun part. This is where you're exploring things. And it is maybe 10 to 15% of what you do with the data you spend with the data exploration. It is probably the most important step, because this is where you got to start asking questions. If you ask your questions wrong, you're going to get some wrong information. If you're working with a company and they want to know the marketing values, then you really got to focus on, hey, how do we generate money for this company? Or fraud, how do we lower the fraud rate while still generating a profit? 4, data modeling. This is where we start actually getting into the data code, which model to use that predicts what's going to happen. And then result interpretation. We want to be able to interpret those results. You usually see that in your Matplot library, where you create nice, beautiful images so that it shows up on their dashboard for the marketing manager or for the CEO, so they can take a quick look and say, hey, I can see what's going on there. You want to reduce it to something they can easily read. They don't want to hear the scientific terms. They want to see something they can use. And we'll talk about that a little bit more when we start looking at some of this in a demo. Since this is data analysis with Python, we got to ask the question, why Python for data analytics? I mean, there's C++, there's Java, there's .NET from Microsoft. Why do people go to Python for it? So the number of reasons. 1, it's easy to learn with simple syntax. You don't have a very high typeset like you do in Java and other coding, so it allows you to kind of be a little lazy in your programming. That doesn't mean that it can't be set that way and that you don't have to be careful. It just means you can spin up a code much quicker in Python. The same amount of code to do something in Python a lot of times is 1, 2, or 3 or 4 lines, where when I did the same thing, say in Java, I found myself with 10, 12, 13, 20 lines, depending on what it was. It's very scalable and flexible. So there's our flexibility because you can do a lot with it, and you can easily scale it up. You can go from something on your machine to using PySpark into the Spark environment and spread that across hundreds, if not thousands of servers across terabytes of data or petabytes of data. So it's very scalable. There's a huge collection of libraries. This one's always interesting because Java has a huge collection of libraries. C has a huge collection of libraries. .NET does, and they're always in competition to get those libraries out. Scala for your Spark. All those have huge collections of libraries. This is always changing, but because Python's open source, you almost always have easy to access libraries that anybody can use. You don't have to go check your licensing and have special licensing like you do in some packages. Graphics and visualization, they have a really powerful package for that, so it makes it easy to create nice displays for people to read. And community support. Because Python is open source, it has a huge community that supports it. You can do a quick Google and probably find a solution for almost anything you're working on. Python libraries. Let's bring it together. We have data analytics and we have Python. So when we're talking data analytics, we're talking Python libraries for data analytics. And the big 5 players are NumPy, Pandas, Matplot library, SciPy, which is going to be in the background, so we're not going to talk too much about the scientific formulas in SciPy, and scikit. So NumPy supports n-dimensional arrays, provides numerical computing tools useful for linear algebra and Fourier transform. And you can think of this as just a grid of numbers. And you can even have a grid inside a grid, or data. It's not even numbers because you can also put words and characters and just about anything into that array. But you can think of a grid, and then you can have a grid inside a grid, and you end up with a nice 3-dimensional array. If you want to talk 3-dimensional array, you can think of images. You have your 3 channels of color, 4 if you have an alpha, and then you have your XY coordinates for the image we're looking at. So you can go X, Y, and then what are the 3 channels to generate that color. And NumPy isn't restricted to 3 dimensions. You could imagine watching a movie. Well, now you have your movie clips, and they each have their X number of frames, and each of those frames have X number of XY coordinates for the pictures in each frame, and then you have your 3 dimensions for the colors. So NumPy is just a great way to work with n-dimensional arrays. Now closely with NumPy is Pandas. Useful for handling missing data, perform mathematical operations, provides functions to manipulate data. Pandas is becoming huge because it is basically a data frame. And if you're working with big data and you're working in Spark or any of the other major packages out there, you realize that the data frame is very central to a lot of that. And you can look at it as an Excel spreadsheet. You have your columns, you have your rows or indexes, and you can do all kinds of different manipulations of the data within, including filling in missing data, which is a big thing when you're dealing with large pools or lakes of data where they might be collected differently from different locations. And Matplot library. We did kick over the SciPy, which is a lot of mathematical computations, which usually runs in the background of NumPy and Pandas. Although you do use them, they're useful for a lot of other things in there. But the Matplot library, that's the final part. That's what you want to show people. And this is your plotting library in Python. Several toolkits extend Matplot library functionality. There's like 100 different toolkits to extend Matplot library, which range from how to properly display star constellations from astronomy. There's a very specific one built just for that, all the way to some very generic ones. We'll actually add Seaborn in when we do the labs in a minute. Several toolkits extend Matplot library functionality, and it creates interactive visualization. So there's all kinds of cool things you can do as far as just displaying graphs, and there's even some that you can create interactive graphs. We won't do the interactive graphs, but you'll see, you'll get a pretty good grasp of some of the different things you can do in Matplot library. Let's jump over to the demo, which is my favorite. Roll up our sleeves, get our hands in on what we're doing. Now, there's a lot of options when we're dealing with Python. You can use PyCharm as a really popular one. And you'll see this all over the place. So it's one of the main ones that's out there, and there's a lot of other ones. I used to use NetBeans, which has kind of lost favor. Don't even have it installed on my new computer. But the most popular one right now for data science, now PyCharm's really popular for Python general development. For data science, we usually go to Jupyter Notebook or Anaconda. And we're going to jump into Anaconda because that's my favorite one to go to because it has a lot of external tools for us. We're not going to dig into those, but we will pop in there so you can see what it looks like. So with Anaconda, we have our Jupyter Lab, we have our notebook. These are identical. Jupyter Lab is an upgrade to the notebooks with multiple tabs. That's all it is. And we'll be using the notebook. And you can see that PyCharm is so popular with Python that we even have it highlighted here in Anaconda as part of the setup. Jupyter Notebook can also be a standalone. So we're actually going to be running Jupyter Notebook. And then you have your different environments. We're going to be under main Py36. There's a root one. And I usually label it Py36. The reason is currently as of writing this, TensorFlow only works in 3.6 and not in 3.7 or 3.8 for doing neural networks. But you can actually have multiple environments, which is nice. They separate the kernels, so it helps protect your computer when you're doing development. And this is just a great way to do a display or a demo, especially if you're looking for that job. Pull up your laptop, open it up. Or if you're doing a meeting, get it broadcast up to the big screen so that the CEO can see what you're looking at. And when we launch the notebook, it actually opens up a file browser in whatever web browser you have. This happens to be Chrome. And then you can just go under New. There's a lot of different options depending on what you have installed. Python 3. And this just creates an untitled version of this. And you can see here I'm actually in a Simplilearn folder for other work I've done for Simplilearn. And that's where I save all my stuff and I can browse through other folders, making it real easy to jump from one project to another. And under here, we'll go ahead and change the name of this, and we'll go ahead and rename it Data Analytics. Data Analytics. Just so I can remember what I was doing. Which is probably about 50 of the folders in here, or files in here right now. So let's go ahead and jump in there and take a look at some of these different tools that we were looking at. And as we go through the demo, let's start with the NumPy. The least visually exciting. And I'm going to zoom in here so you can see what we're doing. And the first thing we want to do is import NumPy. And we'll import it as NP. That is the most common NumPy terminology. And let's go ahead and change the view so we also have the line numbers. I don't know why, we probably won't need them, but I like it for easy reference. And then we'll create a one-dimensional array. We'll just call this array1. And it equals np.array, and you put your array information in here. In this case, we'll spell it out. You can actually do like a range and other ways. There's lots of ways to generate these arrays. But we'll just do 1, 2, 3, so 3 integers. And if we print our array1, we can go ahead and run this. And you can see right here it prints 1, 2, 3. You can see why this is a really nice interface to show other people what you're doing with the Jupyter Notebook. So this is the basic. We've created an array. This is a one-dimensional array, and then the array is 1, 2, 3. One of the nice things about the Jupyter Notebook is whatever ran in this first setup is still running, is still in the kernel. So it still has the NumPy imported as NP, and it still has our variable ARR1 for array1 equal to NP array of 1, 2, 3. So when we go to the next cell, we can check the type of the array. We're just going to print. We say, hey, what is this setup in here? And we want type. And then we want, what is the type of array 1? And let's go ahead and run that. And it says class NumPy ND array. So it's its own class. That's all we're doing is checking to see what that class is. And if you're going to look at the array class, probably the biggest thing you do, I don't know how many times I find myself doing this because I forget what I'm working on and I forget I'm working with a 3-dimensional or 4-dimensional array. And I have to reformat somehow so it works with whatever other things I have. And so we do the array shape. The array shape is just 3 because it has 3 members and it's a 1-dimensional array. That's all that is. And with the NumPy array, we can easily access, stick with the print statement. If you actually put a variable in Jupyter Notebook and it's the last one in the cell, it will be the same as a print statement. So if I do this, where array 1 of 2, it's the same as doing print array of 2. Those are identical statements in our Jupyter notebook. We'll go and stick with the print on this one. And it's 3. So there's our print space 2, and we have 0, 1, 2. 2 equals 3. We can easily change that. So we have array 1 of place 2 equals 5. And then if we print our array 1, you can see right down here when it comes out, it's 1, 2, and 5. And there I left the print statement off because it's the last variable in the list. It'll always print the variable if you just put it in like that. That's a Jupyter notebook thing. Don't do that in PyCharm. I've forgotten before doing a demo. And we talked about multiple dimensions, so we'll do an array, two-dimensional array. And this is again a NumPy array. And in the NumPy array, we need our first dimension, we'll do 1, 2, 3, and our second dimension 3, 4, 5. And you can see right here that when we hit the, we'll do this, we'll just do array 2. And we can run that, and there's our array 2, 1, 2, 3, 3, 4, 5. We can also do array 2 of 1. And then we can do, let's do 0. Doesn't really matter which one. Actually, let's do 2. There we go. And if I run this, it'll print out 5. Because here we are. This is 0. 0, 1, 2, 3 is on our 0 row. 3, 4, 5 is on our 1 row. I always start with 0. And then the 2, 0, 1, 2 goes to the 5. And then maybe we forgot what we were working with. So we'll go do array2.shape. And if we do array 2 of shape, we'll go and run that. We'll see we have 2 rows, and each row has 3 elements. Two-dimensional array, 2, 3. If you looked up here when we did it before, it just had 3, nothing. When you have a single entity, it always saves it as a tuple with a blank space. But you can see right here we have 2, 3. And if you remember from up here, we just did this array 2 of, let's go, what is it, 1, 2. We run that, we get the 5. You can also count backwards. This is kind of fun. And you'll see I just kind of switched something on you because you can also do 1, 2 to get to the same spot. Now 2 is the last one, 0, 1, 2. It's the last one in there. We can count backwards and do -1. And if we run this, we get the same answer. Whether we count it as, let's go back up here, whether we count this as 0, 1, 2, or we count backwards as -1, -2, -3. And you can see that if I change this -1 to a -2 and run that, I get 4, which is going backwards, -1, -2. So there's a lot of different ways to reference what we're working on inside the NumPy array. It's really a cool tool. It's got a lot of things you can do with it. And we talked about the fact that it can also hold things that are not values, and we'll call this array ask for strings equals np.array. Put our setup in there, our brackets, and let's go China, India, USA, Mexico. It doesn't matter, we can make whatever we want on here. And if we print that out, we run this, you can see that we get our NumPy array, China, India, USA, Mexico. It even gives us our D type of a U6. And a lot of times when you're messing with data, we'll call this array R for range, just to kind of keep it uniform. np.arange. So this is a command inside NumPy to create a range of numbers. And if you're testing data, maybe you want, maybe you have equal time increments that are spaced a certain point apart. But in this case, we're just going to do integers. And we're going to do a setup from 0, 20, skipping every other one. And we'll print it out and see what that looks like. And you can see here we have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Like you expected, it skips every one. And just a quick note, there's no 20 on here. Why? Well, this starts at 0 and counts up to 20. So if you're used to another language where it explicitly says less than or less than equal to 20, like for x equals 0, x plus plus, x is less than 20. That's what this is. It just assumes x is less than 20 on here. And if we want to create a very uniform set, 0, 2, 4, 6, what happens if I want to create numbers from 0 to 10, but I need 20 increments in there? We can do that with line space. So we can create an R, we'll call this L, equals, I don't think we'll actually use any of this again, so I don't know why I'm creating unique identifiers for it. But we'll do NP, lin space, and we're going to do 0 to 10, or 0 to 9. Remember, it goes up to 10. And then we want to, let's say we have 20 different increments in there. So we're creating we have a data set, and we know it's over a certain time period, and we need to divide that time period by 20. And it happens to just have 10 pieces in it. And here we go. You can see right here, we have 20, or it has 20 pieces in it, but it's over 10 years. And we got to divide it in the middle. And you can see it goes 0.52. Remember, yeah, there's our 10 on the end, so it goes up to 10. And then we can also do random. There's np.random. If you're doing neural networks, usually you start it by seeding it with random numbers. And we'll just do np.random, and we'll just call this array. We'll stop giving it unique numbers. We'll print that one out and run it. And you can see we have random numbers. They are 0 to 1. So you'll see that all these numbers are under 1. And you can easily alter that by multiplying them out or something like that if you want to do like 0 to 100. You can also round them up if it's integer 0 to 100. There's all kinds of things you can do, but it generates a random float between 0 and 1. And you have a couple options. You could reshape that, or you can just generate them in whatever shape you want. And so we can see here, we did 3 and 4, and so you can see 3 rows by 4 variables. Same thing as doing a reshape of 12 variables to 3 and 4. And if you're going to do that, you might need an empty data set. I have had this come up many times where I need to start off with 0, and I don't know, because I'm going to be adding stuff in there, or it might be 0 and 1, where 1 is, if you're removing the background of an image, you might want the background is 0, and then you figure out where the image is, and you set all those boxes to 1, and you create a mask. So creating masks over images is really big, and doing that with a numpy array of 0. And we can also give it a space. And we'll just do this all in one shot this time. And we'll do the same thing like we did before, zeros. And in this case, we'll do 2, 3. And so when we run this, forgot the asterisks around it. I knew I was forgetting something. There we go. So when we run this, you can see here we have our 10 zeros in a row, and maybe this is a mask for an image, and so it has 2 rows of 3 digits in it. So it's a very small image, little tiny pixel. And maybe you're looking to do something the opposite way. Instead of creating a mask of zeros and filling in with ones, maybe you want to create a mask of ones and fill them in with zeros. And we'll just do, just like we did before, we'll do 3, 4. And when we run this, you'll see it's all ones. And we could even do this even, we'll do it this way. Let's do 10 by 10 icon, and then you have your 3 colors. And you can, so it creates quite a large array there for doing pictures and stuff like that when you add that 3rd dimension in. If we take that off, it's a little bit easier to see. We'll do 10 again. And you can easily see how we have 10 rows of 10 ones. And you can also do something like create an array. And we'll do 0, 1, 2. And then in this array, we actually, we'll print it right out. we want a repeat. And so you can actually do a repeat of the array, and maybe you need this array, let's repeat it 3 times. So there's our repeat of an array, repeat 3 times. And if we run this, you'll see we have 0, 0, 0, 1, 1, 1, 2, 2, 2. And whenever I think of a repeat, I don't really think of repeating being the first digit 3 times, the second digit. I really always think of it as 0, 1, 2, 0, 1, 2, 0, 1, 2. It catches me every time. But the actual code for that one is going to be tile. And again, if we do a range 3 and we run this, you can see how you can generate 0, 1, 2, 0, 1, 2, 0, 1, 2. And if you're dealing with an identity matrix, we can do that also if you're big on doing your matrices. And we'll just identity. I guess we'll go ahead and spell it out today. Matrix. And the command we're looking for is EYE. And we'll do 3. And then we'll just go ahead and print this out. There we go. There's our identity matrix. And it comes out by a 3 by 3 array, because there's our matrix. And then it puts the 1s down the middle and for doing your different matrix math. And we can manipulate that a little bit too. We talk about matrices. We might not want 1s across the middle, in which case we now have the diagonal. So we can do an np.diagonal. And we do a diagonal. Let's put in the diagonal 1, 2, 3, 4, 5. And when we run this, again, this generates a value. And by just putting that value in, there's the same as putting print around it, or putting array equals and then print array. And you can see it generates a diagonal 1, 2, 3, 4, 5, and there's your beginning of your matrix array for working with matrices. And we can actually go in reverse. Let's create an array equals, remember our random dot-random, and we'll do a 5 by 5 array. Oops, there we go. 5 by 5. And just so you can see what that looks like. Helps if I don't mistype the numbers, which in this case I just need to take out the brackets. And there you go. You have your 5 by 5 array set up in there. And we can now, because we're working with matrices, we might want to do this in reverse and extract the diagonals, which would be the 0.79, the 0.678, and so on. And we simply type in np.diagonal. We put our array in there. And this will, of course, print it out because it returns it as a variable. And you can see here, here's our diagonal going across from our matrix. And we did talk about shape earlier. If you remember, you can do print the shape out. You can also do the dimensions. So in dimensions, very similar to shape, it comes out and just has 2 dimensions. We can also look at the size. So if we do size on here, we can run that. And you can see it has a size of 25, 2 dimensions, and of course 5 by 5. And that was from the shape from earlier that we looked at. There's our 5 by 5 shape. And if you remember earlier we did random, well, you can also do random. I talked a little bit about manipulating 0 to 1 and how you can get different answers. You can also do straight for the integer part, and we'll do minus 10 to 10, 4. And so we're going to generate random integers between minus 10 to 10. We're going to generate 4 of those. And so when we run that, we have 7, minus 3, minus 6, minus 3. They're all between minus 10 and 10, and there's 4 of them. And now we jump into some of the functionality of arrays, which is really great, because this is where they come in. Here's your array, and you can add 10 to it. And if I run this, there it takes my original array from up here with the integers and adds 10 to all of those values. So now we have, oh, this is the decimal, that's right. This is a random decimal I had stored in an array. But this takes a random decimal, the random numbers I had from 0 to 1 and adds 10 to them. And we can just as easily do minus 10. We could even do times 2. And we could do divide by 2. And it'll take that random number we generated and cut it in half. So now all these numbers are under 0.5. Another way you can change the numbers to what you need on there. And as you dig deeper into NumPy, we can also do exponential. So as an exponential function, which should generate some interesting numbers off of the random. So we're taking them to the power, I don't even remember what the original numbers in the array were, because we did the random numbers up there. Here's our original numbers, and if you build an exponential on there, this is where you get e to the x on this. And just like you can do e to the x, you can also do the log. So if you're doing logarithmic functions, that reinforced learning, you might be doing some kind of log setup on there, and you can see the logarithmic of these different array numbers. And if you're working with log base 2, you can just change it in there, np log 2. You have to look it up, because this is not log 1, 2, 3, 4, 5. It is log and log 2. So just a quick note, that's not a variable going in. That is an actual command. There's a number of them in there, and you'll have to go look and see what the documentation is. But you can also do log 10. So here's log value 10. Some other really cool functions you can do with this is your sine. So we can take a sine value of all of our different values in there. And if you have sine, you of course have cosine. We can run that. So here's a cosine of those. And if you're doing activations in your NumPy array and you're doing a tangent activation, there's your tangent for that. And the tangent activation is actually from neural networks. That's one of the ways you can activate it, because it forms a nice curve between from whether you're generating 1 to -1 with some discrepancy in the middle. Just jumping a little bit in there into neural networks. And then we get into, let me just put the array back out there so that we can see it while we're doing this. As we're getting into this, you can also sum the values. So we have np sum, and you can do a summation of all the values in this array. And you'll see that if you added all these together, they'd equal 12.519, and so on. I don't know what the whole setup is in there. But you can see right here the summation of this. One of the things you can also do is by axes. So we could do axes equals 0. And if we run the summation of the axes equals 0, and you can think of that in NumPy as the rows. So that would be, or you can think of that in NumPy as being the columns. We're summing these columns going across. And you can also change this to 1, and now we're summing the rows. And so that is the summation of this row, and so forth going down. And maybe you don't need to know the summation. Maybe what you're looking for is the minimum. So here's our minimal. You're looking for, and this comes up a lot because you have like your errors. We want to find the minimal error inside of this array. And just like the other one, we can do axes equals 0. And you can see here 0.0645 is the smallest number in this first column is 0.0645, and so on. And if you have a minimum, well, you might also want to know the max. Maybe we're looking for the maximum profit. And here we go. You can see maximum 0.79 is the maximum on this first column. And just like we did before, you can change this to a 1 on axes. You can take the axes out of here and just find the max value for the whole array. And the max value in here was 0.8344, so on and so on. And since we're talking data analytics, we want to go ahead and look at the mean. Pretty much the same as the average. This is the mean across the whole thing. And just like we did before, we could also do axes equals 0. And then you'll see this is the mean of this axis, and so on. And we have mean. We might want to know the median. And there's our median, our most common numbers. If we have median, we might want to know the standard deviation. Or if we have the average, a lot of times you do the means and the standard deviation. We can run that, and there's our standard deviations along the axes. We can also do it across the whole array. If we're going to do standard deviations, there's also variance, which is your VAR. And there's our variance across the different levels. And so if we looked at that, we looked at variance, we looked at standard deviation, the median, and the means. There's more, but those are the most common ones used with data analytics. And then going through your data and figuring out what you're going to present to the shareholders. And some other things we can do is we can actually take slices. You'll hear that terminology. And a slice might be, like we have a 5 by 5 array, but maybe we don't want the whole array. Maybe we want from 1 on, we don't want the 0 in there. So we got up to 4. And maybe on the second part, we just want 2 to row 3. And so this notation right here says 1 to the end. And if we run this, you can see how that generates a single row to the end, and then row 2 and 3. Now remember, it doesn't include 3. That's why we only get the 1 column. So if you wanted 2 and 3, you would need to go ahead and go 2 to 4. So it goes up to 4. We could also do this in reverse. Just like we learned earlier, we can go -1. Whoops. And when we go to -1, it's the same thing because we have 0, 1, 2, 3, 4. This is the same thing as 2 to 4. It goes 2 to the last one. Also very common with arrays is you're going to want to sort them. So we still have our array up here that we randomly generated. And we might want to sort it. And we'll go and throw an axis back in there. Axis equals 1. If we run this, you can see from the axes that it sorts it, the 0.2 being the lowest value to the highest value by the row. We can also change this, of course, to axis 0. If you're sorting it by columns, so maybe your values are based on columns. And then, of course, you can do the whole array, and we can sort that. Don't usually do that, but I guess sometimes that might come up. And so you can see right here we have a nice sorted array. Something else, let's just go ahead and reprint our array so we can look at it again. Starting to get too many boxes up there. Something else you can do with an array is we can take and transpose it. This comes up more than you would think. When you transpose it, you'll see that the rows in the column are transposed. So where 0.79, 0.57, 0.064 is the column, now we've switched it and we have 0.79, 0.42 as the index. You can see this really more dramatic if we take a slice, and we'll just do a slice of the first couple, and then we'll just do all the other, the full rows. And if we run this, you can see how it comes up a little bit different. And we'll just do the same slice up here so you can see how those two look next to each other. There we go. There's our slice. Run. And so you can see the slice comes up and it has 1, 2, 3, 4, 5 columns. Now we have 1, 2, 3, 4, 5 rows and 3 columns versus 3 rows. And the original version, when they first started putting this together, was a function. So the original version was transpose, and this still works. You can still see it generates the same value as just a capital T. So many times we flip this data because we'll have an XY value or we'll have an image or something like that, and it's being read one way into the next process, and the next one needs it the opposite. So this actually happens a lot. You need to know how to transpose the data really quick. And we can go ahead, let's just take, here's our transpose. We'll just stick with the transpose on here. And instead of doing it this way, we might need to do something called flattening. Why would you flatten your data? If this is an array going into a neural network, you might want to send it in as one set of values instead of 2 rows. And you can see here is all the values as a single array. It just flattens it down into one array. So we covered our scientific means, transpose, median, some different variations on here. Some of the other things we want to do is what happens if we want to append to our array. So let's create a new array. I'm getting tired of looking at the same set of random numbers we generated earlier. So we'll go ahead and create a new array here, something a little simpler so it's easier to see what we're doing. And 4, 5, 6, 7, 8. That's good enough. We'll just do 4, 5, 6, 7, 8. And if we print this array, there it is, 4, 5, 6, 7, 8. And we might want to append something to the array. So we have our array, we need to extend it. You got to be very careful about appending things to your array, and there's a number of reasons for that. One is runtime. Because of the way the NumPy array is set up, a lot of times you build your data and then push it into the NumPy array instead of continually adding on to the array. And then it also it automatically generates a copy for protecting your data. So there's a lot of reasons to be careful about appending this way. But you can certainly do it. And we can just take our array, we're going to create a new array, array 1. And if we print array 1 and we append 8 to it, you'll see 4, 5, 6, 7, and then there's our 8 appended onto the end. And if you want to append something to an array, you'd probably also want to, whoops, array 1. Let's try that again. There we go. Now we have the 8 appended onto the end. So you can see 4, 5, 6, 7, 8, and then we appended another 8 on there. And if you're going to append something, you might want to go ahead and insert. Instead of appending, it might be you need to keep a certain order. And we can do the same thing. We can do our array, and we're going to append or insert at the beginning. And let's go ahead and insert 1, 2, 3. 1, 2, 3. And we go ahead and print our array 2. We run it, and you can see 1, 2, 3 is inserted at the beginning. Insert's a lot more powerful in that you can put it anywhere in the array. We can move it to the 1 spot, and there we go, 1, 2, 3. We can do a -1 just for fun, and you'll see it comes up 1, 2, 3, and we're counting backwards by 1. I imagine you can do a -0 and run this, and it turns out that -0 puts it back at the beginning, because that's how it registers as 0, it just takes a minus sign off. And just like we add numbers on, we might want to delete numbers. And so let's do an np.delete. Well, let's keep it a little bit, make it a little easy here to watch. We'll go ahead and create an array 3, and we'll do np delete. We were just working with array 2, and what we want to do is delete 0 space. So if you look at this, here's our array 2. Array 2 starts with 1. And when we delete the space on here and print that out, we deleted the 1 right out of there. And we can also do something like this, where we can do it as a slice. And we can do, let's do 1, 3. And if we run 1, 3, you'll see we've deleted the 1 space and the 3 space out, which deleted our 2 and 4. Now, keep in mind, when you're messing with adding lines and deleting lines, you have to be really careful, because there's a time element involved as far as where the data is coming from, and it's really easy to delete the wrong data and corrupt what you're working on, or to insert stuff where you don't want it. So there's always a warning when we talk about manipulating NumPy arrays. And just like anything else we're doing, we'll create an array C, which equals, we'll just do our NumPy array that we just created, our NumPy array 3, and we can do copy. So you can make a copy of it. Maybe you want to protect your original data, or maybe you're making a mask, and so you copy the array, and then the new array make all these alterations and change it from values to 0 to 1 to mask over the first one. And of course, if we do array C, since it equals a copy of array 3, it's the same thing, 1, 3, 5, 6, 7, 8. And now we're getting into combine and split arrays. I end up doing a lot of this, and I don't know how many times I end up fiddling with this and having a mess. But you do it a lot. You know, you combine your arrays, you split them, you might need one set of data for one thing, another set of data for the other. So let's go ahead and create 2 arrays, array 1, array 2. And I want you to note, and the terminology we're going to look for is concatenate. And what that means is we're going to take, we'll call this array cat. I like array cat. There we go. Our array cat, our concatenated array, we're taking array 1 and 2, and it's very important to really pay attention to your axes and your counts. I can't merge two arrays that have, like, if their axes are messed up and I'm merging on axis 0, it's going to give me an error and I'll have to reshape them. So you got to make sure that whatever you're concatenating together works. And what that means, as you can see here, we have 1, 2, 3, 4, 1, 2, 3, 4, and then 5, 6, 7, 8, 5, 6, 7, 8 along the 0 axis. These each are 4 values. So it's a 2 by 4 value. And if we go ahead and switch this to 1, you can see how that flips it a little bit. So now we have 1, 2, 3, 4, 5, 6, 7, 8. It's interesting that we chose that one. If I did something like this, where this is now, there we go, and we concatenate it, run this, and it gives me an answer okay because I have 2 by 2, and I'm using axis 1. But if I switch this to axis 0, where now it's got 3 and 5, it gives me an error. So you got to be really careful on that to make sure that whatever axes you are putting together, that they match. So like I said, this one, oops, axis 1. Axis 1 has 2 entities, and since we're going on axis 1, or by row, you can see that it lets it merge it right onto the end there. And you could imagine this if this was a XY plot of value, or the X value going in and the predicted Y value coming out, and then you have another prediction and you want to combine them. This works really easy for that. And we'll go back and let's just put this back to where we had it. Oops, I forgot how many changes I made. There we go. We'll just put it, whoops, I messed up on my concatenation order here. There we go. Okay, so you can see that we went through the different concatenation. Axes is really important when you're doing your concatenation values on here. And we'll switch this back to 1 just because I like the looks of that better. There we go. 2 rows. Now, there are other commands in here. So we can do cat v equals np v stack. This is nothing more than your concatenation. But instead, we don't have to put the axes in there because V stands for vertical. And so if we print out cat V and we run this, you can see we get the 1, 2, 3, 4, 1, 2, 3, 4, and that would be the same as making this axis 0 for vertical stack. And if you're going to have a vertical stack, you can also have an H stack. So if we change this from V stack to, oops, here we go, H stack, and we'll just change this from cat to cat, and I run this, it's the same as doing axis 0. The process is identical in the background. This is like a legacy setup, your V stack and your H stack. Most people just use concatenate and then put the axes in there because it's has a lot more clarity and is more commonly used nowadays. The last section in NumPy we're going to cover is kind of data exploration, and that'll make a little bit more sense in just a moment. Sometimes they call them set operations. But let's say we have an array, 1, 2, 3, 4, 5, 6, 3, whatever it is. You can see we generate a nice little array here. And what I want to go ahead and do is find the unique values in that array. So maybe I'm generating what they call a one-hot encoder, and so these values then all become, I need to know how long my bit array is going to be. So each word, each word is represented by a number, and then I want to know just how many of those words are in there. If we're doing word count, very popular thing to do. And you can see here when we do unique, we have 1, 2, 3, 4, 5, 6. Those are our unique values. Some of the things we can do with the unique values is we can also, instead of doing just unique, we can do uniques, our unique values, and counts of each unique value. And this is very similar to what we just did up here, where we're doing np unique, but we're going to add a little bit more into there. And it's just part of the arguments in this. And we want to do return counts equals true. So instead of just returning the unique values, we want to know how many of those unique values are in each one. And we'll go ahead and print our uniques. and print our counts. When we run that, you can see here we have our unique value 1, 2, 3, 4, 5, 6, just like we had before. And then there's two of the first of 2 1s, 2 2s, 2 3s, 2 4s, 1 5, 2 6s, and so on. And you can go through and actually look at that if you want to count them. But a quick way to find out your distribution of different values. So you might want to know how often the word the is used versus the word and, if each word is represented as a unique number. And along the set variables, we might want to know, let me just put a note up here. We're going to start looking at intersection, and we might want to also know differentiation, and neither. So when we're, neither. So when we're looking at now is we want to know, hey, where do these two arrays intersect? And we have 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. We might want to know what is common between the two arrays. And so when we do that, we have NP intersect, and it's a 1D array, one-dimensional array. And then we need to go ahead and put array 1, array 2. And if we run this, we can see they intersect at 3, 4, 5. That's what they have common. And because we're going to go ahead and go through these and look at a couple different options, let's change this from intersect 1D. And we'll do the same thing. We'll go ahead and print this. So we might want to know the intersection where they have commonalities. Another unique word is union of 1D. So instead of intersect, we want to know all the values that are in both of them. So here's our union of 1D. When we run that, you can see we have 1, 2, 3, 4, 5, 6, 7. So it's all the different values in there. And the last, one of the last words, we have 2 more to go, is we want to know what the set difference is. And so that's where you'll see that, if you remember set, we talked about that being what they call these things. So the set difference of a 1D array, when we run that, you can see that 1 is only in one array and 2 is only in one array. And if we want to know what's in array 1 but not in array 2, we might want to know what is in array 1 but not 2 and what's in 2 but not 1. And this would be the set XOR 1D on here. So we have the 4 different options here where we can do an intersection. What do they both have in common? We can do a union. What are all the unique values in both arrays? We can see the difference, what's in array 1 but not array 2, so set diff 1D. And then set XOR, what is not in 1 but is in 2, and what is not in 2 but in 1. So we dug a lot in NumPy because we were talking, there's a lot of different little mathematical things going on in NumPy. A lot of this can also be done in pandas, although usually the heavy lifting is left for NumPy because that's what it's designed for. Let's go ahead and open up another Python 3 setup in here. And so we want to explore what happens when you want to display this. This is where it starts getting, in my opinion, a little fun because you're actually playing with it and you have something to show people. And we'll go ahead and rename this. We're going to call this pandas and pyplot. So pandas pyplot, just so I can remember for next time. And we want to go ahead and import the necessary libraries. We're going to import pandas as PD. Now remember, this is a data frame, so we're talking rows and columns, and you'll see how pandas work so nicely when you're actually showing data to people. And then we're going to have NumPy in the background. NumPy works with pandas, so a lot of times you just import them by default. Seaborn sits on top of the matplot library. So sometimes we use the Seaborn because it kind of extends. It's one of the 100 packages that extends the matplot library. Probably the most common used because it has a lot of built-in functionality. Almost by default, I usually just put Seaborn in there in case I need it. And of course we have matplot library as pyplot, as PLT. And note we have as PD, as NP, as SNS, as PLT. Those are pretty standard. So when you're doing your imports, I would probably keep those just so other people can read your code and it makes sense to them. That's pretty much a standard nowadays. And then we have the strange line here. It says ampersand matplot library inline. That is for Jupyter Notebook only. So if you're running this in a different package, you'll have a pop-up when it goes to display the matplot library. You can, with the most current version of Jupyter, usually leave that out and it will still display it right on the page as we go. And we'll see what that looks like. And then we're going to go ahead and just do the Seaborn, the sns.set, and we're going to set the color codes equals true. Let them just keep the default ones so we don't have to think about it too much. And we of course have to run this. The reason we run this is because these values are all set. If we don't run this and I access one of these afterward, it'll crash. The cool thing about Jupyter Notebooks is if you forgot to import one of these, you forgot to install it, because you do have to install this under your Anaconda setup or whatever setup you're in, you can flip over to Anaconda and run your install for these. And then just come back and run it. You don't have to close anything out. And we'll go ahead and paste this one in here real quick, where we have car equals pd.read_csv, and then we have the actual path. This path, of course, will vary depending on what you are working with. So it's wherever you save the file at. And you can see here I have like my OneDrive documents, Simplilearn, Python, data analytic, using Python, / car CSV. It's quite a long file. When we open that up, what we get is we get a CSV file, and we have the make, the model, the year, the engine, fuel type, engine horsepower, cylinders, and so on. And this is just a comma separated file. So each row is like a row of data. Think of it as a spreadsheet. And then each one is a column of data on here. And as you can see right here, it has the make, model. So it has columns for a header on here. Now, your Pandas just does an excellent job of automatically pulling a lot of this in. So when you start seeing the Pandas on here, you realize that you are already like halfway done with getting your data in. I just love Pandas for that reason. NumPy also has it. You can load a CSV directly into NumPy, but we're working with Pandas, and this is where it really gets cool, is I can come down here and I can print, you remember our print statement, we can actually get rid of it. And we're just going to do car head because it's going to print that out. The head is going to print the top values of that data file we just ran in. And so you can see right here, it does a nice printout. It's all nice and inline because we're in Jupyter Notebook. I can scroll back and forth and look at the different data. And just like we expected, we have our column, and it brought the header right in. One thing to note is the index. It automatically created an index 0, 1, 2, 3, 4, and so on. And we're just looking at the head. So we got 0, 1, 2, 3, 4. You can change this. You might want to just look at the top two. We can run that. There's our top two BMWs. Another thing we can do is instead of head, we can do tail. And look at the last three values that are in that data file. And you can see right here, it numbered them all the way up to 11,913. Oh my goodness, they put a lot of data in this file. I didn't even look to see how big the file was. So you can really easily get through and view the different data in here. When you're talking about big data, you almost never just print out car. In fact, let's see what happens when we do. If we run this and we just run the car, it's huge. In fact, it's so big that the Pandas automatically truncates it and just does head plus tail, so you can see the two. So we really don't want to look at the whole thing. We'll go and go back to, let's stick with the head, displaying our data. There we go. So there's the head of our data. It gives us a quick look to see what's actually in there. I can zoom out if we want, so you can actually get a better view. Although we'll keep it zoomed in so you can see the code I'm working on. And then from the data standpoint, we of course want to look at data types. What's going on with our data? What does it look like? Now this, you show when you're talking to your shareholders, they like to see these nice, easy to read charts. They look like a spreadsheet. So it's a nice way of displaying pieces of the chart. When we talk about the data types, now we're getting into the data science side of it. What are we working with? Well, we have make, model, we have an integer 64 for the year, engine fuel type is an object, If we go up here, you can see that most of them are it's a set manual, rear wheel drive, so they might be very limited number of types in there, and so forth. And it's either going to be a float 64, an integer, or an object is the way it's going to read it on here. And the next thing you're going to know is like your columns. And since it loaded the columns automatically, we have here the make, the model, the year, the engine, the size, all the way up to the MSRP. And just out of something you'll see come up a lot is whenever you're in pandas and you type in dot values, it converts it from a pandas list to a numpy array. And that's true of any of these. So then you end up in a numpy array. So you'll see a little switch in there in the way that the data is actually stored. And that's true of any of these. In this case, we want car.columns. You have a total list of your car columns. And like any good data scientist, we want to start looking at analytical summary of the data set. What's going on with our data? So we can start trying to piecemeal it together. So we can do car, describe, and then what we'll do include equals all. So a nice panda command is to describe your data. If you're working with R, this should start looking familiar. And we come down here and you can see count. There's the make, the model, the year, how many of each one, how many unique values of each one, the top value of each one, what's most common, the frequency, the mean. Clearly on some of these it's an object, so it really can't tell you what the average is. It'd just be the top one's the average, I guess. The year, what's the average year on there? All this stuff comes down here. Your standard deviation, your minimum value, your maximum value, what's in the lower quarter, 50% mark, where's that line at, and what's in the upper 75%, the top 25% going into the max. Now, this next part is just cool. This is what we always wanted computers to be back like in the 90s, instead of 5,000 lines of code to do this. Maybe not 5,000. All right, I built my own plot library back in 95, and the amount of code for doing a simple plot was, I don't know, probably about 100 lines of code. This is being done in one line of code. We have our car, which is our pandas. We generated that. It's our data frame. And we have .hist for histogram. That is the power of Seaborn. Now, it's still going to generate a numpy graph, but Seaborn sits on top, and then we can do the figure size. This is just so it fits nicely on the paper on here. And we do something simple like this, and you can see here where it comes up, and it does say matplot library and does subplots and everything. But we're looking at a histogram of all the different pieces in our database. And we have our engine cylinders. That's always a good one because you can see like they have some that they had a null on there, so they came out as 0. Maybe one of them had a 2-cylinder engine way back when. 4 is a common, 6 a little less common, and then you see the 8-cylinder, 12-cylinder engines. Boy, that's got to be a speedster or something. But you can see right here, it just breaks it down. So now you have how many cars with how many, whatever it is, cylinders, horsepower, and so on. And it does a nice job displaying it. You can see if you're working with your, you're going into your demo, it's really nice just to be able to type that in and boom, there it is. They can see it all the way across. And we might want to zero in and use like a box plot. And this time we'll go ahead and call the Seaborn, SNS, box plot. And we're going to go ahead and do vehicle size versus engine horsepower XY plot. And the data comes from the car. So if we run this, we end up with a nice box plot. You see our mid-size, compact, and large. You can see the variation. There's our outlier showing up there on the compact. That must be a high-end sports car. Large car might have a couple engines, and again, we have all these outliers and then your deviation on them. Very powerful and quick way to zero in on one small piece of data and display it for people who need to have it reduced to something they can see and look at and understand. And that's our Seaborn box plot, or SNS.boxplot. And then if we're going to back out and we want a quick look at what they call pair plotting, we can run that, and you can see with the Seaborn, it just does all the work for you. It takes it just a moment for it to pull the data in and compile it. And once it does, it creates a nice grid. And this grid, if you look at this one space here, which is, you might not be able to see the small number, it says engine horsepower. This is engine horsepower to the year it was built, and it's just flipped. So everything to the right of the middle diagonal is just the rotation of what's on the left. And as you expect, the engine horsepower gets bigger and bigger and bigger as time goes on. So the year it was built, the further up in the year, the more likely you are to have a heavy horsepower engine. And you can quickly look at trends with our pair plot coming up. And look how fast that was. It took it a couple, moment to process. But right away, I get a nice view of all these different information, which I can look at visually and kind of see how things group and look. Now, if I was doing a meeting, I probably wouldn't show all the data. One of the things I've learned over the years is people, myself included, love to show all our work. We were taught in school, show all your work, prove what you know. The CEO doesn't want to see a huge grid of graphs, I guarantee it. So what we want to do is we want to go ahead and drop the stuff that might not be interested in. And I'm not really a car person. Our guy in the back is, obviously. So you have your engine fuel type. We're going to drop that. We're going to drop market category, vehicle style, popularity, number of doors, vehicle size. And we have the axes in here. If you remember from NumPy, we have to include that axes to make it clear what we're working on. That's also true with pandas. And then we'll look at just what it looks like from the head. And you can see that we dropped out those categories, and now we have the make, model, year, and so forth. And we took out the engine fuel type, market category, etc. And this should look familiar to you now. When you start working with pandas, I just love pandas for this reason. Look how easy it is. It just displays it as a nice spreadsheet for you. You can just look at it and view it very easily. It's also the same kind of view you're going to get if you're working in Spark or PySpark, which is Python for Spark across big data. This is the kind of thing that they come up with, and this is why pandas is so powerful. And we may look at this and decide we don't like these columns. And so you can go in here and we can actually rename the columns. Simple command, car equals car, rename. Columns equals engine horsepower equals horsepower. This is just your standard Python dictionary. So it just maps them out. And instead of having like the lengthy, if here we had engine horsepower, we just want horsepower. We don't need to know it's the engine horsepower. Engine cylinders, we don't need to know that it's for the engine, because there's only one thing we're describing if we're talking about cars, and that's cylinders. And we'll go ahead and just run this. And again, here's our car head, and you can see how that changed. We have model year and horsepower versus model year, engine horsepower, engine cylinders, and just cylinders. Again, we want to keep reducing this so it's more and more readable. The more readable you get it, the better. And of course, we can also adjust the size a little bit, so that when it prints out, instead of splitting it on two lines, we get like a single line. We can do that also. That's just your control mouse up or plus sign you use in Chrome. That's a Chrome command. And if you remember from NumPy, we had shape. Well, pandas works the same way. We can look at the shape of the data. So we now have 11,914 rows and 10 columns. So you see some similarities because pandas is built on NumPy. And questions that come up just like you did in NumPy, we might want to know duplicate rows. And so we can do car. And look at this switch here. We're doing a selection. This is a pandas selection with the brackets. But we want to select it based on car.duplicated. So how many duplicates on there. So it's starting to look a little bit different as far as how we access some of the data on here. This can be a logical statement. And we get the number of duplicate rows. We have 989 rows by 10 columns again. And this is one of those troubleshooting things that we end up doing a lot more than we really feel like we should. We might go ahead and do like a car count just to see how many rows we're dealing with. And then right after that, we might want to go ahead and say, hey, let's drop duplicates. So remember we did all the duplicates on there. So car equals car dot drop duplicates. And then we can print the head again. We'll just do car head here. And you can see the data on there looks the same as before. And just note that we did car equals car dot duplicates. There are commands in here where you can do, where it changes the actual value, and it works on some of them and not on others depending on what you're doing. But by default, it always returns a copy. So when we do this, we're reassigning it to car. And you can see it's the same header, but we want to go ahead and do count and see how the count changes. Let's go ahead and run this. And you can see here, instead of 11,914, we have 10,925. So we've removed about 100 cars that were duplicated, just slightly under 100 there. And then as we're prepping our data, we might want to know car is null. So it's going to count the values of null, and then we want to sum that up. And when we do that, we do the car is null function dot sum. We end up with HP, the horsepower is 69 have null values, and 30 have cylinders have null values. Now, if you don't put the sum at the end, it's just going to return a mask with the true false of is it null or is it not, by 0 and 1. So you're summing up the ones underneath each column. And this, of course, then you have to decide what you're going to do with the null values. There's a lot of different options. It might be that you need to put in the average or means. Maybe you want to put in the median value. There's a lot of different ways to fill it. Usually when you first start out with the data, a lot of them you just drop your null values. And you can see here car.drop NA, which is equal to all. And then we're going to go ahead and count it. And you can see that we've dropped almost another 100 values. So from 10,925 to 10,827. Maybe 75 or so values. So we've cleaned this is really a big part of cleaning data. You need to know how to get rid of your null values, or at least count them and what to do with them. And of course, if we go back to counting our null values, we should now have null values. There we go. And you'll see there's 0 null values. I don't know how many times I've been running a model that doesn't take null values and it crashes, and I just sit there and look at it trying to get, why did that crash? It should have worked. It's because I forgot to remove the null values. So we've been jumping around a lot. We're going to go back to finding outliers. And let's go ahead and bring that back into our Seaborn. And if you remember, we did a box plot earlier. This time we're going to do a box plot just on the price. And you can see here our price value, and we have the deviation with the 2 thinner bars on each side of the main value. And then as we get up here, we have all these outliers. In fact, we have one way out here that's probably a really expensive high-end car is what we're looking at. If you were doing fraud analysis, you would be jumping on all over these outliers. Why are these deviation from the standard? What are these people doing? Again, this is probably, like I said, a really high-end expensive car out here. That's what we're looking at. And we can also look at the box plot for the horsepower. And we'll put that in down here and run that. And you can see again, here's our horsepower, and it just jumps, and there's these really odd, huge muscle cars out here that are outliers. And we're going to jump into making this a little bit more, as you start displaying your data or your information to your shareholders. We're going to look at plotting a histogram for the number of cars per brand. And the first thing we want to go ahead and do is we have with our car, go back over here, here we go. We have our make value counts, largest plot, and we want to do a kind equals bar, fig size 10.5. And right off the bat, we jump up here and we see Chevrolet, it's going against, what was it? It's figure ratio, the value counts, and we want the largest value. So here's our value counts and compared to what the different cars are. Chevrolet puts out a lot of different kinds of cars. I didn't realize that they made that many cars or different types. And then for readability, let's go ahead and add a title, number of cars by make, number of cars and make. If you had looked at this the first time, you would have been like, well, what the heck am I looking at? Well, we're looking at the number of cars by make. And then you can see here, now we're talking about the type of cars and the different ones were put out. Lotus, I guess, only had a few different kinds of cars over there. very high-end cars. And then as doing data analytics and as a data scientist, one of the things I am most interested in is the relationship between the variables. So this is always a place to start. We want to know what's going on with our variables and how they connect with each other. So the first thing we're going to do is we're going to go ahead and set a figure size because we want to make sure it fits our graph. We'll just go ahead and set this one plot figure set to figure size 2010. If you never used the matplot library, which is sitting behind Seaborn, whatever is in the PLT, this is what's loaded. It's like a canvas you're painting on. So the second you load that pyplot as PLT, anything you do to that is affecting everything on it. And then we want to go ahead, since we're using Seaborn, we'll go ahead and create a variable C for relationships or correspondence, and car.corr, that's a correlation in Seaborn on top of pandas. Again, one line and you get the whole correlation on there. And because we're working with Seaborn, let's put it into a nice heat map. If you're not familiar with heat maps, that means we're just using color as part of our setup. So we have a nice visual. And we can see here that the Seaborn connected to the pandas prints out a nice chart. We'll talk a little bit about the color here in a second. It prints out a nice chart. This is a chart I look at. As a data scientist, these are the numbers I want to look at. And we'll just highlight one of them. Here's cylinders versus horsepower. The closer to 1, the higher the correlation. So 0.788. Pretty high correlation between the number of cylinders and how heavy the horsepower is. I'm betting if you looked at the year versus horsepower, we can just look at that one. Here's year and horsepower. 0.314, not as so much, but if you combine them, you don't actually add them. But if you combine them, you'll start to see an increase in horsepower per year and cylinders. You could probably get a correlation there. And just like 0.78 is a positive correlation, you might notice if we look at cylinders, or let's look at horsepower and mileage. So if we go here to horsepower to mileage, you get a nice negative. We'll do cylinders, that's a bigger number. With cylinders to the miles per gallon, it's a minus 0.6. So it's a negative correlation. The closer to -1, the more the negative correlation is. And then the chart you would actually show people is a nice heat map. This is all our colors, and it's just those numbers put into a heat map. The darker the color, the higher the correlation. You can see straight down the middle, obviously the year correlates directly with the year, horsepower with horsepower, and so on. That's why it's a 1. The closer to the 1, the higher the correlation between the two pieces of data. Now, this is a good introduction. Pandas goes way beyond this. Most of the functionality in NumPy, since Pandas sits on it, is also in Pandas, and then it even has additional features in it. And we use Seaborn pretty extensively sitting on top over our pyplot. So keep in mind that our pyplot has a ton of other features in it that we didn't even touch on in here. We couldn't, even if you had a sole course in it, there's just so many things hidden in there depending on what your domain you're working on. But you can see here, here's our Seaborn and here's our matplot library. That's all our graphics that we did. And then the Seaborn worked really nicely with the pandas. We really like that.
In the world of data science, Python stands out for its ease of use and powerful data analysis capabilities. Reflecting on the 2023 Stack Overflow Developer Survey, Python's popularity is unmatched, especially among data analysts and scientists. Consider the success story of Anna, a data analyst whose expertise in Python's pandas and NumPy libraries led to the development of a predictive model that significantly influenced her startup strategy. This example highlights Python's practical application in extracting meaningful insights from data, a skill highly valued in the industry. As you gear up for a Python data analyst interview, it's crucial to demonstrate not only your technical mastery of Python, but also your ability to apply its functionalities to real-world problems. This guide focuses on essential interview questions and answers, drawing from real-life applications and challenges to prepare you for what lies ahead. Through understanding practical use cases like Anna's, you will gain insights into the impactful role Python plays in data-driven decision-making. So, we will start with the first question, that is, what is Python and why is it preferred for data analysis? So, Python is like a versatile tool that's not only easy to use but also powerful enough to tackle big projects. It's a programming language, which means it's a way for us to write instructions that a computer can understand and execute. What makes Python special is how it combines simplicity and power. It's as if the tools in this section of the supermarket are designed to fit comfortably in your hand and work exactly as you expect, making your job easier. So here I will be giving you an overview of the answers you can provide to the interviewer in the interview. So now you might wonder, why do people working with data love shopping in the Python section so much? So let's consider some points for that. That would be easy to learn. So Python's simplicity means you can learn how to use it quickly even if you are never programmed before. It's like learning to cook using recipes that requires only a few ingredients. Then comes versatile toolset. Python offers a variety of tools known as libraries, specifically designed for data analysis. Imagine having a Swiss Army knife but for data. These tools can help you clean, sort, analyze and visualize data all in one place. Then we have community support. So there's a huge community of people who use Python for data analysis. So if you ever get stuck or need advice, there's a good chance someone has been in your shoes and can help. It's like having a group of friends who are always there to lend a hand. And then comes integration and automation. So Python makes it easy to automate repetitive tasks and integrate your data analysis work into larger projects. This can save you a ton of time and effort, allowing you to focus on the fun parts of your project. Then comes the in-demand skill. Because so many businesses rely on data to make decisions, knowing how to analyze data with Python is a valuable skill that can open doors to exciting job opportunities. So this is how you can answer the interview about why is Python preferred for data analysis. So moving to the next question, that is explain the difference between a list, tuple and dictionary in Python. So I will give you an overview. You could use this or just mold it to your language and provide the answer to the interviewer. So when discussing the structures, that is list, tuple and dictionary in Python, it's like looking at different ways to organize information. Each serves a unique purpose. Lists are akin to an adjustable shelving unit. You can add, remove or change the items on freely. It's ordered, meaning you can refer to each shelf by its position. For example, you could see an example here, that is my underscore list, and we have put pencil, notebook and eraser in the list. So it allows you to manipulate the contents as needed. Now coming to the tuples, so tuples resemble a fixed display case. Once you have arranged your items inside, their order and presence are set. You cannot change them. This immutability is useful for ensuring that certain data remains constant. So you could see the example. So I have changed the example. So you could see here that my tuple has pencil, notebook and eraser. So it signifies data that you don't intend to alter. Now coming to dictionaries, so they are like a flying cabinet or the filling cabinet with labeled folders. Each folder or key holds specific items values, making it easy to locate what you need quickly without concern for the order in which you added them. So you could see an example, that is my underscore dictionary that has pen and it is pointing out for the blue, then book that is pointing out to mathematics. That provides a way to access items directly by their label or key. Now moving to the next item or the next question, that is how do you handle missing values in a pandas data frame. So when working with data in Python using pandas, it's common to encounter missing values. Think of missing values like puzzle pieces that are lost. To complete the puzzle or analyze your data, you need to decide what to do with these missing pieces. So strategies to handle missing values. The first one will be remove. So if the missing value is like a lost puzzle piece that isn't crucial, you can simply remove that row or column. This is straightforward but can lead to losing valuable information if not done cautiously. For example, you could just use df.drop_na. So this is how you could use it. Now coming to the next option, that is fill in. So if you think of the missing piece as something you can guess or approximate, you can fill in the missing value with a guess. This could be the average of the ordered pieces, the most frequently appearing piece or a placeholder like 0. For example, you could use df.fill_na and you could pass the value inside it. So the choice between removing and filling in depends on your specific dataset and what you are trying to achieve. If maintaining the integrity of your data without the missing pieces is crucial, filling in might be the best option. If the presence of incomplete data could skew your results, removing those entries might be safer. So this is how you could tackle this. Now moving to the next question, that is, what are lambda functions in Python and where would you use them? So imagine you are in the kitchen about to make a quick snack. You could pull out a big food processor for a small job, but sometimes it's easier to use a simple knife. In Python, lambda functions are like that handy knife, a quick one and a one-time tool for small tasks. So let's understand the lambda function. Lambda functions are small anonymous functions defined within the lambda keyword. They can have any number of arguments but only one expression. Perfect for when you need a simple function for a short period. You could see the syntax, that is basic form, lambda arguments, expression. Now we'll see its examples of use. Number one is sorting. Imagine you have a list of names with their ages and you want to sort them by age. Lambda function makes this simple. So you could see the code here, that is sorted, and under we have passed list, key equal to lambda x x of 1. So this is how you could do that. Then comes the quick calculation. So you need to quickly apply a mathematical operation like squaring a number without writing a full function. So you could have a example here. So this is how you could have a square of a number. So when to use lambda functions? So now we'll see when to use lambda functions. Number one is short one-time use. That is ideal for when you need a function once or in a limited scope. And number two would be simplicity, when the operation is simple enough to be expressed in a single line. And then comes the inline operations, that is useful for inline operations that requires a function. So let's move to the next question, that is question number 5. And the question is, demonstrate how to use list comprehension to simplify code that generates a list of square for all even numbers from 0 to 10. So imagine you are tasked with creating a beautiful garden path using square stepping stones. However, you only want to use stones that fit certain criteria, such as being even numbered in size. In Python, list comprehensions offer a concise way to create this path with just the stones you need. So let's understand list comprehension. So list comprehension provides a succinct way to create list. They combine a loop, conditionals, and the list operation into one line. It's like selecting specific items based on criteria to create a new collection. And now we'll see the basic syntax for that. That is, in the form, you will write the expression for item and then the iterable and if condition. So let's see an example. So we'll create a list of square for all even numbers from 0 to 10. So first we'll do this with the traditional approach. And here we have an array, and then we'll use the for loop and then if statement, and then we'll append if the number is even, we will square it. Now coming to the list comprehension approach, so you could see the expression here. So first is the condition, then the for loop, and then the if conditional. So this is how the list comprehension works. So now we will discuss about the key points of list comprehension. So the number one is efficiency. So list comprehensions make your code more readable and efficient. Number two is simplification. They simplify multiple lines of code into a single readable line. And then comes versatility, useful for filtering items or applying operations to elements. And now coming to the next question, that is 6th one. Explain the concept of deep and shallow copy in Python. So imagine you have a magical notebook. Whatever you write in it also appears in a linked notebook. If you have a shallow copy of the notebook, changes to the content like adding a new page in one will show up in the another. However, if you change something on a page already existing in both notebooks, only the original notebook's page is affected. A deep copy is like having two completely independent magical notebooks. Whatever you do in one notebook, whether adding new page or changing existing ones, doesn't affect the other notebook at all. So let's understand shallow copy and deep copy. So shallow copy creates a new object but does not create copies of nested objects found within. Instead, it just copies the reference to these objects. So changes to nested objects in the original or the copy will reflect in the other. So you could see an example for that, that is import copy, and then we have the original list, and the shallow copied list is equal to copy.copy of the original list. Now moving to the deep copy. So it creates a new object and recursively copies all objects found within the original object, nested objects included. So changes in the original or the copy do not affect each other at all. So let's see the example, that is deep underscore copied underscore list equal to copy.deep copy, and inside we have passed original list. Now we'll discuss about the key points. So shallow copy, that is good for saving memory when creating copies of large objects where nested objects aren't modified. And about the deep copy, so it used when you need a fully independent copy of an object, including all nested objects. So this was about deep copy and shallow copy. Now moving to the next question, that is, what is PEP8 and why is it important in Python programming? Imagine you are playing a game where everyone agrees on certain rules to make the game more fun and fair for everyone. In the world of Python programming, PEP8 serves a similar purpose, but for writing code. PEP8 stands for Python Enhancement Proposal 8, and it's essentially a set of rules and guidelines for formatting Python code. So let's understand PEP8. So PEP8 is like the rule book for Python code style. It covers recommendations on how to format your code, such as how to name variables, how to indent your code, and other best practices. Think of it as the etiquette for Python programming. Ensure that everyone writes code in a consistent and readable way. And let's discuss why PEP8 matters. So the number one reason is readability. Just like a well-organized book is easier to read, code that follows PEP8 is easier for humans to understand and read. It's about making your code not just functional but also presentable and approachable. Then comes collaboration. When everyone uses the same style guide, it's much easier to work on projects together. This consistency removes confusion and helps prevent errors that arise from misinterpreting the code. And then comes maintenance. So code that's easy to read and understand is also easier to maintain and update. If your code follows PEP8, anyone including future you can quickly understand and modify it as needed. So following PEP8 is like keeping your code's desk clean and organized. It makes your Python programs more enjoyable and easier for you and others to read and work on, just as playing a game is more fun when everyone knows and follows the rule. Coding in Python is more effective and enjoyable when everyone adheres to PEP8. So this was about PEP8. Now moving to the next question, that is, describe how to perform a merge operation between two pandas data frames. So imagine you are at a dinner party and you have two guest lists. One list has the names of guests and their favorite dishes. The other list has names with their preferred drink choices. To plan your dinner menu, you need to combine these lists into one. So you think each guest food and drink preferences side by side. In Python's pandas library, this combining of lists or tables is called a merge operation. So let's understand merge in pandas. So first we'll see pandas. So it's a powerful library in Python for data analysis and manipulation. And merge operation is like joining two tables based on a common column, like guest names in our example, so that you can see all the information in one place. So let's see the steps to perform a merge. Number one step is identify the common key, that is, find the column common to both data frames such as guest name. Then choose the type of merge. Decide how you want to combine your list. Do you want to include all guests, only those present on both lists, or some other criteria? And then use the merge function. Apply pandas merge function to bring your data frames together based on your criteria. You could see the example here. That is, first we will identify the common key and then we'll choose the type of merge, as you could see, like outer join, inner join, or both the criterias. And then we have used the merge option. So this is done. That is to perform a merge operation between two pandas data frame. Now moving to the next question, that is ninth question, and that is, can you explain what NumPy is and how it is better than a regular list in Python? So imagine you have a toolbox. In this toolbox you have a regular hammer, that is Python's list, and a power hammer, that is NumPy. Both can drive nails into a board, that is perform numerical operations, but the power hammer does it faster and with less effort, especially when you have a load of nails, large dataset. NumPy stands for Numerical Python, and it's a library especially designed for numerical operations. It introduces an object called an ND array, that is n-dimensional array, that is more efficient than Python's regular list for a few reasons. Now we'll see those reasons. Number one is performance. So NumPy arrays are stored at one continuous place in memory, allowing faster access in comparison to list. So this means operations on NumPy arrays can be done much quicker than on list. Then comes functionality. NumPy comes with a vast library of mathematical functions that can be performed on arrays, making it incredibly powerful for scientific computing. And then comes memory efficiency. A NumPy array is more memory efficient than a list, allowing you to work with larger dataset. So this is why NumPy is better than a regular list in Python. Now moving to the next question, that is, how do you improve the performance of a slow running Python script? So imagine you are in a race with a backpack full of tools you think you might need. As you run, you realize the backpack is slowing you down. So to speed up, you would streamline your backpack, carrying only what's essential and being organized for quick access. Optimizing a Python script follows a similar principle. So here's how. Number one is profile. before optimizing. First, find out where the heavy items are. Use profiling tools to identify the slow parts of your script. It's like checking your backpack to see what's making it too heavy. Then you can use efficient data structures. Some data structures are faster than others for certain tasks. It's like choosing a lightweight, compact multi-tool over carrying separate tools for each job. You could leverage NumPy for numerical tasks. If your script does a lot of mathematical calculations using NumPy, as we discussed earlier, you can significantly speed things up, similar to swapping out a manual tool for a power tool. And then you could avoid global variables. Accessing global variables is slower than accessing local ones. It's akin to having the tools you frequently use in an easily accessible pocket rather than in the bottom of your backpack. And you could use built-in functions and libraries. Python's built-in functions and standard libraries are optimized for speed. Using them instead of custom solutions can be like using a well-paved road instead of hacking your way through the jungle. And then you could use limit of loops. So loops, essentially nested ones, can slow down a script. Where possible, use Python's list comprehensions or NumPy's vectorized operations. It's like choosing a path that goes directly to your destination instead of wandering around. So by focusing on these strategies, you could significantly improve the speed of your Python script, making your coding race more of a sprint than a marathon. Now moving to the 11th question, that is, what is the purpose of the group by function in pandas, and provide an example of its use. So let's say you have a big box of crayons sorted by color. You want to count how many crayons you have in each color. In Python's pandas library, the group by function helps you do exactly that with your data. So the group by function groups data in a data frame based on a certain criteria, like how you might group crayons by color. So once grouped, you can apply functions to each group independently, such as counting them, summing up values, or calculating averages. So here how it works. Number one is group. So the first group by that separates the data into groups based on your chosen criteria. It's like sorting your crayons into groups of the same color. Now coming to the apply, so next it applies a function to each group. This could be calculating the average, sum, count, etc. If we are sticking with the crayon analogy, this is like counting how many crayons you have in each color group. And then comes combine. Finally, it combines the results into a new data frame. You end up with a summary of your original data organized by the grouping criteria. So it's like having a neat list that tells the count of each color of crayons. So now moving to the next question, that would be 12th. So how can you create visualizations using Matplotlib or Seaborn? Provide an example. So imagine you have just taken a beautiful hike and you want to share the experience with your friends. You could describe every detail in words, or you could show them a photo that captures the essence of the adventure. In data analysis, Matplotlib and camera and filters for data, allowing you to create visual representations that capture the insights from your dataset. So talking about Matplotlib, that is the camera. So Matplotlib is a plotting library in Python that allows you to create a wide range of static, animated, and interactive visualizations. Think of it as your camera for data visualization, giving you the tools to create basic graphs like line charts, bar charts, and scatter plots. And then comes the Seaborn. But before that, you could see the example here, that is import Matplotlib as PLT. Then we have X and Y, and they have the numbers there, and then you could plot the graph there. And then comes the Seaborn, the filters. So Seaborn is built on top of Matplotlib and provides a high-level interface for drawing attractive and informative statistical graphics. So Seaborn is like adding filters to your photos, making your visualization more aesthetically pleasing and easier to interpret with less code. And you could see the example here, that is import Seaborn as SNS, and then you could set the theme and the line plot. Now coming to the next one, that is 13th question. So now guys, let's understand overfitting. So overfitting occurs when a machine learning model learns the details and noise in the training data to the extent that is performs poorly on new data. It's like memorizing the answers to a test rather than understanding the subject. And now we'll see how to prevent overfitting. So number one is use more data. So having more data can help the model learn better and generalize well. It's like learning more about types of fruit to improve your overall understanding. Then comes simplify the model. Sometimes using a simpler model can prevent overfitting. This is akin to focusing on the basic characteristics of fruit, like color and shape, rather than memorizing every spot on the apple's skin. And then comes cross-validation. This technique involves rotating the dataset through training and validation phases. It's like practicing with different sets of fruit every time to ensure you really understand them, not just memorize them. And then comes regularization. So this technique adds a penalty on the more complex features of the model. Think of it as discouraging the model from paying too much attention to the less common characteristics of the fruit, and then comes early stopping. During training, if you notice that your model's performance on a validation set starts to worsen, stop the training. It's like realizing you are starting to focus too much on the details that don't matter and stopping your studying to refocus. And in conclusion, overfitting is like studying too hard on the specifics and missing the big picture. By using strategies like gathering more data, simplifying your model, and practicing with cross validation, you can help your machine learning model to learn better and be more adaptable. Just like a well rounded student who understands the essence of the subject, not just the details. Now, moving to the next question, that is 14th. Describe a situation where you had to clean a large dataset, and what steps did you take? So, imagine you have just been given a giant old attic full of various objects to organize and clean up. Some items are valuable and need to be kept, some are duplicates, and others are just plain junk. Cleaning a large dataset in Python is somewhat similar. You are aiming to tidy up the data so that it's useful for analysis. So, we'll see the steps for cleaning a large dataset, that is, remove duplicate data. That is just like removing duplicate items in the attic that you don't need more than one of. In datasets, duplicates can skew your analysis. So for that, we'll use the action as we have seen the number one step, that is remove duplicate data, and we'll see the action, that is we will use dataframe.drop underscore duplicates in pandas to remove them. And then we can use another method, that is handle missing values. So imagine finding boxes that are supposed to contain items, but some are empty. You decide whether to fill them, label them as empty, or remove them altogether. For that, we could do the action, that is options include dataframe.fillNA to fill missing values, or dataframe.dropNA to remove rows or columns with missing values. And then we have correct data types. Sometimes objects are stored in the wrong boxes. Similarly, a numeric column might be incorrectly formatted as text. So for that, we'll use dataframe.asType to correct data types. And then we have standardized the data, ensuring everything is organized and labeled consistently, like making sure all book titles follow the same format. For this action, we will apply functions to clean and standardize text, numbers, and dates. And we have remove or correct outliers. If you find something completely out of place, like a snowboard in a box of summer clothes, you decide if it's an error or if it should be stored somewhere else. So the action we can use is use statistical methods to detect outliers and decide whether to keep, adjust, or remove them. And in conclusion, cleaning a large dataset involves removing unnecessary parts like duplicates and outliers, filling in gaps, that is missing values, and organizing, correcting data types, and standardizing. It's about making sure the data is accurate, consistent, and ready for analysis, just as organizing and cleaning the attic that makes it easier to find and use what you need. Now moving to the next question, that is 15th. How do you split a dataset into training and testing sets using scikit-learn? Imagine you are preparing for a magic show. Before performing in front of a live audience, you practice your tricks with a friend to get feedback. Similarly, when you are working with machine learning models, you need to practice or train your model on a portion of your data and then test it on another portion to see how well it performs. So this process helps ensure your model can perform magic with new, unseen data, not just the data it learned from. So we'll see using scikit-learn to split data. So scikit-learn is like your magic kit for machine learning in Python. It has a tool called train_test_split that makes dividing your data into training and testing sets a breeze. So we'll see the steps to split your dataset. Number one is prepare your data. Gather your dataset. It's like getting all your magic props ready for the show. Then import the tool. Bring the train_test_split function into your project. And then we have split the data. Decide what portion of your data you want to train on and what portion to test on. The common split is 80% for training and 20% for testing. And you could see the code here. And here X represents your features, that is the information you use to make predictions, and Y represents your target, what you are trying to predict. And then we have text size equal to 0.2 that tells the function to reserve 20% of the data for testing. And in conclusion, splitting your data set into training and testing sets is a crucial step in the machine learning process. It's like rehearsing your magic tricks before the big show, ensuring your model is well prepared to amaze with its prediction on the new data. Using scikit-learn's train_test_split, this process is simple and straightforward, allowing you to focus on perfecting your model's performance. That is 16. Explain the difference between supervised and unsupervised learning with examples. So imagine you are learning to paint. In supervised learning, you have an instructor who gives you a picture to paint and guides you, telling you when you are putting or getting it right and where you need to improve. So this is like having labeled data in machine learning, where you know the correct answers or labels for your training data, and you are trying to predict those answers for new data. So in supervised learning, however, it's like you are given brushes and paints, but no pictures to replicate and no instructions. You are free to explore and create patterns or structures on your own. In machine learning, this means working with data without predefined labels, and the goal is to identify patterns or groupings within the data, such as clustering similar customers together. So key points are here are supervised learning. You have labeled data, and the goal is to learn a mapping from inputs to outputs. And examples include regression and classification problems. So now moving to the key points for unsupervised learning. That is, you work with unlabeled data, and the goal is to discover underlying patterns or structures. Examples include clustering and dimensionality reduction. Now moving to the next question, that is 17th question. And what are the main steps in a machine learning project? So embarking on a machine learning project is like planning a journey. You need a map to guide you through different terrains and landmarks. And here's how this journey typically unfolds. Number one is define the problem. So first figure out your destination. What do you want to achieve with your machine learning model? And this step is about understanding the problem you are trying to resolve. For second point, gather and prepare data. So next, pack your backpack. You need data for your journey, collects data for your problem, and then clean and pre-process it to make it useful for training a model. Then choose a model. Now choose a model of transportation. Different models like decision trees, neural network, etc. have their strength and are suited for different types of problems. And then train the model. Time to hit the road. Training a model is like teaching it the rules of the road. You will feed it the data you prepared earlier, allowing it to learn from it. And then evaluate the model. Check your map and compass. How well is your model performing? Use separate testing data to evaluate its accuracy and make sure it's learning correctly. And then fine tune the model. So find the best route based on the evaluation, adjust your model's parameters or approach to improve its performance, and then deploy the model. You have reached your destination. Once your model is trained and fine tuned, you can deploy it to start making predictions or insights on new data. And then we can monitor and update. That is, keep an eye on the road conditions. Over time, your model might need adjustment or retraining as it encounters new data or as the underlying data patterns change. So this is about the main steps in a machine learning project. Now moving to the next question, that is, how do you evaluate the performance model? So imagine you have baked a batch of cookies for the first time. To know if they are good, you need people to taste them and give you feedback. Similarly, after you have trained a machine learning model, you need to evaluate its performance to see how well it's doing for its job, like predicting outcomes or classifying data. So the steps would be, number one is accuracy. So this is like asking, out of all the cookies, how many were just right? In classification problems, accuracy measures how often the model's predictions are correct. And then confusion metrics. Imagine a chart showing the types of feedback, too sweet, just right, too bland. A confusion matrix helps you understand not just the successes, but also where and how the predictions went wrong. And then comes precision and recall. Precision asks, of all the cookies we labeled as just right, how many truly are just right? Recall asks, of all the cookies that are actually just right, how many did we correctly identify? It's about being correct when you say it's right and finding all the right ones. And then comes F1 score. Sometimes you want a single number to balance precision and recall, especially if you have unsure which one is more important. The F1 score is like an overall grade for your cookies that considers both taste and appeal. And then comes ROC curve and AUC. Imagine plotting a graph showcasing your cookie making attempts, balancing how adventurous you are with flavors against the mistakes you make. So the ROC curve plots true positive rates against false positive rates, and the AUC, area under the curve, gives you a single measure of how good your model is across different thresholds. Now moving to the next question, that is, provide an example of using SQL in conjunction with Python for data analysis. So imagine you are a detective trying to solve a mystery. You have a huge room full of file cabinets, your database with information of various cases. Now you need a smart, efficient way to find exactly what you are looking for without rummaging through every file by hand. Here's where Python and SQL join forces to help you out. So the Python and SQL, the detective duo. So SQL is like your search tool for query of the database directly, pinpointing the exact information you need, such as details of a specific case. And you know Python, that is like your assistant detective. that helps you to analyze the information, draw insights, and present them in a way that's easy to understand. So now we'll see a simple scenario. You are interested in finding out the number of cases solved each month to see when your team was the most effective. So use SQL to retrieve data. So you write a SQL query to extract the number of cases solved by month from your database. So you could see how we have written here, that is select month and count as case solved, and from case files where status is equal to solved, group by month. So now we will analyze and visualize with Python. So you use Python to connect to the database, run your SQL query, and then use libraries like pandas for analysis and matplotlib or seaborn for visualization. So you could see here that we have imported pandas and matplotlib, and then we have connected the SQL here, and then we have run the SQL query and load into a data frame, and then we have plotted the graph. So you could see the example how we have used SQL in conjunction with Python for data analysis. Now moving to the next question, that is 20th question, and how do you handle error handling in Python? And can you explain the use of try, except, and finally blocks? So let's dive in. Imagine you are walking through a forest on a path you think you know well. Suddenly you find a tree that has fallen across your path and you need a plan to deal with the unexpected obstacle. In Python situation, this is like running into an error in your code. So the try, except, and finally blocks help you navigate these unexpected errors gracefully. So the try block, this is where you walk along your planned path. You place the code that you think might cause an error inside the try block. It's like saying, I will try to go this way, but there might be a tree in my path. And then we are coming to the except block. So if you encounter a fallen tree, an error, the except block is your alternate route. This block catches the error and lets you handle it, preventing the program from crashing. You can specify different types of trees to look out for and different detours. So you could see the example here, that is try walking the path, except, oh no, a tree, take a detour. So you take a detour from here. And then we have the finally block. Whether you encountered a tree or not, the finally block is like reaching the end of your work and taking a moment to reflect. So this block runs no matter what. Even if there was an error, it's often used for cleanup actions like closing a file or releasing resources. So you could see the code here, that is finally relax at the end.
Thank you for joining the Data Analytics full course by Simplilearn. By completing this course, you have taken a significant step towards rewarding career in data analytics. With the high demand for data experts in 2024, you are now well prepared to land a top job in the field and enjoy a lucrative salary.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.